Okay, great.
All right. Good morning, everyone. Hello. Thank you so very much for coming back. That was the second day of PyCon Italy 2023. It's my extreme pleasure to introduce Marlene this morning. She is fantastic. You might know her already, but let me just give a brief introduction of her. She was previous vice chair of PSF, Python Software Foundation. She is currently serving as vice chair of ACM Practitioner Board. She's also a founder of PyCon Africa, and Zimba Pi is a non-profit organization to support women into programming and computer science. That is fantastic. Thank you very much for your efforts. We'll be hearing her talking about transcendence this morning, but I don't want to steal any more time with me blubbing, so please give her a warm round of applause.
Can you hear me okay? We can hear me okay, I think. Okay. Hi, everyone. Like Valerio said, my name is Marlene. And yes, today I'm going to be speaking to you about the topic of transcendence and the power of representation. So the word transcendence is not a word that we are hearing every day. There was a movie a few years ago called Transcendence with Johnny Depp in it. It was a very creepy movie. Would not recommend, actually. But I'm not sure if anyone liked the movie. I don't know. But hopefully, as I continue this talk, you'll get a better understanding of why I decided to use this word transcendence to describe the power of representation. So before we get started, I'll just share again a little bit more about me. I am from Harare, Zimbabwe. Zimbabwe is a country in the southern part of Africa. It's just above South Africa. It's a very interesting place, Zimbabwe. We had a coup a couple of years ago. The military came on the TV and they said, we have the president. And so that was interesting. But there are other things in Zimbabwe, like Victoria Falls, that are very nice and not as controversial. And it's a really great place for tourism and animals and things like that. So if you are ever thinking of visiting Africa, I can recommend it when there's no coup happening. So something else about me is that I work for a company called Voltron Data, and we do a lot of things with developer advocacy. I'm a developer advocate. We do a lot of things with Apache Arrow. And there are a couple of people actually here at the conference from Voltron Data. So there they are, actually. Shout out to the team from Voltron, exactly. And we work remotely from different parts of the world, so it's been nice to see them here in person. And like Valerio mentioned, I am the previous vice chair of the PSF, and I founded an organization called Zimba Pi that gets women in Zimbabwe excited about coding in Python. So getting into the talk now. When we have this idea of transcendence, I think a good place to start to understand what it means is looking at the world of sports. So I'm going to just play a quick video clip for us to help us understand what transcendence means. Let's hope that plays. Okay. Interesting. So this was a clip on the screen from the UK, and this is a scene where people are watching football. I'm going to explicitly say football because I said soccer at another European conference, and people were very offended. So I'm going to say football. Anyway, the football that happens in Europe is actually very popular all around the world, even in Zimbabwe. I remember growing up, I'm not a very big fan of football, but my brothers would be like randomly shouting like AC Milan or FC Barcelona or something like that. So these scenes that we just saw on the screen are something that happens in a lot of different countries. And so as I've grown up, I mentioned I'm not a big fan myself of football, but whenever I saw scenes like this, I would ask the question, what exactly is going on here? Like, why are these people being so emotional about what's going on, the football itself? Well, this is actually something that has been studied by a number of different institutes across the years. No. Second screen. So a few years ago, the New York Times published an article titled "Sports Psychology, It Isn't Just a Game." And researchers from this article found that many fans, while they're watching a game that they're interested, become so tied to their teams that they experience hormonal surges in the same way or just as much as the athletes playing in the games did. So this quote from the article is by a professor called Robert Cialdini, and he says, "Our sports heroes are our warriors. This is not some light diversion to be enjoyed for its inherent grace and harmony. The self is centrally involved in the outcome of the event. Whoever you root for represents you." And another professor from this article is quoted, and he says, "The results suggest that fans empathize with the competitors to such a degree that they mentally project themselves into the game and experience the same hormonal surges that the athletes do." So I think this is super fascinating to me. And here we have this human experience where just by watching someone who inspires us, we can transcend our physical bodies and mentally project ourselves, and we can start to experience these hormonal changes in the same ways that athletes do. So I think this is just incredible. And when I was reflecting on this a bit more myself, I tried to think where I've personally experienced this feeling of transcendence. So I actually thought about this woman. Does anyone know Serena Williams in the house today? Serena's amazing. And she recently retired from tennis, so that was devastating news for me. But she had such an amazing career, and when I was growing up, my dad was actually very into tennis. And I clearly remember this one morning where we were all sitting together. We would sometimes on Sundays come together, and we would sit together and watch the tennis matches. And so Serena was playing at Wimbledon that day. And I remember being so nervous for her. She was about to hope, I really wanted her to win the finals. And I think with every stroke she was doing, my breath was held and I had adrenaline pumping through me. And ultimately she won that game. And at the end of that, I thought to myself, actually, I am Serena Williams myself. I pretty much look exactly like her. And all I need to do is just work a little harder, and I am going to be the next Serena Williams. So after watching this game, I decided to really get a bit more dedicated in my tennis career. So I started practicing every day, and I told my parents to try and buy me new things to help me be a better tennis player. And I actually got much better at tennis from watching Serena, and ultimately I ended up being the captain of my tennis team. Of course, I didn't end up going to Wimbledon, but that's my parents' fault because they didn't really invest in my talent. They couldn't see it for what it was, so that's on them. But absolutely, the main reason why I got into tennis was because of having this experience of watching Serena play tennis. So there are three main things that I think this idea of transcendence can teach us about the power of representation and why it matters not only in sports, because of course this is not a sporting conference, this is a tech conference, a PyCon conference specifically, and I'll go ahead and share some of those things with you this morning. So the first thing that I think this teaches us, or the power of representation and transcendence teaches us, is about inclusion. So I think when we are thinking about inclusion, one quote that I really like is by a lady called Mary Ann Wright Altman, and she says, "You cannot become what you cannot see." And I think it's very hard. You know, it might be possible. Like I gave this talk once and I was like, oh, it's not possible to become what you can't see. And some guy came and he was like, it's possible because I became a computer scientist and I had never seen someone who was a computer scientist. So it's very hard. It's possible. But it's very hard to become something that you actually can't see. So for me, for example, it would have been very difficult to think to myself, I'm going to go to Wimbledon, I'm going to be this amazing tennis player if I'd never seen someone playing tennis. And I think it's even harder to imagine yourself as well if there's no one that represents you or looks like you playing that game. So one example that we can think about is ice hockey. Has anyone heard about ice hockey before? Do we know what this is? Ice hockey is like a game where you play hockey on the ice. And for me, I never knew about ice hockey. I grew up in Zimbabwe. We don't have snow. We don't have an ice rink. And then one day, I actually ran into some Canadians. And they were talking about ice hockey. And they were very passionate about this. And I remember just being there and being like, I really can't relate to you at all because like I've never seen this game being played before. And so for me, in general, I didn't even looking at the ice hockey players today and seeing what they look like, I'm just like, I really don't belong there. Ice hockey is not for me. And so when we think about representation and when we think about inclusion, one of the major things that I think is important is to represent different demographics, whether that's women or different races or different spheres, which I'm going to talk about just now. So I think it's important that we have people who represent different groups in positions that are visible and in positions of leadership as well. So we have representation at all levels. So one of the things that I think when we bring this back to the world of technology, when I think of the companies that represent, doing tech at the highest level possible, one of the companies that comes into my mind is Google. And I know, people have mixed feelings about Google, but it's a very big company. It has 190,000 employees around the world. And I decided, for me, usually when I am thinking about sort of representation and inclusion, because I am a Black person and I'm also a woman, those are specific things that feel important to me or that feel relevant to me. So something that Google has been doing since 2014 is publishing an annual report about their company demographics. And even more recently, they published this report, or the data for this report, on Google BigQuery through their public datasets platform. And honestly, kudos to Google for doing this. Like, I wish more companies would do that. Now, for me, I wanted to imagine, and let's imagine in this room right now that you are all Marlene, and you're this amazing Pythonista from Zimbabwe who's involved in all of these things. And we want to find out, as Marlene, do you see yourself represented at Google? Can you go to Google or apply to Google and feel that you belong at Google? So to be able to understand this, let's take a quick look at some code. I am going to hopefully drag my other screen. Let's try and drag this out. Oh, it's on that side. Let's drag this to the side. And we are going to drag my code editor here. So I have a copy of this notebook because I'm going to try to run the code for us step by step. But running code in a live demo session is always, precarious. And so it might not work. So if it does, we will switch over to the copy version of this notebook. So what we're going to do first, we are using a library called IBIS. And we're connecting to the BigQuery database. We're specifically connecting to the Google DNI dataset that's hosted there. So they have a number of different tables in this dataset. And, oh, I wonder if we can, OK, it's moving, but at a very slow pace. Oh, it's moving? OK, great. So let me go to the side here and try and See, if I try to do anything with code in real time, it's wild. But anyway, they have all of these tables that are there in the database. And, sorry, it's taking a long time to like respond. Okay, there we go. So anyway, here's the code, the piece of code that I want you to see. The first thing I'm going to do is run this table, and so that we can get a look at some of the data that's available in the data set. So they have a workforce column that lets you know specifically which role that someone plays in Google. So whether they work in tech, they also have leadership data. They have data about hiring. They have data, different data. So this is a very interesting data set. They have the report here whenever this information was collected. Then they group the employees by race, and they also group them by gender. So I specifically use this table because it also includes the gender demographics as well globally. So we're looking for here, I am running a query, and I'm doing group by, and I'm taking the report here, I'm taking the workforce and the gender of women globally. I'm also taking the race, and I'm making the year 2023. So I'm doing a bunch of things, and I'm also making the different columns into a percentage. So we can see the data there. So when we look at the data here, we can see the number of women that are working in Google. So we're specifically getting the gender. We're isolating women in the company globally. So this is actually pretty good. In non-tech roles, they have 53% of Google's non-tech roles are women. 32% are leaders. I'm not sure what the tech old thing represents, but in tech specifically, 25% of their workforce is women globally. And then when we isolate this and bring this down and we say, okay, what part of this workforce is black? When we look at the people in tech that are black, we have 4% of that group being black. And then now if we aggregate everything together and we say we want to get the percentage of women, and we want to get the percentage of black women specifically, we get 1% of the people working globally in Google are black women working in tech. And we can visualize this over time as well. So I'm going to try and run this cell here with matplotlib to visualize that data. And yes, it worked. So we can see that over time, this has gradually been increasing in terms of the percentage of women globally that are working in tech, specifically at Google. And that percentage of women is about 1%. I actually have the actual image here in my slides. So we're going to go back to the slides where it's a bit safer. And I don't know how to minimize this now. How do we minimize it? You see, if you do anything with code. Swipe to the side. Anyway, I'm going to try and put this one over here and see if that works again. Oh. No. It's broken now, sorry. But I think the point of what I was saying is that it's very, very unlikely, it's actually quite unlikely for you to meet a woman working in tech at Google. Actually, there's like a 1% chance that a woman working at tech at Google will be black. And this is globally across all of their offices. I'm going to unplug this and try it again to see if that will help. Give me 1 second, everyone. Sorry about that. I'm trying to see how I can go back. Oh, I think I'm actually in the...
Want to log out everything?
I'm in the wrong terminal, yeah. Sorry.
No, don't be. Very fine. This is something I forgot, so that's entirely on me to say. If you want to ask questions, we can use Slido. And if you don't remember, it's Slido-PyCon23. So please use that
I think I've got it.
to pose your questions during the talk.
See if I can pull back up the slides. Okay, I'm going to go back to the slides here. And then hopefully I'll be able to pull it over. Thank you. Okay. Let's try that again. Okay. Okay, we are back. No! Okay, hi! This is my problem. I do too much when I'm doing stuff, and then it doesn't work. But thanks, everyone, for your patience. So we can see, this is the graph that I created from their data. And we can see over time, it's actually quite shocking. In 2014, they had almost no Black women globally working for their company. That number has increased slightly, and it's at 1% now, slightly over 1%. So we have about 1,000 employees that are Black women working in tech roles at Google at the moment. And this is not specifically a criticism at Google itself, because I think they're taking steps and trying, with the minimal few resources that they have, they're trying the best that they can. So, So I also want to mention that I don't think this subject of inclusion or representation is just about gender and race. I think it goes beyond that. Oftentimes when we talk about diversity, we think about demographics. And some people might be thinking, oh, how can I get more Black people to attend my conference? Or how can I get more women to be part of my meetup? But I love this quote. I'm not really sure who said it initially, but it says, diversity is about demographics. Inclusion is about a sense of belonging. And we need to feel like we can belong wherever we go. And I think one of the things that makes us special as human beings, I'm not sure if animals do this, but I probably don't think they do. But as human beings, one of the things I think that makes us special is that we have shared experiences. So we can relate to each other's experiences, regardless of your race, regardless of which country that you come from, and regardless of your gender. So in tech specifically, I think there's several ways that even if you don't look like someone else or you're not an underrepresented group, you can actually represent a large group of people in ways that someone can look at you and they can see themselves reflected in you. So let's talk about those things. I think the first thing I want to talk about is shared experiences and the process of learning something new. So hopefully everyone, let's lift up our hands if we've learned something new before. And we've been a beginner before. So I remember a few years ago when I first joined, so before I worked at Voltron, I was at NVIDIA. And when I first joined NVIDIA, I was so scared. And I remember even just setting up my laptop and my work environment. I was still getting used to using NVIDIA GPUs. And I felt so nervous that even just the beginning steps, I was really taking so much time to do it because I was overthinking. And one of the main things that helped me was a senior software engineer on my team. I think when I was starting out, he saw that I was feeling nervous, and he just reached out to me, and he was just like, hey, I can see that you're nervous. Don't worry. We can go ahead and we can walk through the setup to set everything up. And he also shared that, when I first started, I also didn't really feel confident in what I was doing. But don't worry, you'll get there. You're going to learn, and you will grow. And so even though this was someone who was a senior software engineer, and he was someone that I physically, we look completely different. He's from a completely different country as well. I could see myself in him, and I could see, this person represents me in terms of if they started out not knowing exactly how to do this, and right now the senior software engineer who's really great at their job, then I can get there too. There's a path for me. So I think telling your story and sharing when you're learning something new or you're seeing other people learning something new is really important. And I think 2 practical ways that we can do this in the Python space is to share your story with other people. So whether that's tweeting, whether that's with your own team, if you want to give a talk, but just being open with where you've struggled in the past. I think sometimes we can fall into this space where we want to look, like we're super competent, and it's important to look competent in what we do. But sometimes sharing that, hey, I made this mistake this number of times or something else makes people feel like they can also try and make mistakes too. Another thing is good documentation. So when you're writing your code, remember that what it felt like to go over this code when you first used it. So sometimes I think it can be challenging if you're starting out with a code base and the documentation isn't great. And if you're intentional about thinking about the people that you're representing, the people that are going to have the same struggles as you in the future, and keeping that in mind when you're writing good documentation, I think is another way that we can do that. So the second thing that I think we can learn from transcendence is inspiration. So now that if we see ourselves being represented, I think we start to feel like we're included. And if we feel included, what happens is we have people coming into the space that don't look the same or don't have the same background. And I think this creates a very unique environment that can lead to all sorts of inspiration and creativity as a direct result of the diversity in the room. So one example that I like to talk about recently is this man. His name, I didn't write it on the screen, but his name is Pat Hanrahan. And Pat Hanrahan is the creator, he's the founder of Tableau software. He actually sold Tableau to Salesforce for like $16 billion. So he did great. And he's won 3 Academy Awards. So that's not something software engineers do every day. And he's also a professor at Stanford. And I was at a conference where Pat was giving a talk. And when he gave this talk, he was speaking about innovation and creativity and how they've played a very big role in his career. And in the talk, he shared that some years ago, he was working for Pixar on some rendering software. And he was trying to figure out how to represent light reflecting on skin using this rendering software. And a lot of his friends at the time were artists. So he went to lots of spaces where artists hang out, and they would always have conversations about different people that they enjoyed. And so by virtue of hanging around artists, he got interested in art himself. And so he found a Dutch artist called Rembrandt and became very interested in this artist. And it was in studying Rembrandt that he found a technique in oil painting called impasto. And this technique actually gave him a deeper understanding of how light interacts with translucent surfaces. So I'll quote him directly from the talk, and he says, artists, they sort of instinctively figured it out. They don't know about the physics of light transport. Inspired by this whole idea of Rembrandt's, I came up with a mathematical model. And it was actually from this model that he went on to create this rendering technique that was used in Pixar films like Toy Story and Finding Nemo that he went on to win Academy Awards for. So that's one example, I think, of having a diverse community around you that actually leads to more innovation. So for me, I think having a welcoming community means we have a greater capacity to be creative. Anwesha gave a great talk yesterday about her journey coming into tech as a lawyer. And I can only imagine, she shared about her experience being very negative and people telling her, no, you can't do that. Or, I've seen in tech spaces where people will look at a marketing person and be like, why are you here at this conference? Or like, there's this attitude that people have sometimes. And I can only imagine a Python community where you aren't told you shouldn't be here, but you're actually welcome. You're told you're welcome, your skills are valuable, and your perspective adds to the community. So what would the most inclusive version of our community actually look like? Now finally, I want to end by talking about why you matter and why the value of your story is important as well. So So 100 years ago, I'm joking, like 6 years ago, I was here at PyCon Italia as well, and I was giving a talk, and it was the first talk that I had given outside of Africa. And I remember just really loving the conference so much. I had been so nervous to come and speak. And Matteo, I don't know where Matteo, and I don't know if people know Matteo, but Matteo is amazing. I don't know who he is, but everyone give a hand for Matteo. And he is like one of the kindest people I have ever met. And he helped me when I was feeling super insecure and I was, nervous about my talk. And I was this random girl from Zimbabwe at this Italian conference, and he was just super encouraging to me. And that's something I really remembered from that conference. And something else that I remembered was a keynote that a lady called Valeria gave that was right on this stage. And at the time, this stage looked huge. And I remember looking at her and thinking, oh my gosh, she is so awesome. And I hope to be like her one day. And so for me, this moment and the PyCon Italia team inviting me to give this talk is such a full circle moment for me. Because I was able to see like someone else's story reflected back in my own, and now that's actually come to pass, and I'm giving a keynote today, which is kind of cool. So another person that I will say is a great inspiration in terms of representation is Guido van Rossum. And I thought he would recognize me this year at PyCon. I went to PyCon US this year, and he was like, sorry, do I know you? But a few years ago, a few years after PyCon Italia, I went to PyCon US, and I met Guido. And he is the creator of Python, if you don't recognize him. But I remember that when I went to this conference, he was wearing a shirt that says, Python is for girls. And I loved that shirt. And I think one of the reasons the Python community is growing as fast as it's growing and is as inclusive and welcoming as it is that Guido himself, even though he doesn't do it perfectly, he's actively making an effort to make the community welcoming to people who look different from him. And then finally, I will mention these three women on the screen. Rebecca Anchanong, Johanna Nandeke, Anna Makarite. These are incredible African women that are leading in the tech space. Rebecca has founded a company that is making millions of dollars in Africa, a tech company. She's super inspirational. Joanna is a Python core developer. She works for IBM. She's a PSF board director right now. Anna Makarite she was the previous, actually, president of the Django Software Foundation, and she's one of the founders of Python Zimbabwe. So these are all women that I think as well, it would be awesome if you could give them a follow or encourage them or see yourself reflected in them as well. So yeah, I'm actually going to end there, and thank you so much for listening to my talk.
Thank you so very much for the talk. We do have one question. Please keep them coming. Talking about mistakes, what has been your biggest in a tech role?
Great question. Wow. What's been my biggest mistake? I think I was, I'm trying to remember what was, it didn't actually lead to anything, but I remember when I was first contributing to QDF, which is one of the projects that I was working on at NVIDIA, I messed up this thing. We have, so it's an open source project, and you're supposed to do some specific checks and things like that. So I mixed up the checks and ultimately uploaded the code, but the code didn't get merged. But it was, to me, it felt like a big mistake at the time. It wasn't that big because the code didn't get merged. So I feel like that's one. I'm trying to think if I have any other ones. No, I'm just a perfect person, so that's it. That's the only one I'm thinking of right now that's relevant to tech, yeah.
In Is anyone here having a question? I can sort of bring you one. Yeah.
Thank you for the great talk. I was wondering, as a group organizer, what was your biggest challenges? And especially if you can share some tips on maintaining the people on the groups. Yeah, thank you.
Yeah, wow, that's a great question. Oh, I will also say that maybe a mistake that I've made is like I've obviously applied for lots of different roles and not gotten the job, so that's probably one. But in terms of that, community organizing, it's really hard. And the thing that I feel is the most helpful for me is keeping relationships with community organizers. So I'm particularly involved in the Python Africa community. So if I'm trying to organize something for the wider community, I'll like reach out to local organizers. If you're organizing a more local event, I think that is a bit harder. I think one of the things that is helpful for that is like consistency. For me, the meetups that I tend to attend the most are the ones that I know, oh, it's going to happen, you know, once a month on a Thursday, you know, at this time or whatever. That consistency, I think, makes a big difference. So, yeah, I'm not great at that either. So,
there's another question for you saying, what has been the most challenging thing working on empowering girls to start coding in Zimbabwe, and how did you deal with that?
yeah, it's something that I've really struggled with because Zimbabwe is like a specific case, and it's really hard to get funding into Zimbabwe because it's a sanctioned country. There's lots of things happening with it. And so financially, for a while, I was like trying to run this nonprofit by myself, and I was trying to do everything. And I used a lot of my parents' money, and I'm sorry to them for that, but it's a good cause, so it's fine. But I feel like for me, trying to run it sustainably is something I've really struggled with, and I took a break from it because of the sustainability aspect until I could figure out a sustainable way to run the organization. So, yeah.
Yeah, we can all sympathize that. I do have a very, oh, sorry, yeah.
Can you elaborate on the Google DI report that you quoted? There's a distinction in there between so-called tech and non-tech roles.
Yeah.
Can you elaborate on A, how those were defined in the report, and can you share your take on that perceived dichotomy between classifying roles as tech and classifying roles as non-tech?
That is a really cool catch, actually, because I didn't think about that. And I actually didn't, in the, specifically in the Google D&I data itself, it doesn't give a clear distinction between the two. I think for myself, I also didn't like go researching, deeper into it, because I just thought, oh, it's just non-tech and tech, so it's fine. But it actually links to what I was saying about people not feeling welcome because they're being told you're non-tech. So I think that's a great question, and I need to actually research that, and I will probably do that a bit different if I give this talk again. But I'm sure it's probably a breakdown between people who are software engineers and probably people who are not. And yeah, that's not always great. So, yeah.
There's another one very interesting, and thank you very much, everyone, for keep them coming. How can one attract diverse people in their company, given that there are fewer black women working or studying in tech in the first place?
So like I mentioned, I don't think diversity and inclusion is just about race and gender. I give that example because it's more relevant to me in my own life. But like, I'm not going to come to Italy where I don't know how many black people are in Italy and like expect there to be as many people working that are black in tech as they are in Zimbabwe. Like, Zimbabwe is full of black people, so it's going to have more black people in tech. But I think that being intentional, if you do have underrepresented minorities in any aspect, so be it people from a different background or from a different gender, even from a different perspective, in some ways, I think making those spaces intentional is really important, like intentionally safe, so really being aware of the language that you use around people, trying to be a bit thoughtful about it. I also think that I do think there's a pipeline problem. I do think that we need to be empowering more people with the right education. So I think that we need more education in underrepresented groups. Carlton gave a great example that in open source, like how are we going to know, how people from underrepresented groups know that they can get experience through open source if it's all white males in open source? And like probably their friends are white males and their children are white, they're not white males, but white people in general. So I think that is also an issue in terms of, can we, as people who are different, think about someone who's different from us and think, how do I create space for them to have these tools to learn more about open source or software or whatever? But it's a hard problem. It's not an easy problem.
Sure. Do you have suggestions in setting metrics for impact for a national group?
For a national group,
National group.
I do not. I think I am not an expert in this field. So I primarily read on diversity and inclusion because it interests me. I also think that it's relevant to my life, so I'm interested in it in that aspect. What I do think is the metrics are important, and I think what Google has done is actually very good. The fact that they've actually openly shared their data across, openly, is something that not all companies are doing. How to collect those metrics or how to measure them nationwide, I'm not really a statistician. Like I can't make a good recommendation, I will say. So.
There's another one which is, I guess, quite personal, but as well as inspiring, is how do you manage your time and priorities among different roles and initiatives?
I could probably do a better job at that, honestly. Like, I'm trying to do fewer things now, and I'm trying to not overcommit myself. I think also when you're interested in these topics, like I don't know how many D&I councils I've been invited to join, and I'm like, I'm not joining any more D&I councils, you know? But I think it's really important work. So it feels important to me, so I try to keep time for it. But if I don't have time, if I'm doing other things, I'll just say, I'm sorry, I just don't have the time, or I can't make it this meeting this week, or whatever it is.
Learning to say no is always difficult, isn't it?
Yes, yeah. Learning to say no is hard. So.
I do have another question if anyone else has one. That was very selfish of me. Okay, got it.
It's a bit difficult. Why are we different? I mean, I'm a male, you're a female, I'm black, I'm white, you're black, etc. But does that make us different? So maybe not, because our passion, our interests make us more equal than what we see make us different. So the question is, how do you identify a different person from you? Because I don't consider you different. No, we share the same interest. So if I was to hire you or anything, I'm not going to look at you because you belong to a certain group, but because you express certain interests. So how do I know that I need different people? How can I understand that they are different and then they can bring value to me, seeing the world as in a way different than I do?
Great. No, that's a great question. Honestly, I think that humans have a lot of similarities. I think we all have shared experiences. I think we all love Python. Like I am similar to you. I love Python, you know. I'm assuming you do too because you're here at this conference. So I think we have a lot of similarities, but I do think there are clear differences in terms of like, so for example, access, right? I did not know about computer science in the sense that I could code until much, much later in life. So I switched careers. I was in like molecular biology, pre-medicine route for a while. And I actually know there are people in my community that will not have access to a computer, right? And so this is a different person because of the access they have, the resources they have. And so even if they're going to come in and they're going to come in as a software engineer in your company, they might feel less confident than someone who has been coding from the womb, you know. Like I see Pi here, Anwisha's daughter, and I'm like, she's going to be so confident as a software engineer because she's been around code her whole life. But for someone who's like new to it, it can be hard for them. So the experience, though we are doing the same thing, our experience and our perspective coming into it is different. So I think that makes a big difference. So I wouldn't say that you should. This is why I actually think that all software engineers should like look into like good emotional intelligence books and things like that, because I wouldn't say you should go and you should, if you see a black person, you should treat them really extra nice or like really different or something like that. It's like, oh, that would be bad as well. But like, I think you should try to be sensitive or use emotional intelligence to see if you see someone who's struggling, just like identify that and then approach them in a way that you think you would like to be approached in their situation. So maybe do some research on their background or something like that. But like, I wouldn't say you have to initiate that until you see that the person actually struggling with something. So I would say just trying to use like your own instincts, your own emotional intelligence about it might be a good way. But yeah, it's also hard to not. That answered the question well. I don't know if that answered the question well, but you can also chat to me afterwards if you'd like. Yeah.
So anyone has any other question?
Brilliant.
So thank you for the talk. So I currently work in finance, and finance is not a very diverse field, and especially, as you said, it's not just gender and color. It's also socioeconomic background. These companies and over in the industry, they like they identify talent usually based on school, and like the very elite school are not very diverse as a starting point. So it's a bit of an open question, but what do you think could like help them identify other talent pools, more diverse talent pools? Because like, yeah, they just want the very best, but like it happens that the only place they know how to find the best people are not very diverse. So I don't like, I think like there are certainly good schools in Zimbabwe, but like they don't know about them, and like they probably don't see them to the same level as European schools, and like we could say like, yeah, we could just like get more diverse people into the elite schools, but that's not an easy problem either. So yeah, would just like to hear your thoughts about like how to help with that.
Yeah, I think that's a hard question. I think particularly in finance, I'm not really sure how I would address that. I think in general, with education, it's a really big barrier for people. And that's why like initially when I started ZimboPi, I was trying to get like a specific type of skill set in the girls we were teaching at a super young age, like before high school, so that they're building that skill set up until they're done. So my suggestion would be maybe to work with communities directly and look for communities that companies can partner with to, you know, you can really teach some of these skill sets to people at a younger age. So maybe doing after-school programs. There's awesome programs around the world, like Girls Who Code is global, a great program. There's a bunch of programs in Africa as well that do things like that. So I would say partnering with those communities that are already doing things, getting the education, if there's like a specific thing that they're like, we want this specific education set or skill set, trying to, I think, provide that at an earlier stage. But it's very difficult. I'm not a super expert on what actually works, so I don't know. But yeah, that would be my suggestion.
Hi, Mark.
Hi, Mark.
Just dropped my phone, yeah. I have a question. I've been trying to get my two girls into IT. for actually quite a long time now. And I'm not very successful at it. I was wondering, how can we make IT more interesting for girls? I mean, in terms of, not so much getting them included, but actually, creating interest that comes from themselves.
Yeah. I love that question. I think that making programming interesting. So hardware is a big part of that. I love Adafruit's hardware. Adafruit has some amazing hardware that has lights and colors and these things, and I feel like the way we approach the interest, so not only just being because I think the problem is as well, one of the issues for especially for older girls in high school, I found is the image they have in their mind of what a programmer looks like, and they're thinking of a TV show where it's someone in a hoodie and they're in the dark somewhere. But I think for young girls, I think really the storytelling I think is a big part of that. How do you get them interested in building a game in a fairyland somewhere that once they do get to certain places, a light lights up or something like that. I don't know, but I think there are some awesome resources. Adafruit has some great resources that try to do that, try to do some good storytelling. I think that would be my biggest suggestion, I would say. Yeah.
There's another one actually asking you, are you optimistic about the development of IT industry in Africa? Which are the biggest challenges and the biggest opportunities?
I'm optimistic. I am also a little tired, so I feel like I'm jaded a little bit because of how long I've been in the industry in Africa. But I am optimistic. I think there's huge opportunities in fintech. Nigeria has had several unicorns out of the country, in the past few years alone. There's been a number of fintech unicorns. So fintech is a big one. I would also say agriculture, agri-tech is a big one as well. There are a bunch of unicorn companies around agri-tech in Africa as well. I think access to internet is a big thing as well. I was talking to yesterday, no, a few days ago, and we were talking about the price of the internet. And in Zimbabwe, I'm paying $130 a month for internet, and he is paying in Switzerland $40 a month or $60 a month or something. And I'm just what are we doing? Why am I paying $130 for my internet connection? So also, can we get someone to provide internet at a reasonable cost to Zimbabweans or to anyone across Africa? That's one thing that I also think is something that I've consistently heard over and over again is the internet is too expensive. Internet is too expensive. So we have a lot of Africa that is not connected to the internet because of the price range. It's too expensive. So that's a big issue, I would say. But I'm optimistic. I'm very optimistic about it. Hopefully some things will change soon. Yeah.
Brilliant. I guess we have time for just last question, and I will be selfishly ask you mine,
Okay.
which is, so from yesterday's keynote, from Vesha's keynote, we said, I come from the language, I stayed from the community. We've been talking about diversity, inclusion, what's the difference, and how healthy is the Python community. But my question is actually, where do you think the Python community can improve at the moment?
Yeah, I love the Python community. I think that we are doing a lot of things right. I think I would love to see inclusion in terms of other backgrounds, like I said. I think not just an emphasis on the demographic data, but also okay, where are people coming from? I'd love to see more artists in this space. I'd love an open space for artists, or I'd love to see an open space for musicians. AI is actually moving us into that direction where, some of the most successful software engineers are the most creative ones. So I would love to see more inclusion of people from different backgrounds. Yeah.
I love that very much. Thank you. Well, with that, I think we do have time for a very quick last question, if you have one. Don't see anyone on Slido. Yeah.
Oh, there is one.
So thank you very much for the talk. You showed I mean, large corporations like Google can afford to invest resources in diversity and inclusion programs and can rely on aggregate statistics to understand if they're going towards the right directions. Smaller companies, small businesses, cannot really afford to take this approach. So I'm wondering if you can share some practical tips for small businesses to improve their inclusion. And I'm not talking just about gender and race, if we call that, but I'm talking about inclusion in a broader sense.
Yeah.
Thank you.
Oh, that's awesome. That's a great question. And I do think that, I think education, ideally, is something that is a great place to start. So maybe teaching yourself or about ways to make your company more inclusive. So it can be inclusion in terms of like, how do we create a workspace where people feel free to fail, you know? Like creativity, just feeling like you don't have to be perfect, I think it makes an inclusive environment. So I feel like, you know, maybe reading on that and presenting those. I think also as like a leader in your company or something, just being intentional about your hiring practices, being intentional about, you know, even we talked about women who are mothers, right? And having inclusive policies for maternal leave. So can women actually have a baby and come back to work? You know, that's something that in some countries is not possible. And so I think thinking about those policies on just trying your best for the people you have and seeing, okay, what do they need? And seeing yourself like in their shoes and trying to do the best for the people in your company, I think is a good start, I think, so, yeah.
Brilliant. I think we're at time. So, Madeline, thank you so very much. It's coffee break now. We reconvene in half an hour.
How is that?
I'll introduce myself real quick. Dave Klein. I've followed you on Twitter for a while.
Yeah.
It's nice to see we have a full house. So today our topic is creating an AI Python infrastructure that works with a reasonable scale. And we have a very good speaker here, Andrea. So just a reminder to all of us, if you want to ask a question, go to the schedule, this particular talk, and the Slido link will be there. Looking forward to this talk. Thank you. Shall we welcome Andrea?
Ciao, guys. Hello, hello, ciao. Can you hear me? Yes, okay. Okay, so I'm so happy to be here, so friendly face. So I'm Andrea Guzzo, I'm the AI technical leader of MDPI. MDPI is a digital publisher, we are publishing papers. And also I am one of the organizers of Python Biella group, a group of people that are talking about Python, technologies, a lot of things. Also, sometimes I'm a nerd. And so today, what's our goal? The goal of today is to speak about a little bit how to create an AI product that works, okay? Especially in NLP. In MDPI, we have a lot of text data. And I'll just give you some general ideas. I don't want to be like a Greg Sugo and throwing you things, so much things. And the most important thing is that we want to, I want to prove that it's possible to create something that works at reasonable scale, okay? And we'll see what is reasonable scale. And of course, you can do it also. So the idea here is also to give you also some repositories, some GitHub tools and stuff like that that we have created also in the Python Biella group, so you can do also by yourself in your company. Okay, what is a reasonable scale? Thank Jacopo Tagliabue for this kind of things. So a reasonable scale company is a company that it's here in the between, I use the mouse, okay, from late adopters and early adopters. So it's a company that it's not like, okay, it's not like Google, okay, OpenAI or something like that, but it's also not like a small company, but also can be a startup, okay? If you think about like a company scale and ML proficiency, reasonable scale company, it's something that probably it's coming later to the market, okay? But also it's an early adopter, so it's a startup, okay? It's something in between. And for sure, this is the criteria of the company. You have probably computational limit, limit budget for computation, short, small team size. You have millions, maybe, revenues, not billions, limited data sets. And also, you are not using data science and AI as a main tool and product. And I would say it's the 95% of the company in the world, probably, right now. Okay, so in this scale, okay, how can we build something? Or how can we build something related to data and AI, okay? This is a question probably that everyone in this field are talking about in AI. And we know that we are data people, and we need to create something that have a value. It's a product, okay, not a research. And the answer is now we don't need a bigger boat. Okay, we have a lot of tools, a lot of models, a lot of framework, mainly open source, I would say, that can help us to develop something that worth. Okay, there are a couple of points that I want to point out coming from Jacopo Tagliabue. I'm not super fan of some of them, but for sure, in this kind of scenario, data is king, and we know that, no? We need to be obsessed with the data quality because it's the greatest payoff everywhere, always. And pass is better than yes. I'm not fully agree with this. But also, this is really important, the corollary, less is more and keys. So we don't write code that other people have already written. Also here we can argue about this. And also the most important thing is we need to be agile. We are in the world where we have like intelligent data archivation, modern laptops, easy access to the resources. We don't need the OpenAI data center to run like a big model, okay? And this is super fun. Distributed computing, especially Spark, is the root of the evil. But it's my point of view. Okay, let's review some trends also on the market, and then we will go into detail about speaking about the architecture a little bit. So the first trend in the market, this is my opinion, and now machine learning models, I think, are somehow commodities, especially in specific fields like computer vision and NLP. What I mean with commodities means that you have a lot of deep neural networks that you can use with transfer learning and fine-tuning to create like models for your company and for your business. And I think that data pipeline are always the real competitive advantage, but of course are less cool. If you speak about, oh, I'm a data engineer, you're less cool than a data scientist for sure. The general trend too, it's that beyond some tech giants, okay, the 95% probably of the company, of the tools, okay, you can use like off-the-shelf and mainly open source solution. So you don't need to purchase like huge license that cost a lot of money and a lot of databases right now. And when we speak about machine learning in general and data science, it's really fun that the machine learning code, the core of what we are speaking today, it's also only this kind of block, no? This small piece of block in all the code infrastructure that it's around, like data pipeline, machine learning management, serving infrastructure, backend and front-end, pipelines and validation. Sometimes we forget about this, okay? But this is how the things are working, basically, under the hood. Okay, some informations to don't forget, never, is that every company is unique in the world because have unique data and unique people, okay? The two concepts that are really important, and I really want to suggest you these two books. One is the same book, but one is Italian, one is in English, okay? Data Culture by Alberto Danese and Stefano Gatti, just speaking about these kind of things. It really suggests it's really good. And also three concepts that I think are really important to have always in mind is that the information extracted, it's worth more than the data, than the raw data, okay? Knowledge, it's worth more than the information. And of course, the wisdom, if we are able to do it, extractor is invaluable, okay? I'm a nerd, as you said, so I really like Dune. So if you control the spice, the data, you control the universe, by the way. Okay, I will make some example. I just want to show you what we have built in MDPI, just to give you a big context, and then we go into the pieces and in the detail of the architecture, and I will try to explain a little bit. Let's see if it's working. Okay, so this is basically our portal, the AI portal that we have to test the models and and all the tools that we have created before going in production. For us, going in production means giving to the users and to other tools APIs to be used somewhere. So as you can see here, there is like a collection of tools and products. And I don't know, if I open something like, I don't know, journal overlapping, if it's working, it's Streamlit, by the way, okay? So everything there, it's Python, except for the login system that is Keycloak, but I will show you. So as I said, I want to prove today with this architecture that it's possible to create something. We have like 50K users per month, per week. And we have like a huge traffic of users. We have 15 million authors, and so this is the scale that we have, okay? It's not like a big scale, and it's not a big scale, but also not a small scale. So just to frame what I want to talk to you right now. Okay. Okay, so we started 1.5 years ago, so everything that you saw there, like the products and the tools that it's now integrated in every tools that we have. We started to creating like 1.5 years ago, okay, with a group of 6 people. And the first thing that we started is to frame how we build our products. What are the principles, okay, behind our products and our tools? So we started with a team. We started to create like a work methodology. Before there was only like Jupyter notebooks and people doing research and random things, okay? So we said, okay, let's start with a work methodology that works for the team. and always involving the data manager and the end user in the process. It's very, very important in AI. And we started creating building blocks. I said to my boss, can you give me like 3 months? I don't deliver nothing in 3 months. And he said, why? There is nothing, so we have to start creating some building blocks, some tools, and then we can leverage the architecture a little bit later, okay? And my boss, he's a great guy, and said, okay, I trust you, let's try to do these kind of things. So we started creating building blocks, okay, with fundamentals, simple template that now make all the process really easy to create products. And the most important thing is that we try to get out of the building, except for these 3 months. So we went to production right away from the day zero with development code, okay? The first thing is to create the infrastructure project to go in production. And then we will go to the back end and everything else. Of course, in AI, this is really like something, the shiny object syndrome. I'm suffering also about this. It's the latest model, and the technology in the market will not save our problem, never, okay? Let's try to create something that works, okay, that is stable. And of course, there are no excuses. If you can't make something, build with what you have. For example, in MDPI, we don't have any cloud, okay? Everything that you saw, it's on premises, with Docker, by the way. And of course, the two important things at the end, it's that it must work for the user, okay? So the project must work, it's mandatory. We have to find a way to make it work. And the why, the research question, it's always the beacon in the night. When you start the project, start asking what you want to solve right now, okay? And you have to be always this question in mind. Okay, this is the architecture that we have built in 1.5 years. I just want to point out some of these things. Don't be scared. I will try to stick together the pieces probably in the tool that you saw during these days in the conference also. So as I said, we started from building blocks. For example, data connector, notify me, Swordfish, Acadx. What are these projects? Those are like Python library that we are using internally to do these kind of things. For example, data connector is a wrapper between PsychoPG, SQL Alchemy, SQL Model, and a lot of different libraries to connect to the database. So we can do like pip install data connector. Actually, Poetry add the data connector because we are using only Poetry. And we can install all the data layer that we need. So every time, in every project, you are sure that you have the data layer ready. Everyone agree with the query. Everyone knows what's inside. It's very well documented. So we know what is going on with the data. Then we have the project to notify, to send notifications if something bad happened. And of course, the models. The models, we started from Hugging Face, of course. We took some open source model, especially Spectre, and we trained actually, and before we fine-tune, and then we trained from scratch our model. And then we have created 2 libraries based, of course, on PyTorch, ONNX, and a lot of things to launch the model and put the model, to train the model and also put in production for the inference pipeline. Those are the building blocks that we have created. And then we created Tempi. Tempi, it's like a template system. And with this template system, you can do like a cookie cutter fast API, and you have the backend ready with all the packages that you need. So now I can say we can create a backend for an application in 1 week, basically, okay? 3 months of work for 1 week of backend. You have to judge. Okay, this is basically everything. As you can see here, it's in Python, except for some tools. So nowadays, with Python, you can do everything, okay? From the data pipeline to the backend, to the front end with Streamlit. Probably Streamlit is not the best technology to do front end, okay? You can also have like MKDocs, it's a really good project. I'm backing this project to create like a GitLab pages documentation and also blogs and whatever you want. And basically, this is everything that you need to create something in your company, okay? You don't need something else. You don't need to buy crazy things, okay? Everything here, it's open source. Another concept that we have introduced is the micro-repo approach. So everything here, it's a micro-repo. The front end is divided by back end, by infrastructure, so we can go really easy to deploy everything that we need. And everything, of course, is Dockerized. We have GitLab CI/CD pipeline that we're using to go in production, okay? This is basically how we create the tools that I show you later, that I show you before. Some concept really important. Human evaluation for us, it's really, really, really the most important things because we need to be sure that every model that goes in production is really, really well tested. Documentation first. When we start the project, we go in production, but also we start documenting everything in Confluence, so we know that everything is there. And also, don't forget the maintenance part, okay? It's the tedious part here because you have a lot of packages, you have a lot of models, you have to be sure and control everything. So the maintenance part, actually, it's the most demanding part right now for us. And as you can see, everything here is without any cloud, okay? This is on-premises solution. So you can do also on Contabo if you want. Okay, few things about MLOps. I don't want to go into the detail. If you want, we can discuss later also. This is like a division of machine learning operations maturity model, okay, made by Microsoft. And actually, right now, we are on the level 3. Those are the tools that we have created. And to go from level 0, level 1, level 2, and level 3, the effort is really, really, really high, okay? So it's good to have like MLOps, but probably let's start with the level 0 and level 1 to start having like a DevOps pipeline, some automated training, and then goes later on to MLOps. We know that there are platforms that put everything together for you. It's really convenient also. But we want to start and learn what we have, what is behind here. So we start like creating everything from scratch from our own. And I have to say that the effort here is really high. Okay, it's where we put the most effort of our time. Okay, you can try also these kind of things like the template system, the packages, some of the packages, some of the concept like the customized Airflow version, how poetry configuration, Black, Bandit, all these kind of tools. It's here. It's available in GitHub in our Python Biella group. Okay, there is this project called Beer that if you want you can try. So what I'm trying to do is also giving to the open source what we are taking from open source. So we are making some projects, open some PR, trying to fix some projects. We have a good discussion with ML Server, actually. And also, personally, I'm here in Python Biella group, and we try also to move something also to Python Biella group and to GitHub, so you can try also. You can see what we are doing. We are trying also to create some packages also from MDPI, but it's really complicated sometimes, dialogue with the people and publish the code, okay? Okay, few things, what's happening right now? This is a slide of October 22. I was talking about generation of content, okay, made by AI. So this is the image, the first image that won like AI content. This is Copilot, everyone knows. And at the end, this guy came out, and it's a mess, okay? Especially for us, because we are a publisher, a scientific publisher. And now a lot of people start generating research and comments, so it's really complicated. And we are trying to create and develop some tools to identify if a paper is generated or part of the paper is generated or not. Okay, so you can imagine the complexity. And we are changing the architecture. So nowadays we are in a world where this small piece, okay, that I showed you before, the ML code that was there, now it's becoming a real architecture, really complex. There are new tools coming out, probably Vector Search DB, you know that, like Milvus, Quadrant, and something like that. And we are assessing a lot of tools. And I have to say that the community, it's really great. There are good solutions, actually. The Cheshire Cat project, I really suggest you. It's really great. Also, Private GPT, they are speaking about these things. I have to say that the community is really great. We want to also participate to the community, giving back something. But we are discussing internally very much about these topics here. And also we are trying to create also some Neo4j knowledge graph to add some knowledge engineering inside the models. So this is what's happening right now in the publishing, okay, in the research. It's really a mess, okay? And it's really a war between publishers, but also between AI tools in general. And sometimes it's great, sometimes it's like a little bit complicated. Okay, that's it. What we are taking at home, that's it. I mean, there's a lot of things behind, okay? Yes, we can. I have to say that, yes, we can create something by our own. Couple of points that, like as a takeaway, democratization, artificial intelligence, now it's really accessible to everyone. You can launch something in your laptop, also big complex model, probably you need a GPU. Not only big tech, but everyone now can create like a custom solutions. And of course, we don't need a bigger bot. But first start with the right philosophy of the work. It's a never-ending learning. We need the right methodology and the work philosophy from the beginning, because instead it's a mess. Templates and building blocks really work for us, and it's really working now. It's really important for us to scale and to control the stack, especially now we are moving to Kubernetes, okay? And don't forget the human evaluation and the testing phase, and also, of course, to follow the users. We have a constant dialogue with the users. We are receiving a lot of input from the users to improve our models and our system. It's really important because we really need to work with the adoption of the tool. Without adoption, AI is really complicated. Giving to the people AI tools change their life, okay? The way of working and stuff like that. We are putting a lot of effort to try to help the users and the people to adopt the tools, and this is a lot of work that we are doing here. Of course, we need to find our reasonable scale, and as I said, AI world is really crazy right now. It's a very fast world. It's easy to be lost. So fortunately, there are communities, people that you can follow, and there's a lot of materials. It's a bit complicated. And of course, we are data people, so please build something that works for real, okay? It's a great something for everyone. Okay, thank you so much. Those are the people that are helping me every day. Without them, I'm lost, okay? The Python Gala Group community, MDPI, so thanks also to them because without them, I'm not here, okay? Thank you.
Thank you so much, Andrea. So we have... Thank you. That was very insightful. We have a couple of questions here. So the first one, what has been the hardest parts in your platform to manage? Though there are a lot of components for such a small team.
Okay, yeah, we have like, I was counting like 2 days ago, we have like 67 repositories on our GitHub for six people, so it's crazy. So the most complicated part, I have to say, it's the MLOps part now on the AI things, because it's really complicated to manage and to operationalize to arrive at a good level of MLOps. And I have to say also that the most complicated part was taking all the knowledge of the data that was there behind, organizing and creating the data pipeline. Those are the two most, I would say, complicated things that we have faced in the past. Especially data pipeline, it's a mess. But because of the data, that was before.
Okay. Great.
Okay.
The next question. Looking back, what would you have done differently?
Oh, okay. So probably really differently. Okay, poetry, it's a mess. Poetry is a mess, especially now with the release that they are like coming out every basically months. Now we are at 1.5, yes. So it's really complicated to manage poetry. Probably using PDM is better. I don't know. I have to say that we have lost a lot of times sometimes to deal with the server. Being on premise is good because you know what is going on downstairs. it's really good. You can control the bits, okay? You can control the machine, but sometimes it's really painful. So going in cloud, of course, you spend more money because I have to say that it's really most expensive, especially for the data, no, flowing back and forth. But it's really, I would say, sometimes it's really painful deal with the networks and stuff like that. So probably having a cloud architecture can help really a lot to speed up the process. Instead 1.5 years, probably it's only half of the year or 1 year, I don't know.
Okay,
Yes.
great. So you mentioned the on-premise, so I would ask a question here that's related to that. Maybe you would add up. So why on-premise?
Okay. It was a choice that I've done in the past, okay? And also because 70% of the company is a Chinese company. We are working a lot with Chinese world. Especially there is this tendency also to create everything by our own, okay, from scratch. And also, I have to say that right now, we have done some assessment to the cloud, and going to the cloud now, it's really costing a lot of money. It will cost a lot of money because we have a lot of data, and migrating the data back and forth for the model and stuff like that, it will become like a mess. So yes, like a company-wise choice, but also like cultural choice. And of course, as I said before, you have to build with what you have. So if there is on-premises things, you have to build with on-premises things, okay? This is what it is.
Okay, so the next question. How did you model your data in the DWH? Did you have a specific methodology in place? Can you elaborate on that?
Okay, probably we need another meetup for this answer. Just very quickly, we have modified Airflow to create a template system with YAML and SQL only, without writing any Python code. So we can easily create like a data pipeline writing only the YAML code, okay? Because all the functions that are there, it's all the functions that you need for the data processing, it's in data connector, so it's in our package. And we can really model like ingestion pipeline and transformation pipeline really easily. For the schema, it's something that we are still working on, especially because Postgres probably is not the best solution to create something really big. For now, we are just creating something like a data warehouse only for what we need. So it's not like a full data warehouse. It's like I would say, a big bucket, table bucket, where we have all the data and information that we have. I don't know, feature store, call whatever you want. It's a database where we are sticking all the data pre-processed, but also some raw data that we are integrating and putting there. So it's something like that, okay?
Okay,
Because we have two big collection of the data also behind, so we didn't start from scratch. Okay.
Okay, great. So we have like 2 more minutes for questions.
Yes.
I see you use both FAISS and Milvus as vector databases.
Yes.
Could you explain a bit the differences and the use cases?
Yes. Okay. Wow, that's another long question. Okay. So we started with FAISS basically. Because the methodology to navigate basically the graph and to extract the knowledge there so to indexing the data was more advanced in the past, okay? So FAISS was really the best technology when we started looking at these kind of things. In the meantime, Milvus, also now Quadrant, came up, but we were sticking to FAISS basically. It was great, I have to say. It's really complicated to manage like artifacts, like at the end it's a file, okay? So you have to move it around to the machines, you have to deploy by yourself and stuff like that. Having a vector search engine is more convenient. Also, I know that Milvus integrated a lot of methodologies to extract informations also using the FAISS methodology. So also in Milvus you can have like a sort of FAISS. So we are, as I said, we're starting to migrating to some modern stack with Milvus. Milvus is one of the choices, but of course we are still assessing. Now it's not fully part of the pipeline. Okay, we are working on it.
Okay, I think maybe this will be the last question.
Yes.
How big was the team that built this?
Okay, we started. Andrea, how big is the team? Like 5 people. We started with 4 people. Yeah. 4 people. We started, yes, 1 year and a half ago. Yeah, we started with 4 people. Actually, 3 people and 50%. And we have built like almost all the pipeline there. But for the MLOps part and the new projects that are coming out now, we are 6. We are recruiting 2 new people. They're coming, I think, next month. And also, we have, if you are interested, also reach me if you want to work on these kind of things. But yes, now the team, it's like 6 people working on that. We have also a team in Wuhan, in China, that are working, 3 guys that are working on different projects, most related to image processing. But yes, it's a small team at the end. Okay, I would say 10 maximum working on this kind of project.
Thank you very much. Thank you, Andrea. Hello everyone, thank you for joining this session. So today we have a talk on scaling machine learning microservices by Duarte. And just a quick reminder, if you have any question, you go to the schedule and you go to this particular talk and the Slido link will be there and you put all your questions there. Thank you again for joining. I'll hand over to him.
Thank you. Is this working? Can you guys hear me okay? Can you guys hear me?
Yes.
Okay, awesome, great, cool. All right, welcome everyone. I'm here to talk about scaling machine learning microservices. It's called a bag of tricks for if your stuff starts breaking, or most likely when your stuff starts breaking, if it's like mine. Ciao a tutti, sono Duarte. So the pronunciation you did was great. It's like Duarte. It's like a Portuguese weird name. I'm a machine learning / software engineer and contractor. I'm originally from Portugal, Lisbon, which is very hype right now. I'm based in Copenhagen, Denmark. I've been there for about 7 years. But I spend my summers in the Marche region here in Italy, mostly running around the hills there. That's where my girlfriend's from. And that's one of my favorite places on earth, so I really love coming back to Italy. In the past, I worked in strategy, product management, management consulting, new ventures, so I kind of did the rounds. Now, the thing that I do mainly is just solving tough problems end to end. Either if that concerns machine learning, software, I don't really care that much, as long as it's a tough, challenging problem that is really hard to solve. And this is a picture of me when I had all of my engineering credibility, big beard, and yeah, looking like a badass. Now I look like, yeah, not an engineer anymore. And yeah, I just wanted to take like a quick step back and like, it's such a cool conference, PyCon Italy. Like, I went for a run this morning. I run like, yeah, a couple of marathons a year. I really enjoy it. And the views around Florence are just so incredible that sometimes we're like here at PyCon and we're like really thinking about work and stuff. But I mean, it's the most beautiful conference that I've been so it's my second year. I will always come back whenever I can. Cool. So let's talk a little bit about, let's start about talking about machine learning microservices. And I'll start with a little short story of a prototype. I had this client, and OpenAI and GPT and all that stuff was coming out, and everyone was super excited. They were like, okay, Duarte, we need to build a system that creates super personalized emails. We have 2 weeks. Good luck. I was like, okay, cool. Here I go. And I still remember I was at my parents' place in Lisbon, and it was like 4 days into the project. And I spent like 3 hours from 8 p.m. to like 11 coding this thing away, like building, using OpenAI's API, doing Jinja templates for building all the prompts and with the conditional. So I was going crazy for like 3 hours. And the crazy thing is that it was like an MVP scenario, right? You build something in 2 weeks, you see where it takes. And of course, that ended up in production with lots of users, like thousands of users a day. And unfortunately, 90% of the code of the set that was in production, I had written in like, me and my team had written like in like 3 hours. And so today we'll talk about designing prototypes that scale well, mostly by leveraging Python, the language we all love and use, and how really can we leverage it to build something that works from the start and that scales from the start. And so we'll talk about 3 things mainly. The first one is about productionizing. If that's a word, I'm not sure, but let's pretend it is. The second one is about deploying. And the third chapter is about serving those applications. And so let's start with productionizing. This is a classic, right? Python is slow. Everyone's talking about Rust in this conference this week. And Python, always people say that, why are you not using a language that is much faster than Python? Python is the bottleneck of the stuff you're doing. And the fact is that, yeah, of course, you could write stuff in multiple other languages, but the problem is not necessarily always the language. The problem is how you're kind of designing it. And there are at least 3 ways to speed up your Python code for scale. And some of these are basic for you, I'm sure, if you're really advanced. But I think it's important for us to keep in mind those ways. And the first one of them is concurrency. And so let's take a normal example, right? Like this is a typical predict endpoint using fast API. I know there's one of the maintainers out there, so I hope this is not too bad. You take some items, you loop onto those items, you fetch some data about those items, probably from an external API. You gather those features, you predict with your model, you return your model's predictions. Typical use case, right? The thing is that if it's I/O bound, it's not very fast. And so I always tend to come back to this classical tree, like this cheat sheet, if you can call it, from superfastpython.com, great website. And I always think, OK, like I'm doing a lot of looping. Am I doing something that is CPU bound, compute intensive? Am I doing something that is I/O bound? Am I like fetching from an API, fetching from a database? How can I make this code parallel and concurrent and much faster? And so I always go back and say, OK, am I fetching from an API? Here I go. Many ad hoc tasks, no. Thousands of sockets, that's what I want. Let's go with async I/O. That's normally how I think. And so this is kind of a faster example of like we're doing the same. We're fetching the items. Instead, we're using this thread pool executor to fetch all of the I/O data in parallel. Horrible to read, right? Not very Pythonic, but significantly faster. So use this with care, but keep those in mind because for APIs, you can really speed things up. And this is a way of using this with the power of evil. I had this guy try to scam me when I was selling my bed online. He tried to get my credit card number. So I basically used thread pool execution to send him a bunch of fake credit card numbers. It was really fun. With the power of concurrency, I really think I screwed up his database. So it was a great time. So it shows that you can use this for good things as well. OK, the second way of speeding up our Python code, and it's called caching. Most of you, I'm sure, if you're advanced, you know about caching, right? We import from functools, standard library, the last recently used cache. Here we have a Fibonacci function. It's basically like putting a dictionary on top of your function. So that if we compute that score before, then we just fetch from the dictionary instead of computing again. And that can result in a massive increase of speed. Yeah, in this case, yeah, 1 million times, 3 million times. It's a bit crazy. And so caching ensures that we don't need to do double work when double work is not needed. If we've computed before, why compute it again? And so especially when you're doing external API calls, DB lookups, or you're making predictions from your model, this is a great thing to keep in mind. Normally, you have kind of 2 ways to go about this. I'm sure you have thousands of ways, but I only know mainly 2. DLRU cached, which keeps track of the most recently computed things and if we should use them or not. And the one that is really cool that I actually started using is the time to leave cache. So imagine your function predicts the weather. Weather probably changes every day, right? So you don't want to keep the cache just the weather of today. Probably the weather changes quite fast, so you want to use the time to leave cache. So maybe you want to cache a value for 10 minutes, especially if you're operating on a database that changes fast. TTL cache is a great way to solve those problems that I've had and people complaining to me that things are getting stuck in production. All right, queuing. Third way to speed up your Python code. And it's not really speeding up. And the point here is that if you cannot make it fast, then at least make it appear fast. And the point here is that things take time, OK? But there's waiting time, and there's perceived time. You know when you're waiting for something and there's a little cartoon on the screen, and you're like, OK, there's a little cartoon, so I'll wait a bit more, instead of just looking at a blank screen. And so there's at least 2 ways that I really like to speed up my APIs and my microservices. First one is fast API background jobs, and second one is Redis queuing. And so here in this example, I'm inferring on a bunch of strings. I'll authenticate the user, and I see if the user has requested if he wants me to queue this stuff up. If he wants to queue me up, then I'll create a job. I'll Redis queue this run model with the parameters. Then I'll use fast API's background jobs that on the back always check when that job is finished. Once that job is finished, then we use the job completion notifier to notify my user. But this happens in the back, so we instantly return a job ID. But if the user doesn't want to like just have that, then we can wait still and not enqueue it. And finally, these are 2 great resources that I really advise you to read if you're like me and like reading this stuff on your spare time. I hope you don't. These are 2 great books about scaling Python. One from Julien Danjou, the other one from Brett Stlakin about how to make your stuff really fast. So you don't switch to Rust. No, I'm kidding. Rust is amazing. Deploying. Second thing. So there are mainly 4 ideas. I mainly keep 4 ideas in mind when I'm deploying cloud applications. And the guy before me, Andrea, really talked about this. And I think our talks are complementary. He's mostly right. I am mostly wrong. And so yeah, 4 ideas that I keep in mind. First one, make it work for you. Really leverage the cloud. Like, these things are powerful. So really use them to your point. Second point, can you actually lift your stuff? If you need to move from GCP to AWS, and I've seen this happen in large clients. Can you actually lift your stuff? Third, open source first. These guys love for you to write proprietary Lambda functions, okay? They love for you to write exactly pip install Google Cloud or AWS so that you never leave it. And fourth, watch the spending. These things are expensive, so if you choose Lambda, know that if you're scaling up, it's going to cost some money. All right, but today we'll only talk about two, by the way, because yeah, I don't have a lot of time. So first one, make it work for you. Classic, right? I'll just deploy to the cloud. Great. Then you have thousands of services on Google Cloud, thousands of things to choose from migrations to whatever, like so many services, right? So I'll just deploy to the cloud doesn't really convince me. How exactly are you going to put this stuff out there is much more interesting. And so Andrea talked about IaaS, PaaS, and I think he said that someone said that PaaS was always better. I don't agree. These are three types of services, right? IaaS, which is basically, here's a VM, SSH into it. PaaS, which is basically, hey, here's my container, run it. And then FaaS, which is, here's my Python code, zip it up, run it. And so this exists across GCP, Azure, GCP, and AWS. They're kind of all the same. This website just compares their services across. So these are all the same in the three big guys, right? You have different levels of control, right? So you have a lot of control. If you're running your server, you can really know what's going on, and that's great, but you have to update those apt-get packages, and that's a pain in the ass. And so you can also go in the FaaS, and you just give it the code, which is great, just the code, right? But then it has it needs to start up times, and you're not really sure what's running on the back, and it's not that powerful. So the point here is that it's a trade-off. But normally, I like to make it work for me. And so I normally start with things that are really, really easy, like functions. I just sit on a function, use the simplest thing possible. Then I normally start having some memory issues, and then I start going for PaaS. And I'm like, here's my container, let me control how many containers. And that normally, sometimes, I hope not, I need to deal with GPUs. I really hate them. I have traumas about them. And then sometimes, I end up going for IaaS, and I have to manage my own machine, which is a pain. My sweet spot is definitely PaaS, right? But I never start there. I always start like super easy. I'm very lazy. The least stuff I have to do, the better. Second point about this is deploying. So can you lift it? And here we'll talk about Docker. And Docker is like the de facto industry choice for a lot of this stuff, right? Like it's super easy to use. It's flexible with all the images. You have extensive tooling to use like whatever you want in Docker, do whatever with CUDA, no problems. It solves all of your dependency hells, but even the talk before, Andrea was saying that poetry sucked, so I guess Docker doesn't solve all your problems. And it can also quickly become the source of nightmares, right? Like, here's my bin file. That's what most data scientists say, like, here's my torch model. Just go and run it. You end up with gigantic Docker images. Even yesterday, my server went down. And I noticed that, yeah, I had 140 gigabytes of, hanging on containers, and that's why my server was blowing up. That's what I was doing yesterday at midnight, basically rebooting all of my images. And you get these long and expensive build times, right, where we've seen this use case where you're a data scientist or a machine learning engineer putting an API out there, and your GitHub Actions take 7 minutes or 15 minutes. And the longer that stuff takes, the less you are likely to put code into the production fast. And so it solves things, but not really. But my point is that there are some principles that I always keep in mind to like build these Docker images that really help me in the back. And I want to share those with you in case you find them interesting. First one, choose the right image, right? The base image is really important to choose from. If you go with Slimbuster, or you go with Ubuntu, or we go with Debian, you better know what you're putting on that dependency, because that's going to determine the most amount of how big your image is. Second one, only copy what you absolutely need, please. Do not copy your PyCache files. Use a Docker ignore, for example, and only copy the things you absolutely need to copy. Third point, combine commands for smaller images. If you combine your commands, it possibly will slower your build, will be a bit slower, but your image will be much smaller. So whenever you can combine these commands, do that. And then like a golden rule that I read on the blog, and it's probably wrong, but I think it's nice, is like order the things from the least to the most frequently changing. So things that don't change a lot go up top, things that change a lot go towards down. And these are, yeah, some principles that I like to keep in mind. Yeah. Now, this one is also good about Docker. If you build an image and you don't know like exactly what's going on in that image and why the hell is it 6 gigabytes, use this tool called dive, and you can do dive and then container name, and it will tell you exactly like what's picking up space on your container. So it's a really good way of knowing what's going on. And then finally, like these also 2 great resources I use whenever I'm like using Docker. The first one is a talk by Matthias Browns in NormConf called How Small Can We Get That Container? It's a bit of a parody where he kind of tries to put a container that's from 2 gigabytes to like 25 megs. I do not advise you to do that, but it really talks to you like how can you like really control what's going on with your Docker container. And then another great resource is, I mean, it's one of those like pinnacle Python websites that I love. It's called pythonspeed.com by Itamar Troring. Whenever I'm doing anything with Docker and Python, I'll go to pythonspeed.com. He has the most extensive amount of resources, how you should package up your data science code, what to do, what not to do. So these guys are much better than me at telling you what you should do or at giving you some advice. So whenever you're facing these issues, go and take a look at these guys. They're really doing some great job. Cool. We talked about productionizing. We talked about deploying. Now let's talk about serving. Not tennis serving, serving your actual app. Cool. First thing, NumPy is freaking fast. Use it, okay? A lot of us, at least me, we build these machine learning models, or we build these pipelines, we build these APIs. We use pandas, we use NumPy. They're all great. Those, like, they're the first pip installs, right? But then it comes and we're serving stuff, and we're serving our API, and we completely forget about them. Here's a typical example, right? We have, again, our predict endpoint. We validate the data. If the data is not valid, then we say, your data is not valid. We clean up the data. We predict on that item. We format the data of those predictions to make sure they look nice and dandy. And then we return the output. Classic, classic, classic. Here's a much faster option, where I'm doing, first of all, a batch predict. I'm not doing one item. I'm doing as many items as you want. Okay? I'm removing those duplicates of those items because you are probably lazy consuming my API, so you always send me a bunch of duplicate stuff. And so I'm removing all that duplicate stuff. I'm also leveraging list comprehensions from Python just because I like them. Okay? And then whenever I'm doing this clean data function, where I'm processing multiple elements, I'm probably using NumPy or pandas on the back here. So I'm leveraging all the power of C on the back to make those cleaning and that formatting as fast as possible. And then, have you guys ever wondered like why the .predict endpoint, or endpoint, no, like basically API or function or method, in all of these models always gets a vector and not a single item? It's because these APIs were designed to predict on multiple stuff. Even if you're doing like a Hugging Face torch model, or you're doing a scikit model, you are, like, these things are made to predict batches. And so the first thing that I always do, whenever I create my APIs, is I create a batch predict endpoint. I do not predict on single instances. I always predict for multiple items, okay? And I leverage all the things that Python gives to me, okay? So all the NumPy and all the pandas, it really makes a difference. Cool. Now the second to last point about serving. Can we handle the load? And when you're thinking about scaling machine learning microservices or microservices in general, we always have this question of like, okay, can we actually handle thousands of users? And eventually you build up your MVP. 90% of that was not ready to go to production. But here you go, building that stuff up. And then you get 2 weeks pass on, 3 weeks pass on, and you start getting a lot of users. And eventually, things start slowing down, and things start going wrong, okay? And when things start slowing down and going wrong, that's when what happens that I say is like, the farts in the wind start happening. What I mean by the farts in the wind is like, no guys, like we need more Docker containers. No, it's Docker, like Docker is not giving us what we need. Or no, you need to add RAM to your app, like more RAM, push it up. Or like, no, it's because we're sync and you should be async, or you're async and you should be sync, and everyone gets confused. What the hell should you be doing? And so everyone has kind of is like throwing farts in the wind. Opinions about what is going wrong and how we should do better and stuff like that. I really hate that approach. I much prefer if we back things up with, hey, this is happening because this is happening, and I tested it out, and this is why this is happening. And I much prefer like a scientific approach to solving problems. And when I'm facing with this challenge of like, is this stuff scaling like it should? I use a little tool called Locust. Has anyone here heard about Locust? Okay, there's a lot of advanced guys. Cool, nice. Okay, Locust is a great tool. So check this out. What you first do is you define your Locust file, okay? And this is basically a rule set of, okay, run this test, which is you're going to post to my basic endpoint, you're going to send some headers, and here's my JSON with my 3 favorite cities that I'm going to post to my endpoints, to my machine learning app to make a prediction, okay? Then you go and you open the Locust file, and you just run Locust, and you say, okay, I want to simulate 10,000 users, and you want it to span 100 users per second, and this is the endpoint of my local running app. And so what Locust will do is it will literally hammer your API. It will send you 10,000 users. It will replicate exactly what will go on if your app scales to thousands of users. And so there will be a point where you'll be like, okay, what's my average response times? It will tell you for all of the endpoints what is your like average millisecond response time. It doesn't really matter. What really matters is the 95th percentile of your response time and how those worst predictions are going on. That's what really matters. And you'll also see this curve of, okay, how long are taking all of my requests? When are things starting to slow down? When are things starting to choke up? And this allows you to know exactly what is going wrong and when it's going wrong and what is in your app is choking up. A lot of the times for me, and this slide, of course, comes from trauma. It's something that happened to me in production. And so what was happening in production is that I was mixing asyncs with syncs and stuff like that, and I had a Google BigQuery function running on the back, which was choking everything up. And so yeah, Locust really helped me figure out what's going wrong. And hopefully, if you don't really know if it's going to scale, use it. I mean, nothing like really seeing if it scales or not in your own machine. And so yeah. Cool, we have 3 minutes left. So what's the big deal, Dort? Okay, that's really nice. BCG, they always said in the slide, so what? What's the point? And the point is 3 points. First of all, make sure your prototype is battle ready. People love telling you like, yeah, build an MVP in 2 weeks and then we'll see, we'll rebuild it from scratch. That never happens. So make sure your prototype is battle ready. Squeeze the performance juice from Python. Learn concurrency and multi-threading, and try not to block your user. Give that illusion of speed. My second point is faster deployments means faster development. So first of all, choose the right cloud service for your needs. Know how to improve your containers and make them fast and make them small. And faster builds means more deployments. If things take 10 minutes to reach production, you're going to push to production less often. That's basically the point. And then third point is, when does our app blow up? So leverage NumPy and Pandas, get a batch endpoint running early, and pressure test your APIs so that you exactly know when things will blow up before they do. And yeah, thank you very much, everyone. Grazie mille. Thank you.
Thank you very much. So we have a whole lot of questions, and we have like 6 minutes.
Oh no.
So
we don't need to go through them all.
Yes.
Is enough.
Yeah. So the first one, how would you cache data like images and text?
Well, text, I think, is the easier one. Not easier, but of course you can use just the raw text and make like caching of whatever text got thrown into your API. Another possibly a little bit more efficient way would be kind of hashing that text or doing some sort of table lookups to that text, or even some sort of like simple embeddings of those texts. But normally, like first thing, just throw the text. Are we talking about big paragraphs? Because if we're not, use the text. And for images, yeah, images, it's a bit harder. Images, it's kind of big, so I'm not sure. I don't have a good answer. I would have to look it up, like exactly how I would do this. Okay. But good question, good question.
Great. Second, are you aware of any way of load testing the ML microservice before deployment so you can get a taste of the performance beforehand?
Yeah, this, Locust. You actually can run this locally. I'm sorry if I didn't give you if that wasn't clear, but you run Locust locally. You spin up your API locally in localhost, and then you say to Locust, hey, hammer down my localhost. And then you'll see on your localhost how things are running. And the idea here is that it will give you a good idea how these things are running in prod.
Great. Do you also use two-stage Docker builds and caching?
Yeah, I think multi-stage Docker builds are a great thing. Especially in Python, I haven't really leveraged them for it. And if you guys don't know, it's like this way of making like an image or a base image to build your app and then another image to serve your app. And that's a really good way of like also minimizing the size of your images. And so yeah, definitely I've used it before and I definitely recommend you to check it out. And that website that I recommended has much more knowledge than me about that stuff, so definitely go there.
Great. What is your DevOps MLOps strategy toolset?
My MLOps strategy is keep it stupid simple, okay? Keep it as simple as possible and only increase complexity when you need to. I also gave a talk about MLOps, a poor man's guide to MLOps, which is, for me, MLOps is also about focusing on the software and those software practices and also DevOps. Of course, a lot of times I don't deal with like machine learning platform teams. I don't deal with that scale. Normally, in most of my clients, which are scale-ups, is like, we need to build this fast. We do not have a lot of time to build platforms. So go ahead and show some value. And so yeah, my strategy is keep it simple, make it work, and then we'll talk about making things complex.
In your deployment, how do you address all the vulnerabilities that are usually found by security container scanners?
By doing what? Sorry?
In your deployment, yeah, how do you address all the vulnerabilities that are usually found by security container scanners?
You see, like when you build that Docker image, there's a little sink. We find some vulnerabilities in your image type of thing. Yeah, I don't really address that often, to be honest. But I'm sure it's very important and I'm doing a lot of things wrong, but I tend to ignore it and clearly I shouldn't.
Okay. I like your slides. How do you make the slides?
By hand. So you take PowerPoint and then you write them. That's basically what I do.
Okay.
I'm sorry. Like I mean, I've used like PowerPoint generators and like like write that stuff in JavaScript and just generate your slides. It normally doesn't really work for me. And whenever the school where I learned how to build slides was BCG, and they don't really mess around with like automation of slides. That's something you need to think about every slide. So I hope you like them. Thanks.
Yeah. Yeah, great. Okay. What are your views on making models smaller using things like quantization and ONNX?
Yeah, I haven't used Onyx. For me, it's always a pain, right? For big models are coming, and they're really tough to handle. What I normally do is that I build my Docker image, I keep the model out, and then I'll pull the model in when it's runtime. And I'll try that model not to build and completely bust my container. But definitely, it's becoming very big, and so it's tough. But hopefully, we'll start using also OpenAI and stuff like that, so I won't need to worry so much about pulling those big models in.
Okay. Thoughts on code quality for battle-ready MVP?
Yeah. I do when I have teams of guys that are a little bit junior than me. Not that I'm very experienced. I'm clearly not. I normally tend to use like GitHub Actions a lot. So what I would do is that we have some rules, right? Some opinions about black and rough and stuff like that. So I don't really do like Git commits. What I do is that I get a GitHub action and some unit tests. And whenever junior guys or everyone, even me, makes the PR, if rough doesn't pass, if black doesn't pass, if the unit test doesn't pass, there's a big X on that PR, and I'm saying, okay, we need to do something here. What I also do is that I set a limit for code coverage and tests. And so if anything is below 75%, the PR it has just a big cross. And we don't need to have discussions about tabs and spaces and whatever code styles. It just enforces that stuff on CI. And then if there's a big cross, we need to take that big cross out before we merge it. And that's how I tend to do it.
Thank you. Last question, quick one. How do you deal when your clients need to have a single prediction and you want to do a batch prediction?
You do a batch prediction and you always index the first. Exactly the same.
Okay. Thank you. That's all. Thank you all for joining, and thank you.
time to start now.
Hello, everyone. Thank you for joining. It's interesting to see that we have like a super full house. So today, our topic for this session is diving into event-driven architectures with Python, solving complexity at scale. So a reminder that if you have any questions, you go to the schedule in this particular talk. The Slido link is in there. And our speaker for today is Mark. Thank you.
So thank you all for coming. It's amazing to see this many people in this small room. I hope I give a good talk, and if you have any questions, just put them on Slido. We can then talk afterwards. I'm also going to be around the next couple of hours and tomorrow morning, so you can ask questions there. So who am I? I'm Mark Lemberg. I'm from Düsseldorf in Germany. I have a consulting company doing Python projects. And I've been active in the Python community for quite a number of years. I've also used Python for quite a number of years. I'm old, so as you can see. I don't want to go into all these details. I've done lots of stuff. Let's get started. So motivation. So let's say you have a startup, right? So you have this crazy new idea that you want to put out there. Of course, you need to start thinking about what's going to happen if suddenly, next day 100,000 users start coming to your website, and you need to be able to handle that load. So you need to have some idea, at least, of where you want to go. You have an initial idea, but you need to prepare for the future. So when you start architecting your solution, you have to really think about how you can grow, how you can add flexibility to your architecture so that you don't develop into some kind of rabbit hole, so that you can easily scale up later on. And basically, there are many ways of how you can do this. I'm going to talk about one way to do it. It may not necessarily be the right way for you to do it. So basically, you have to figure out whether this is a good strategy or maybe some more classic strategy would be better to use for this. So of course, a lot of people know probably about REST and GraphQL. It's like the go-to architecture that you would probably use nowadays. If you use microservices, then most likely you're using REST for this. REST it's a very strong following. It has lots of support on the front end. It has lots of support on the back end. So there's lots of technology to choose from. There's one catch with REST, though. It's very inflexible when it comes to changing data and to changing your schemas. So if you want to change a schema and to do that often, then every single time you make that change, you have to roll out a new release. You have to change your front end. You have to change the back end. You might have to change the way that you scale your application. So it's not necessarily always ideal. And this is where GraphQL comes in. GraphQL basically makes it possible for your front end to query exactly what it needs to make. If you want to make a change to your backend, you want to have more data in the backend, then you can just change the backend and then have GraphQL dynamically adapt to that. And so it's better, like the better option instead of using REST. But both have the problem that they're hard to scale. Now let's have a look at a not so new architecture, actually, the event-driven architecture. Event-driven architecture is something that is actually quite old. It was very much in the news in the early 2000s. It was called SOA at that time, or at least that's what the industry called it. And well, back then, there were two architectures, essentially. One was web services. Web services at those days used mostly XML, so SOAP. And then later on, it turned to REST and JSON and so on. The part about the event-driven architecture kind of got forgotten, though, in the subsequent years. And I want to kind of, put this out there to perhaps have a look at it again, because it's actually quite a useful system. So one of the
first things that you have to know about event-driven architectures is always asynchronous. So there's nothing synchronous. You don't call out to something and then expect to get a result back right away. It's about events. So basically, you issue an event, you send out a message, and you expect some message to come back to you, and then react on that message. It scales very well, as you can imagine. I mean, if you basically decouple everything, then you can just add more workers, and then you have a more scalable system. And it also allows you to be very flexible in terms of architecture. So let's say you want to change part of your system because you find that it's not really performing that well, or maybe you want to change the architecture of one part of your system. Then that's very easy to do because you're only communicating with messages, and so the other systems that use your subsystem, they will not really have to know how a subsystem that you want to talk to is actually implemented. So let's have a closer look at this. Event-driven communication is basically the heart of this architecture. So what you do is you send around messages all the time. You have producers that create messages. You have consumers that consume the messages. And in between, you typically have a broker. A broker takes care of making sure that the communication actually works. And the most critical part in this architecture is actually this broker. So when you choose a broker, you have to be, really have to dive into the details and have to figure out whether that particular choice that you made is a good one. What's interesting here is that the consumers can, of course, also produce messages. So it's not just going from left to right. You can also go the other way around, or you can have like circles. So you can have communication going back from the consumer to the producer again to get, for example, feedback done. The events themselves are organized using topics. So this is essentially how you make sure that the right messages go to the right consumers. And there are various ways of how you can use these topics to organize your system. So what is encapsulated in those messages? Typically, it's about things that have happened. It's about change in state, for example, that happened that you want to tell someone about. It can also be used to initiate commands. For example, you can say, okay, please start this, let's say, a job run that you want to do in your workflow system. The messages themselves are very similar to what you have in web messages. So you have headers and you have a payload. You have to be very careful to keep those messages small because the throughput of your whole architecture depends on how many messages you can process per second. And so it's usually better to put all the bulk data, the like huge payloads, you put them somewhere else and just reference them in your messages. So how do you encode the data that you want to keep in those messages, have on those messages? The typical way to do this is using Apache Avro, which is the default for a very popular broker called Kafka. How many of you know Kafka? Most of you? Okay, excellent. Kafka today is mostly used for actually processing data. So you have data pipelines, which are actually very similar to this kind of architecture, except that the data that you're processing doesn't actually execute anything. It just gets processed, right? So it goes in and then gets processed and goes out again. Whereas in this architecture, everything is flowing around, right? So you have lots of communication going back and forth in your system. But of course, there are other protocols as well. Protobuf is a very popular one. MessagePack is another very popular one. You can also use JSON. You should always be careful to make sure that everything is typed and ideally also signed so that whenever you put something into your system, something new, then you make sure that the messages that you're actually getting and you're processing are coming from the right other partners. And this is very important because ideally you want to have this a zero trust kind of system and architecture. In order to keep everything nicely handleable and small, you can use a compression algorithm. zlib is very popular. Snappy is a bit more efficient, so that's something that you can use there, and the brokers typically support these as well. I also already talked about the topics. So topics are sometimes also called channels or queues, depending on which kind of broker you're using. Topics organize the way that information flows through your system. So a topic could be, let's say, I have an order coming in, and I want to process orders. So you call that topic, you call it orders, and then you have a producer producing these topics, these messages in that topic, sending those to the broker, and then you can have consumers that hook up to the broker and then take those orders and initiate some action based on that. There are two ways to process these things. One is called pub/sub. How many of you know pub/sub? Okay, few. So basically this is about publishing and subscribing. It's very much like what you do, for example, on Twitter. Let's say you follow someone, then you're subscribing to a feed, and the person that you're following there is basically providing the publish part. So what happens is whenever something new comes in, a new message gets generated, you get informed about this new message, and then you can react on that. This is a very, very simple approach. It works very well. It scales very well. There's one downside, though, because if you're not always listening to the subscription that you have there, you might lose some messages, and that, depending on what kind of message you want to process, that may cause some data loss. So there is a second way to do this called streaming, which works a bit differently. So it's not about publishing and subscribing, but instead the broker keeps, say, a list of the last, let's say, 100 or 1,000 messages. And then when you use the streaming approach, the consumers can actually go into that stream and also have a look at what were the 100 last messages that were published on that particular topic. And you can then access that. And you can use this to do some kind of replay, for example. Or if you want to join in later, or let's say you have a system that works on mobiles and the mobile is disconnected from the server, then the mobile, when it gets connected again, it can go to that stream and then get the messages. So what's very important here is that you have a decoupled system, so the senders don't need to know anything about the consumers. The consumers don't need to know where a message is coming from. So you have this ideal state of separation of concerns, and everything is encapsulated. So your processing is really the subcomponents that you have in your system are really isolated from everything else, and you can very easily make changes in that kind of architecture. So these are some message brokers. I just put a few here. There are lots and lots more. The most popular one probably is Kafka, but there are also other ones that are used in the industry. For example, AMQP is used a lot in finance. MQTT is used a lot in IoT. You always have multiple implementations that you can use. I put all the open source ones here. Then, of course, if you're going to the cloud, you can get these services there as well. So Google pub/sub, Azure pub/sub. In AWS, it's called SNS. And of course, you can also use a Kafka in AWS as a managed service. So these are things that you can use. These are brokers that you can use. But like I said earlier on, you have to be careful with the choice of the broker that you're using. And these are the things that you have to be careful about. So one is the guaranteed delivery of messages. So you want to be sure, at least in some cases, that when you put a message into a queue, it actually gets processed at some point. And this is very important because network failures can happen. There can be data loss. You can have failures in your system. A subcomponent in your system may go down, and then when it comes up again, it needs to then reprocess everything that's in the queue. So that's something that a broker should handle for you. Another very important point is making sure that the messages only get processed once. Because let's say you're in Amazon or you have some kind of web shop system and an order comes in. Of course, you want to process that order only once. And there are various modes of operation of these brokers that make sure that these things actually work. Something else that's important is the trade-off between message size and performance. Like I already said, you should probably keep messages very small. They should ideally fit into a network packet. So if you put something out there that has like 100 or maybe 1,000 bytes, then you're pretty safe, and that can be handled very well. You can scale up to hundreds of thousands of messages per second if you want. So that's very much possible. And I already mentioned the failure modes. If something breaks, you want to make sure that whenever the system then comes up again, everything continues processing. And that's also a very nice thing about this architecture. Unlike web services that use, for example, a REST interface, and you have a microservice architecture. In a microservice architecture, you have to basically be able to handle these failure modes yourself, and you have to program yourself. In this architecture, basically the failure modes, they are handled by your broker, and it's much easier to implement these things. Right, so we talked a lot about the architecture. Now, of course, you want to document whatever you're doing. You want to tell everyone in your company about the events that can happen, and the consumers, they also want to publish what they can consume. So just like you have with REST, there is an API standard. In REST, it's called Open API. You probably know. Maybe if you don't know Open API, it's the same as Swagger. In the event-driven architecture, there is a new standard. The standard got the development started in 2017, so it's fairly new. It's called Async API. Unfortunately, Python doesn't have a good story there yet. And that's one of the reasons why I'm doing this talk, because I think that we need to do something about this. We need to have more packages, more support for this kind of architecture in Python. Right now, it's basically just Node.js and Java, right? So enterprisey stuff that's using this. But I think we should really put some energy out there and then get more support in Python for this. So let's do a quick recap. Event-driven architecture. On the right here, I put a kind of a typical system that you have. This would be an order system. As you can see, there's a REST backend in there as well. So it's very well possible to combine these architectures. So you can have a client to talk to a REST backend, and then have the REST backend initiate the events, and then send the events into your architecture that you have with components. And then have an order manager ideally manage everything, so make sure that the orders actually go through. Right, I'm not going to talk about all of these things. The slides are already published on Discord, so you can go there and download them. So let's just do a quick example here. I already talked about the web shop and the orders, so I'm just going to use that as an example. In a REST system, what typically happens when you order something, then the order comes in, then you have to do the payment stuff, you have to do fulfillment, you have inventory that you have to handle, you have to queue everything for actually doing the delivery later on. So all of these things have to be done synchronously. You always have to go into your system and call out to these subsystems directly when the order comes in. And that, of course, creates a lot of problems if one of these subsystems is not available, and can easily then crash your system, or give a bad UX, because the user will probably then expect the order to go through, and then actually it doesn't go through. So the architecture helps a lot. The IDA architecture makes this a lot easier to handle, and it can make sure that these orders actually do go through. Another important thing is when deploying things. Because whenever you make a change in here, you will very likely have to make changes throughout the whole system. You have to deploy the complete system again. Let's say you're changing something in your inventory system, maybe a schema there, right? Then everything else will have to know about the schema change as well. And this is a lot better in the IDA kind of structure, because everything is decoupled. You're only sending messages. You only have to make sure that the messages can actually handle whatever change you make. And it's very likely that this will not happen often, that the messages can stay the same, but the implementation that you have for the subsystem can easily be replaced by something else. So the system is a lot more scalable. The code management in there is a lot easier to do. Deployment is a lot easier. And this is the main reason why, for example, Amazon is using this architecture for doing all the order processing. They started with a REST system. They had a monolith system early in the 2000s. And then they realized they couldn't scale that system up. And also going for microservices didn't work because they needed to scale so much. And they had all these issues that I talked about with subsystems not working sometimes. And so what they did is they basically re-implemented everything using this structure. And as you can see, it's giving them a good success. So what about Python and the architecture? We do have async support in Python, and there were a few talks about async at this conference. So we are actually in a very good position to do these things, especially if you want to do pub/sub kind of interface. It's very easy to use. What's not so great is the async API support. There are a couple of modules that you can use, but not that many. And the async API community, the community that's actually building the spec, is also not very Python aware. It does have some support for it, just very basic support in this async API studio that allows you to build these spec definitions. But it could use a lot more. Likewise, if you go to PyPI and want to define some packages, normally when you go to PyPI, there's always lots to choose from when you have a problem, right? But in this particular case, there isn't much to choose from. And what's worse is that the support for these things has more or less stopped. So we could really use more efforts in this kind of area to make it easier to use this kind of structure. What you can do, of course, and lots of companies, of course, are using this, is you can go low level. So you can just take your broker and interface directly to the broker, let's say a Kafka. I put some of these PyPI packages up here that you can use for these kinds of brokers. There's definitely a lot there. Also for the cloud services, I didn't put them up here. So it's very easy to go with this low-level kind of approach. If you want to go a bit more high level, you can also use packages like Broadcaster, for example, that abstracts a bit away from from the direct broker access. And then you can replace, for example, a Kafka with a Redis, or maybe you can use Postgres, the pub/sub in Postgres, if you want to have something that's smaller. Maybe you want to run it on your notebook, which then is installing Kafka is a bit more difficult. And so you can use those, or you can just basically go basically Python all in. There are some implementations there that basically try to have the complete broker written in Python, and you can play around with those maybe while you're developing things. But that's pretty much it. So there isn't really a whole lot. And while the architecture is really useful and really something that you should consider if you're starting your next big thing, we do need better support for IDA in Python. Right, and that's all I wanted to say. Main takeaway is, as always, never stop to learn, always try out new things, and look outside the window to find new technology out there, new ways of doing things, even if they may not necessarily be straightforward or straight away to implement. Right, thank you.
Thank you very much. So we have a couple of questions. Can you open a bit on how to do the signing of JSON? How it's laid out in a nutshell?
The messages are actually, you can actually use existing technology for this. So you can basically use the same technology that you have for SSL processing that you have on the web. You can use that. So it's very straightforward to implement that. You can even use TLS for the network layer if you like.
Okay, great. It seems like EDA seems suitable to work with data lineage. Is that right?
Sorry?
It seems like EDA seems suitable to work with data lineage. Is that right?
It is, well, lineage basically, data lineage basically is about you know where things are coming from, you know where things are going and how are they being processed. So yes, it does help a lot with that because the messages actually carry that information for you. And if you like, you can use, for example, the meta information that's in the headers of these messages and store them away, maybe in a log server, and then use them later on to basically figure out where a certain message came from, where it went, and how it got processed.
Okay, great. Next question. What are good resources to study more about events-driven architecture?
One go-to place is this async API organization website. I don't have a URL here. I think in the slides, if you click on the async API mentioned there, then I think that's a link. I can post some links to the to Discord later on.
Okay. Next question. Your company does consulting. How are devs' reception to the EDA's idea? How do you prevent accidental hybrid architectures and ensure idempotency is implemented?
That is a very good question. So this architecture is not that well known yet for doing like larger scale applications. So there is some training that you have to do. You have to make people aware of it and maybe try out things on a smaller scale first, and then get them into this. In terms of preventing a hybrid architecture, I don't think that you actually need to prevent this. Like I said, you can easily combine REST with an EDA architecture. You just have to document the interfaces between those two worlds in a good way. And this is where this async API spec actually helps a lot, because it defines what your messages are all about, where they're coming from, what the consumers will have to do with those messages. And you can also define which consumers there are for a certain type of message, right? So all of that is basically in the documentation, and it's automatic because it's machine readable, very much like OpenAPI, right? So you can actually have a website where you go, or you can have a system in your knowledge base that takes these specs and then generates documentation from these specs.
Okay. Next question. Any best practices on dependency discovery between services and on event schema migration besides versioning?
Well, discovery, again, this is async API, right? So basically, this is the go-to place where you publish everything. And this is also how, because it's machine readable, this is how your subcomponents can figure out what's there, what's available. And the second part was about versioning, right? So
yes, and on event schema migration besides versioning.
Event schema migration. This is interesting. I have to check. I read something about the async API not supporting versioning, but maybe I've just misread that. I'm not sure. You can go to the async API website and look it up and see whether it does support versioning or not. In general, what you can always do is you can always, if you want to have a new version of a message, then you can just create a new message type that you then start using. And of course, you can keep the support for the older versions of that message type in your system so that you don't have to always upgrade everything at once, but you can do it gradually and then deploy things step by step.
Okay. What problems have you faced in debugging a Kafka unexpected behavior, for example, in case of a rebalance?
This is hard, to say the least. I mean, it's because everything is asynchronous. If you've ever done asynchronous system programming, you probably know that things can go left and right, and it's just a complete mess to debug. So, what you have to do is you have to very much take care that your system allows observability, so that you need to do lots and lots of logging. you need to store all these logs somewhere so that they're easily accessible. So for example, on AWS, you'd use CloudWatch for that. You push all your messages there, and then you need to have a good query language that can actually help you put together everything in order again. Because it's async, everything is out of order, right? Well, normally at least. And so it's very hard to track everything. There's one good thing that you should keep in mind. You should always try to have things like request or order IDs in your messages so that you can easily correlate the different messages to one, let's say, the original event that triggered a whole lot of other events that happened. That makes things easier. And if you have subsystems, it also makes sense to use these IDs for the subsystems so that you can basically put everything together again, and you get a whole tree of messages that were generated, and you can then follow up using that and use it for debugging. But it's hard, definitely. That is one of the downsides of the architecture, I must say.
Thank you. Our time is up now. Thank you all for joining. Thank you, Mark.
Good afternoon, everyone. A friendly reminder that the questions will be on Slido, so if you know the drill probably by now, if you go to the schedule, you have a Slido link over there. And the next session, we have Serena. She will talk about how to use deep learning to process audio data and classify sounds. And let's give her a warm welcome.
Hi, everyone. I hope you can hear me. I am Serena, and I am team leader of the data science and AI group in Overture. And this is my second time here in PyCon, and this is also my second talk here. And just a brief, just a brief introduction about the company where I am working. Overture is one of the 5 companies in Symphony Prime Group, and the aim of Symphony is to bring digital transformation in medium and large companies. And in Overture in particular, we deliver project on cloud, and in particular on Google Cloud, because we are partners since 2014. And we have several years of experience in cloud transformation, and in particular in the big data area. So today agenda, we will see basically how sound data is done and is made up, and how to go from raw format to digital format, and also some common use case in industry in using audio data and processing audio data. And we also see how to prepare audio data to feed deep learning models, and we will see basically 2 techniques, building from scratch a model, and also using the latest transfer learning techniques that are pre-trained to basically fine-tune this algorithm and have an output. So starting from sound data, I will not go in details, but basically we have regular signal, which are non-digital and are produced by air pressure. And usually regular signals of sound are done by regular intervals. But in the real world, the majority of sounds are not following a regular periodic pattern, but basically are following this kind of pattern, which is not regular and is also made up of a mix of frequencies at different amplitudes. The human ear is able to distinguish between basically different sounds, and this is done basically it's done with the timbre. And since we are able to distinguish between different sounds, also machine can be able to distinguish between sounds if we feed them with the correct format of the sound. So going from the raw format to the digital format of sound, basically we need to convert sound into audio, and this is done by doing a conversion in numbers, and the important numbers that are used in audio transformation are amplitude and frequency. We do use Fourier transform to convert audio from the raw format to the digital one, and the transformation from the raw format to the digital one is called spectrogram, and basically is a transformation to an image. What we see in a spectrogram is basically the frequency as a function of the time, and the color of the spectrogram is called amplitude, and it indicates basically the energy of that sound. So since we are using basically images, or maybe video, I will explain in detail, there are some challenges that we need to take in account when we are going to feed a deep learning algorithm. First of all, since we are talking about images, basically we are going to use some deep learning techniques that can be trained on images. And an example of these are the convolutional neural network. Another thing that we need to take in account is the time factor. We have seen the spectrograms that are frequency as a function of the time, and basically a spectrogram is more similar to a video rather than an image. And since it is moving in time, We can both using convolutional neural network, but also LSTM, which are a class of recurrent neural network. And this kind of network in particular are used for recurring patterns like natural language processing, where we need to take in account the content before and after a word. In this talk in particular, I just show how to train a convolutional neural network, not LSTM, just to simplify a bit. And before to move to the discussion of the sound classification, here some example on how audio data are used in common business use case. Basically, we can use audio for audio classification, audio segmentation, also, for example, to separate which person is talking instead of another, or if there is some background noise under the voice. We can also generate audio and music, and this is done actually with the generative algorithms like ChatGPT or Palm or GANs. And we can also make voice recognition and also speech to text and text to speech, and other use cases that I don't list in here. So what I will show you here today is how to classify sounds and to predict categories. And I will do it in two different ways, by building a convolutional neural network and also by using the latest state-of-art transfer learning techniques. And the process that we will see is basically take raw data, which are audio wave, transform them in spectrogram, build and train a convolutional neural network, and then have feature maps that then help in categorize the different sounds in different categories. The audio dataset that I'm using can be found online on Kaggle and so on. It's basically made by 80K sounds coming from day-to-day city life sounds. And the dataset in particular is made up audio files, which are of 4 seconds in length usually, the one in this dataset. And then it's made up the class ID. We have 10 classes in total. So before to feed our algorithm, we need to clean the dataset and manipulate it a bit. And to do this, Python has several libraries that can help in doing the pre-processing step for the audio data. These kind of libraries can do the reading of the files, the visualization of sound wave. We can even listen to them, and also we can transform and augment the data. We will see this in detail. But the main libraries that are used to process audio are Librosa, which is one of the most popular one and has a wide range of features. Then there is SciPy, that is a library similar to Librosa, but has less features than Librosa. And then there is Torch Audio, which is mainly used when we train a network using PyTorch instead of Keras or TensorFlow. Today, I'm using Librosa to show you some transformation and also an example with SciPy. But starting from Librosa, if we want, for example, load a raw data file, we can do it by using the load function of Librosa. Or if we want to do the same with the SciPy, we have to import a web file from scipy.io and then read the audio file in a similar way. What we have in output is printing the shape of the sample, which is basically the print of the amplitude of the sound at each time step. Moving on, we can also visualize and listen to audio. We can visualize audio by using librosa.display, and this basically shows the amplitude as a function of time, because here we are still talking about raw data. And we can also visualize data if we are using, for example, Jupyter. We can visualize it, listen to it, and see which kind of sound we have in a raw format. So we were talking about spectrogram before, and here we can see how Librosa can help in converting to spectrogram. Basically, there is one single function, which is stft, that helps in converting into spectrogram. But as you can see from the image, basically, the image is very, very black, and there is just a little part that shows the frequency and the amplitude, but is not really clear. And this because as we do, as a human being, we can perceive the audio as logarithmic scale. This is linear scale, so we need to move to logarithmic as well to see a clear image. And so this is done with a couple of libraries. Basically, a library that is used to convert to mel scale instead of having frequency, and to convert to decibel scale instead of using amplitude. And as you can see in the image here, this was before, and this is now. Basically, we can see the amplitude more clear because it is in a logarithmic scale. This is done with two functions of Librosa, which are magphase and amplitude 2dB. There are then other steps that are optional, but can be done to have a more precise training of the network. And these are, for example, the spectrogram optimization with the MFSCC function, which basically take a subset of features from the previous image in order to make the training simple and also more dedicated to the important features. Another common technique is the augmentation of spectrogram. Basically, if we have not a lot of data to train on, we need to have synthetic data. This is common in deep learning, and in case of audio, basically what is done is to mask a part of the amplitude and of the frequency, so that the algorithm can see this data as new data. So this is also a technique that can be done with the spec augment and is provided by Librosa. So moving on, we will see now how to train a convolutional neural network on this kind of data. And basically, before to do this, of course, we need to do the usual things, which are label encoding in order to have the class in a categorical way, and also split the training and test the data set into train and test data set. About the machine learning model, so this is a convolutional neural network which has 4 convolutional layers, and then at the end has the layer that make the classification and also the feature map. And this then will give as a prediction, the class of the audio. I built the convolutional neural network by using Keras, but it can be done, of course, with also by Torch. This is basically the network that I built, which is a Keras sequential network with 4 convolutional layers, and the last layer, which is global average pooling to make the feature map for each category. Then it is compiled, and then we can have the training of the model, which is done with 100 epochs. And as you can see on the right, the loss function and of the training and the test is very similar, so it seems there is no overfitting. One of the last step is the model performance assessment, and this is done by using the evaluate function of Keras. And as you can see here, we have a very good testing and training accuracy of the model trained. Moving to the prediction, and then we will go to the transfer learning techniques. After the training, we can get the prediction. So basically, we can get the prediction on new audio data never seen by the model, and then we can get which is the category of that audio with a probability associated. This is done with the predict function of the Keras model. So moving on, training a neural network from scratch basically nowadays is more and more not used because there are a lot of pre-trained models that can be fine-tuned on our own dataset and be very, very precise. And also using transfer learning techniques save time and resources, but also allow to have more accurate results because basically we are getting the pre-trained features which are basically models trained on very, very large data sets. And then we will do a fine-tune of just the last layer on just a small set of data that we have. So in doing this, there are some community like Hugging Face, which helps. And Hugging Face is one of the AI community, one of the most large AI community open source, and it basically provides the latest state-of-the-art models pre-trained, and the most of them are based on transformers. And also for usually Hugging Face has most of the models dedicated to natural language processing, but in the last times also to computer vision and also to audio tasks. Regarding audio, the most common Hugging Face pre-trained models are Wave2Vec, which come from Facebook's, and it is available in Hugging Face. Then there is YAMNet coming from TensorFlow Hub. And then there is also SpeechBrain, which is available in Hugging Face and is more dedicated to actually voice recognition, but can be suitable also for this kind of task. So if we want to fine-tune an Hugging Face transform, basically we have to import a pre-trained model. In this case, I was choosing the one coming from Facebook. And we have also to define the training arguments and the evaluation strategy because there is the last part of fine-tuning, so some hyperparameters need as well to be defined. And after that, we can define our trainer, which basically contain our dataset of train and validation, and also the computing metrics that we choose based on the task. And in that case, I built the compute metrics in there. As you can see in the bottom part, this is the print screen of the training step. Usually, when we fine-tune a pre-training model, we don't do a training on a lot of epochs because it is pre-trained. So usually, we can use 3 or 4 epochs, and we can see that there is a good accuracy and that also the validation and the training loss is not that different, which means it's not overfitting or underfitting. And here we can see the print screen of the evaluation accuracy, which is very good. So in conclusion, we have seen how to use audio data to train deep learning algorithms from scratch, but also by doing a fine-tuning of pre-trained model. And as usual, Python brings together all the libraries that are needed to build everything, basically. And this go from data exploration to data transformation to visualization, and then for model building, assessment, and predictions. Thanks.
Thank you for the talk. We have a bunch of questions and we have a lot of time, so we'll be able to go through them. So the first question that we have is, how do you label data and segments? Are there any nice tools to do that?
Sorry, how to?
How do you label data and segments?
So Yeah. So basically, the label problem is a common problem in the sense that either you have a already labeled data set, or you need to do it. And sometimes there are like services, like in Google Cloud, we have one that is able to label for you the data set if you don't have these kind of features. Otherwise, sometimes some pre-trained models are used for the first part, that means label the data set, which can be like not really, how to say, precise, but is like a first screening of the label phase. So yeah, these are the common techniques that I know.
Okay. And then another question was, since audio signals probably are not time invariant, do you also use wavelet transforms instead of Fourier?
Personally, I just use Fourier transform, but I mean, it depends, of course, on the case, because this is maybe a simple case and we can do with Fourier. And of course, if there is something which is more complicated, there are a composite of different techniques to use and find the best fit, basically.
Okay. Is there any particular reason to perform the data augmentation step on MEL spectrogram representation rather than on raw audio data?
Well, for audio, actually, I don't know how, if it is applied, the second techniques. I know that it's possible to do this kind of augmentation because it basically, as I said, masks some part of the image. But I don't know if it is possible to apply also the other technique.
Okay. And the last question that we currently have on Slido is there a rule of thumb about how much to mask?
Well, about augmentation, I think. I think so. Yeah. Not really. I mean, it depends also on the source data, because usually augmentation is used to have more synthetic data if we don't have enough data. So if we have something that start to be enough, we don't need to mask a lot.
Okay. Now, we don't have any more questions on Slido, but we still have some time. So if you have any questions from the audience, we might take it. Is there anyone who has a question? Okay.
Thank you. Thank you for your talk. If you would do LSTM, would you do it on the spectrogram or on the raw data? So on the image? Okay.
Because it's time, I mean, it is as a function of the time, and this is the reason because we need to use LSTM instead of CNN.
But the raw data is also a function of time.
Yes, but in the raw data you have only the amplitude as a function of time. So if you need to train, you need to transform the spectrogram also to have the frequency. So, I mean, it's better to transform and then use the LSTM. You can, actually, I don't know if it is possible to train also on the raw data, but I think you won't have an image, so you cannot use that techniques. And also you don't have a lot of information because you miss the frequency which is needed to distinguish between different timbres.
Okay, thank you.
Maybe I find this is also very interesting topic and task. It's also challenging.
Yeah.
My question would be, are there any techniques how to, so here we speak about how to classify a noise. Basically, is there any technique how to remove the noise? Because sometimes it's overlapping with the speech. So if someone would call on the phone and there is a wind, for example, driving in a car, like a sound of the engine, wind noise. So how to, maybe is there any technique or possibility to remove the noise from the audio?
So basically, as far as I know, but I don't know if there is also anything else, you classify first between person or noise or other things, and then in a post-processing you can remove the noise, but it is something that comes after this kind of
so
process.
no streaming capability then?
I mean, it can be streamed, but is like a piece after the training and after the prediction. So you can put a piece in the streaming line in real time, but after that you get the prediction. As far as I know, but I don't know if there is like something that can be done also during the, because classification is classification, so you cannot remove from that part.
Okay. Thank you.
Okay. And we have time for one more question. We have someone at the back.
Hello. Thank you for your speech. I have a little doubt. In the outcome of the transfer learning that you use, which is the outcome of the utilization of transfer learning?
So basically, I don't put here the prediction, sorry, because here is only the step of training and get the evaluation. But what you have there, then after this, is a function which is predict, and you can put the audio never seen from your training and get the prediction from there. So it is another function that basically give you the prediction.
Okay. Do we have any more questions in the room?
My question is, have you noticed some particular difference on the performance of the first model that you trained compared with the fine-tuned model?
Yes, I mean, the point is that since the fine-tuned model is trained on billions of data, of course you will get an accuracy that is higher and higher. So it's always suggested, if you can, to use transfer learning techniques, because you don't have to train from scratch, and maybe you have not a lot of data, so your model won't be precise enough. So basically, yes, the prediction will be more and more accurate for fine-tuning techniques instead of training from scratch.
Thank you.
Okay, any more questions? We have time for one more.
Did you have to go through any hyperparameter tuning in the process?
Well, for this kind of problem here, not actually, because I was using baseline batch size and optimization parameter and so on. But in case of having the need to have a more complex network and you need to do hyperparameter optimization, you will use grid search or random search techniques as is done for other models. But in this case in particular, I didn't have the need to do hyperparameter optimization.
Okay, thank you very much for your talk, and let's give a round of applause. And the next talk in this room is going to be about building a fact-checking system for rock music by Stefano. Good afternoon, everyone. Friendly reminder that we take questions on Slido. So if you want to ask a question during the talk, you can go to the Slido link on the schedule and then put the question there. And the next, we have Stefano talking about how to build a fact-checking system for rock music. Let's give him a warm welcome.
Hello, everybody. This is Fact-Checking Rocks, how to build a fact-checking baseline using Python open source tools. I am Stefano Fiorucci, a machine learning engineer focused on natural language processing. I'm interested in semantic neural vector search, and I love Python and open source. In this infodemic era, fact-checking is becoming a vital task, but it is time-consuming and hard. And with the latest wave of generative AI, we can expect more and more noise on the web. But the machine learning could also come in our help. And I built a simple, baseline fact-checking system where the user can enter a factual statement, and then our system tries to see if the knowledge base confirms or contradicts our statement. I used the knowledge contained in Wikipedia. I developed this system with modern NLP tools and with zero manual effort for annotation. The final outcome of this experiment is a Streamlit web app hosted on Hugging Face spaces, but we will see it later on. This is the agenda of the talk. Fact-checking rocks is built using the Haystack NLP framework, so I'll cover some Haystack basics, and then I'll show you the idea and the implementation of fact-checking rocks. So let's start. Haystack, by Deepset, is an end-to-end open source NLP framework, and you can use it to build search systems, so semantic search systems, extractive question answering application, also multimodal search application. But you can also use Haystack to build application based on large language models for example, generative question answering, but also more complex decision-making tools. It is modular, so you can use several different databases. You can choose different NLP tasks. It is meant for production, so it can easily scale to millions of documents, and it is customizable and developer-friendly. The document stores play a central role in Haystack. Essentially, you save in the document store documents, metadata, and vector representation. You can use SQL databases, but you can also use enterprise search systems such as OpenSearch or Elasticsearch, and also modern vector databases, including, for example, Wave8 or Quadrant. The node in Haystack is a component which performs a single task. This task can be related to importing data, documents, but the nodes also cover several NLP tasks, including retrieval, classification, summarization, and so on. And you can use these nodes to form pipelines. And usually pipelines are used for indexing or querying purposes. But let's go to the idea of our fact-checking application. First, we have an indexing phase where the data are crawled from Wikipedia, then they are preprocessed and encoded using a language model, and then saved in a document store. At the query time, the user enters the statement to check, then the retriever tries to find the most relevant textual passages, and I developed a custom node called the entailment checker that tries to understand if there is entailment neutral contradiction between the statement to check and the most relevant textual passages. So now let's see the most important components of this system, starting from the retriever. Essentially, a retriever is a component that sweeps through a document store and tries to find the most relevant textual passages. Particularly, the embedding retriever is based on language models from the sentence transformers family that are trained to embed in a shared vector space the textual passages, and similar textual passages are near in this vector space. So at indexing time, you store several passages and represent them as vectors. For example, we can see 3 documents, 2 speaking about Green Day and 1 about Jeff Buckley. And at query time, also the user statement or the query is represented as a vector. And in this example, the query is about the Green Day, and probably the most relevant vectors are those speaking about Green Day. So the embedding retriever has some, use some vector search to perform for you this operation. Let's go to another concept, natural language inference. In NLP, it is the task of determining whether an hypothesis is true, false, or undetermined, given a premise. Here we can see a sample from a training dataset for natural language inference. So you have a premise, an hypothesis, and a label which can be contradiction, neutral, or entailment. So at inference time, if you pass the premise and the hypothesis to such a model, you get back a label. Nowadays, natural language inference models are commonly used for zero-shot classification, but in this project, I'm using them for their original task. And particularly, they are used in the entailment checker node. This node takes as input the most relevant textual passages and the statement to check. Then it computes the textual entailment between each passage and the statement to check. Then inside this node, we aggregate the textual entailment scores by computing a weighted average, where the weight is the score given back by the retriever, the relevance score, which expresses the similarity between the statement to check and the single passage. And then I also applied an empirical consideration. If in the first n documents, where n is less than key, there is a strong evidence of entailment or contradiction, it is better not to consider the less relevant passages, otherwise they would add noise. Yeah, this is the idea. Now we can go to the implementation using Haystack. So we start with the indexing part. I already crawled these JSON files from Wikipedia. You can find the code for the crawling part in the GitHub repository. So now I am creating a list of documents, starting from this JSON, which contains the text and the title and the URL. Then I'm pre-processing the documents, splitting them by chunks of 2 sentences. And I only select document with at least 10 words, otherwise they are not very informative. The second step is about encoding and writing document in the document store. So I first initialize a files document store, which is essentially a vector database based on the Facebook library files. I can also choose different vector databases such as Quadrant or Weaviate. Then by calling the write documents method, I'm storing the text in the document store. I initialize an embedding retriever, which is based on a sentence transformer model, and I choose to also embed the meta field name, which contains the title of the Wikipedia page because it is informative. Then, by calling the method update embeddings, I'm computing and storing the vector representation for these textual passages. So now we have done the indexing part, and we also initialize the embedding retriever. We can go to the implementation of our custom node, the entailment checker. So how to implement a custom node in Haystack? You can find a useful guide from the documentation. So you have to create a new class that inherits from base component. Then you have to set outgoing edges as a class attribute. And if it's not a decision node, there is only one outgoing edge. Then the actual action happens in the run method, where you can pass the data and some configurations. And it should return a tuple, which is composed by a dictionary containing the transformed data, and a string which indicates the outgoing edge. But let's go to the actual implementation. I started with an init a constructor method because I want to define some attributes to be used later. Particularly, I give to the user the possibility to choose to use the GPU or not. And I also load a tokenizer and a model from Hugging Face transformers. And I'm also setting the batch size and some other attributes. Then, in the getEntailment method, the actual inference happens. Here, this method takes as parameters the premise and the hypothesis. So first, I prepare the inputs, and the inputs is consists of the premise, the separator, and the hypothesis. I'm tokenizing this input, and then I make a forward pass in our model, and I get back logics that are unnormalized probabilities. And in order to have normal probabilities, I apply a softmax function. And this method returns an entailment dictionary, which consists of labels as the keys and probability as the values. We can see a simple example of calling this method. I pass as a premise, I have a blue-eyed cat, and as an hypothesis, my cat has yellow eyes, and I get back a dictionary with a probability of contradiction of 0.99. So it's good. Yeah, then the run method. Here, it takes as argument the query, so the statement to check, and the documents, a list of textual passages. And here, I'm calling several times the getEntailment method, passing the textual passage as a premise, and the statement as an hypothesis. And I'm also computing this weighted average. I'm also using this empirical consideration. So if in the first documents there is a strong evidence of entailment or contradiction, I ignore the less relevant documents. And in the end, I return the used documents and an aggregate entailment information containing a summary score about entailment, contradiction, or neutral. Yeah, this implementation is good. And now I can initialize an entailment checker node, which is based on a strong natural language inference model. And I'm creating a simple pipeline for fact-checking by using a retriever and an entailment checker. Now I can try this pipeline. For example, passing the statement, the Smiths have had an influence on other bands. I get this result. And particularly, it contains several information, the used document, and also an aggregate entailment information with strong probabilities of neutral and entailment. So probably the Smiths have had an influence on other bands. But let's see our, somewhat a video demo. You can find the real demo on Hugging Face Spaces. So we start with a simple statement, Elvis Presley is alive. We run our system, and we see that the knowledge base contradicts our statement. I can see the scores, and I can also see the used snippets. And I recently implemented another simple features, so explain using a large language model. In this case, I'm using Flanty5 Large, an open source large language model from Google, which is not so big, but yeah. In this case, I'm passing a specific prompt, so use these text snippets to explain, in this case, why the premise contradicts the hypothesis. And I get Elvis Presley died on 1977, therefore the final answer is no, yeah, which can be a good explanation. Let's try with a more difficult statement. So a statement about the Beach Boys were involved with the Manson family. The knowledge base in this case confirms our statement, but in this case the used snippets were 4, and the explanation, yeah, is not so good in this case, but the model is not so big. It was only an experiment, yeah. So, moment. So let's go to some conclusions. Yeah, this is a simple baseline, and it has some limitation. First, there is no statement detection. In real-world fact-checking or fake news detection, there is the need to detect what are the factual statements to check. And yeah, this part is not covered by this project. Then Wikipedia is taken as a source of truth, as we usually do in NLP, but there are also other interesting approaches, such as taking a snapshot of the entire web as an uncurated source of knowledge, as proposed by a recent Meta paper called Sphere. Another aspect is that there is no effective guarantee that the best textual passage for fact-checking emerge from semantic similarity. An example, if I type the Beatles were influenced by the U2, probably I get back some snippets about the Beatles, some about the U2, but none of these snippets is useful to understand if my statement is true or not. Finally, no organic evaluation was performed, only experiments, and I'm trying to use this simple application also for other domains. And I also have seen a GitHub user that forked my project and adapted it to energy domain in French language. So yeah, maybe it can be sometimes used. We can easily think of ways to improve this system. Particularly, I considered only a small part of Wikipedia for infrastructural limitations, so we can expand the knowledge base. Another interesting approach involves adapting the retriever to the domain using an approach called generative pseudo-labeling, which is unsupervised, and it is included in the haystack framework. I want to give you some consideration about building modern natural language applications. Nowadays, language models and large language models have strong abilities for what concerns text comprehension and generation, but their knowledge is generic, not domain-specific. It is not easily updated over time, and we know that they can easily hallucinate. So a good idea could be to combine them with retrieval system, to give them a source of truth, a source of knowledge, our data, for example. And along these lines, I would like to show you some new features, some interesting features in the A-Stack framework involving large language models, particularly the prompt node, which is an abstraction in A-Stack to simply use large language models, and also the agents. Simply put, an agent is a large language model with a specific prompt that allows this model to perform complex and a series of tasks using also external tools. And these external tools can be deterministic, like a calculator, but also statistical, like other models. And you can also use other A-Stack nodes or pipelines. So I'll show you a little toy example. And we can see from this example, some ideas or the power of this agent. Particularly here, I'm importing my reading list in CSV format. So here I have some books that I want to read with some basic information. Then I define a question answering pipeline on my reading list. Then I also define another pipeline for question answering on the web using Google search or something similar. I'm also instantiating a prompt node used in this question answering on the web, which is based on an OpenAI model in this case. Then, our agent will be powered by a prompt node based on an OpenAI model. Then I also tell that I want to use the pipelines, the already defined pipelines, as tools. And particularly, the table question answering pipeline is useful for when you need to answer questions about the books on my reading list. The web question answering is useful for when you need to Google questions. And these descriptions are important for the large language model. Now I am defining the agent, which is based on the prompt node and on our tools. And finally, I can query my agent with a question like, can you provide me with information about the shortest book on my reading list, including author and price on Amazon? And so we can see, in this case, only 2 steps. But the interesting part of this little example is that I used the large language model as somewhat a linguistic, logic engine. Then I used my knowledge through the reading list question answering, and I used also the knowledge in the web. And last aspect that I want to underline is that in this case I used OpenAI models, but there are other large language models which are supported by A-Stack, and so you can also use the open source model without giving away your data if you can use this model in your infrastructure, which is not simple sometimes. If you want to know more about A-Stack, there is around here the DeepSet team. I am Stefano Fiorucci. You can find me on GitHub, Hugging Face, LinkedIn. And here we also have the Hugging Face spaces and the GitHub repository. Thank you.
Thank you, Stefano, for a great talk. We have lots of questions, so you probably won't be able to get through all of them. But let's start. So the first question is, what are the hardware requirements for a demo like this? Can it run on a laptop, or does it require a GPU?
No, this demo can be run on laptop, doesn't require GPU. I'm using, on Hugging Face Spaces, I'm using the free version, so it runs on CPU. For experimentation on my laptop, I used a smaller model than when I went to Hugging Face. I used larger models, but yeah, you can try in your laptop, I think.
Okay. And the second question, does the type of similarity model affect the fact-checking capabilities as in validity of the app?
What?
Yeah, so does the type of similarity model affect the fact-checking capabilities of the app?
I asked the question. I was wondering if you were to use something like mini-LM or if you were to use something like mini-LM or like if you were to use some other SBERT model, for instance, does it really affect the fact-checking capabilities of this application?
Yeah, I think that the retrieval model is important, and I used, I think, TASB model, which is a sentence transformer model. The particularity of this model, I think, I tried several different models. Moment. Yeah. Marco di Stilbert-based TASB, which is not a large model, but it's not the smallest. And the idea of a particularity of this model is that it can easily compare short statement or short queries with longer textual passages. So
it's a passage retrieval model, and my next question was actually about this because I didn't see this, so I was going to ask what if you were to. So sorry. So my next question that I wrote over there was about this because I know MS Marco is used for long passage retrieval. So I was thinking whether if it would work better to use like a longer context and passage retrieval type of models to you know, have a lower latency and stuff, you know.
Yeah, I think that I should try. In this case, the idea of have only 2 sentences is that if the textual passage becomes very large, a simple sentence transformer model, I think that struggles a bit to. No, the problem is not about the sentence transformer model, but about the natural language inference model. So if the text is longer and the information is diluted, let's say, it's more difficult to compare the textual passage with the statement to check. But yeah, I think.
PR if you want.
But I think that my approach is somewhat naive. Probably you can get better results also applying a chain of thought or other, because I show you that in some cases it can perform well by using information from different textual passages, but these are situations more that are more suitable for chain of thought or other approaches. Like so, I think.
Thank you.
Okay. The next question is, would the entitlement checker be optimized using batching?
Yeah, I know. Surely it can be optimized. I didn't work on this part. Yeah, but.
Okay. So speaking about the optimization, there's also a question, did you play around with different prompts for the optimization?
Yeah, in my case, this explanation part is really a toy part of my project. So I tried several prompts with this model. But yeah, another aspect that I can say about this model is that I had also in this case some infrastructural limitations, but and so my model can be too large, but too big. But in the latest versions of Haystack, you can easily call the Hugging Face inference API, so you can also use bigger models. In this case, probably the prompt would vary, but you can get better results as explanations.
Okay. We still have 5 questions left, but unfortunately we run out of time. So whoever wants to ask more questions, you can find Stefano later on all the social medias and maybe Discord as well. And thank you, Stefano, for the talk and the Q&A. And yeah.
Thank you.
Okay, welcome everyone. Just a reminder that we do questions through Slido, so if you go to the schedule, you have a Slido link, and then you'll be able to ask questions throughout the talk. And as the next speaker, we have Roberto. Roberto will be talking about cybersecurity in the semantic web with Mitra Defend. Yeah.
Hi.
Let's give him a round of applause.
Thank you. So, this is an experimental talk on an experiment, but it is a fun experiment. We will see how to create an application helping us in securely reviewing our architecture using the knowledge graph, the knowledge database about cybersecurity of the Mitre. So we'll start saying that a network is a network of vulnerable nodes. Then we need to classify those nodes. And then we will arrive to our application, an open source editor to design secure architecture. We will see that using this experimental application, we can learn cybersecurity concept through assistive functionalities, and we can have a real-time security assessment. Then we will see how this application works under the hood. There are two very interesting parts. But, well, who are you? Well, I am a solution architect at Partech. I am in the Python community from more than 10 years, and it's a very great community. I came here for the code and stayed for the community. I am a Python enthusiast and an API expert. I support the HTTP, IETF HTTP workgroup for writing standards, and I worked for the Italian government digital transformation team. So, our networks, our infrastructures, our platform are networks of vulnerable node. Each node can be expanded or, well, folded, and it has various levels of complexity. We should identify our level of complexity. And every node has its vulnerabilities, and we can be attacked in different ways, dependently of its categorization. For example, a web application server is attacked in different way with respect to a network node with a public IP or a database. So we want to make security assessment. Okay, we should first classify our nodes. But, well, what does it mean to classify network nodes? And this is an example. We have a website here. Our website is connected to the internet, and a denial of service attacks via internet, okay? And a distributed denial of service is a kind of denial of service. But, well, a website is even executed by a server, and the server is a computer. So this is an example of network. There are different kinds of objects that can be targeted by different attacks. For example, I have an iPhone, an Android phone. They are both mobile devices connected to the internet, and malware can attack via the internet. So these are basically the first example of connection. But as we can see, it's not that. It's not all. We can still continue to expand and unfold this kind of information, this kind of graphs, to identify attacks, walk through these attack paths, and identify mitigation. Well, we said before we had network node classes, attacks and mitigation, but we want to use a classification. The Mitre created this defend classification so that network nodes are branded as digital artifacts. And they can be targeted by different offensive techniques and defended by defensive techniques. There are other blocks, but those are the main blocks. Digital artifacts attacked by, defended by different offensive and defensive techniques. So this is a more in-depth design of digital artifacts. we can see that we have a user application that is an application, that is a software, that is a digital artifact, and that it has children, developer application, a build tool, compiler, and we have a source code analyzer tool that is a static analysis tool, and so on. We have different mitigation technique, defensive technique, credential hardening, and this shows the complexity that we have to target when we want to have a methodology for defining a secure profile of our application. So, defend, classifies network nodes, associating to every class of nodes, to every artifact, a series of possible attacks. The digital artifacts can be databases, routers, container image. You can see that we have prefixes, D3F. This means that those are keywords. They are not just words. They are keywords. They are well-defined. They have definition. So imagine we have a postfix mail server. We know that this is a mail service. A mail service delivers email. Email can be attacked by phishing, can be attacked by malware, and ransomware is a malware. This means that a ransomware can attack through our postfix instance. This doesn't mean that the ransomware attacks the postfix, but can attack through postfix. And on the other side, our postfix server is a network server. It can be executed by a server that it can be attacked by theft. Somebody can come in my data center and can steal the server or can steal server components. Or a network server can be attacked by a denial of service and so on. We are going to understand that this knowledge graph has a lot of information and can be used in thousands of different ways. So when I found it, I asked myself, what can I do with it? Because it's complex, so we can have 1,000 million of paths every time I add a network node. I can have thousands possible more connection. So I said, okay, I want to create an experimental PyScript application so that all my colleagues can play with this tool. So, and this application should use Defend to support the secure design of application and platform. Well, challenging, but the first thing I did was saying, okay, how can I describe my infrastructure? Because all the infrastructure were defined, for example, our customer infrastructure are designed on wonderful images, PDF, PNG. Okay, but those kind of images cannot be processed by a computer. So, okay, I need to create meaningful, when I say meaningful or when I say semantic, I mean meaningful, graph representation of my customer infrastructures, not all those images design, and I need a formal language. Well, one source of formal language is infrastructure as code, and I won't speak about it today, but if you browse the Git repository, you can find something like get my Kubernetes manifest file, generate mermaid graph, generate defend graph from this information, and generate, well, but that's not for today. An open source editor. We have open source editor. Do you know Mermaid.js? Please raise your hand. Okay, the ones you don't know, well, I will show you. It's an open source editor. It's in JavaScript, but you can use text and arrows to create diagrams. and you can add labels, text labels to every node. Then this application is very simple. You write your mermaid diagrams, and in every node, you write d3f dot something. He knows what something is. It can be a database, it can be a volume. He chooses it, makes some magic, but we'll see if we have time, and creates a graph. And then I can query the graph and get the attacks, so the offensive and defensive, the associated defensive and offensive techniques. So in this image, we have the diagrams that is rendered, and then, well, we'll see. So I will just say that when I have a client, instead of just client, I say that client is internet network traffic. I annotate this client with this keyword. Our customized mermaid draws a globe. Well, I haven't found a better image, sorry. But this tells that the traffic comes to and fro into the web. And when I say webmail, I tell you that it's a React. The first one, the far React, is just an icon. It's not a defend keyword, but we process it anyway. And the second one is a defend keyword, and we say this is a web server application. And if we want to say that the client sends email to the web application, we just say client, arrow, pipe, defend email, pipe, webmail. This draws this image, but he knows that the client is sending email in some way, or email information to the webmail. So the client accesses the email, the client produces email, and webmail uses email. Those are semantic information that can be processed to create a security assessment. Moreover, the editor has auto-completion feature, so that when I start writing database, in this case is a web app that communicates to MySQL using database something, because I don't know which are the hundreds of categories that are in defend. I can ask to autocomplete. I can see that I have a database, but the web app is not sending databases to MySQL, but is sending database queries. And he explains what is a database server and what is a database query. At this point, he is capable of identifying all the possible threats associated to the transit of database queries, or to each one of those objects. And what do we have? That this PyScript application is capable of generating a list on the right that says, okay, I have a data volume. This data volume is subject to, well, supply chain attacks, sure. But, well, something we might not think about, direct volume access. So I have a database with a volume, but somebody can access directly the information into the data store. So I can read Mitre documentation or the NSA documentation about direct volume access, and maybe they can suggest you can encrypt this disk, for example, or if somebody steals the disk, you need some physical measures to avoid this kind of direct volume access. At the disk level, at the, for example, container orchestration level, if the disk is provided by a cloud provider or by a container orchestration. Or another issue, disk content wipe. Sure, I should have a backup, but I can even identify other measures to avoid this content wipe. For example, if I have a specific volume that is read-only, I can say, okay, this is mitigated by a technology that doesn't allow to write to this disk. And which is the knowledge required to get all this information? Well, just this one. Instead of webmail, I have to say that this is a D3F volume, and I get information. So it's very easy to use. For every kind of resource, I can create this kind of assessment. I can get from this information that I can export to a ODF all the hyperlink to the websites where I can see in detail of the issues that I have from the webmail, or what does it mean a graphical user interface input capture, for example, keylogging, for example, web portal capture. And this information is available to every colleague that has no knowledge about cybersecurity, because you just say, you should just test your architecture into this Mermaid editor. So since this information is produced in almost real time, just 20 seconds from the moment you write down the design, you can modify your architecture and your diagram as soon as you're writing it. In this way, you can iterate your design before even writing the documentation code or the architectural document. And you can reuse the snippets from previous architecture, surely. So how does it work? It seems cool. It seems easy. Yes, it's easy. But, well, there is this Mitre vocabularies. There are Python libraries that use this vocabulary. I have the Mermaid.js that works for the graphic stuff. And I have PyScript that is the glue. Well, what's that? On the right, in green and purple, and on the small dots, you have the Mitre graph. And in red, there is the node. In reality, I just write the postfix node in my Mermaid graph. I create a graph, a semantic graph from the Mermaid 1, and then I merge this graph into the larger graph that is made of thousands or 10 of thousands possible paths that is produced by Mitre. The best way to do this kind of analysis is using Neo4j that I used to create this graph, but your colleagues maybe are not interested in it, and I wanted to make it simple. So I picked all this graph into a Python library, and I started creating this kind of reports using Python scripts. Then the team manager of my colleagues told me, okay, nobody will use it because they don't know how to launch all this kind of stuff or set up the Neo4j databases and whatever. And I said, okay, let's do it with PyScript. And it seemed to work. With PyScript, I used this RDF lib. And I imported, this is the URL of the graph, defendmitre.org ontologies defend TTL. TTL is the extension of this kind of graph. I imported the graph, I added mine, and then on G, other than parsing, I can querying. It's very intensive computationally, so you need some, because it's in Python and it's in the browser. So the application structure is this one. There is this index HTML that uses the JavaScript libraries to create the diagram. Oh, this is made with Mermaid. The index HTML uses all these libraries packed in a nice wheel file that generate the inner graph and load the inner graph. They reference the Mitre load databases load in the app. So this is into the inner graph, well. And then generate the reports. And, well, you have even a terminal, but it's not interesting. Thank you. I am Well, that's it. I hope it's fun. Questions? Or...
Thank you, Roberto.
Oh, well, just one thing.
You still have 5 minutes if you want to show something else.
Okay, because since I have those minutes, I want to risk it all and say that, well, poof, poof, poof. This is, oh, that, no, not this keyword. Oh, it was fast, strangely. This is all Python, mostly. Okay, the build is failing because it's experiment, as I say it. But you can use it, you can make pull requests, you can enjoy it, you can browse, and you can use the application that now the hamster is running. And for example, you can have, you can design platforms. This is the, oops, it's uninitialized. Okay, this is the graph. I mean, the semantic graph that is merged with the other one, and it is queried through PyScript, through Python. Or you can make your own queries here, but it's slower. And you can create hamster running here. Will it work? I don't know. Yes, it works! 38 possible attacks with, well, it's almost one attack per line of diagram. And it's easy. It's a simple diagram. You can zoom it. Oh, well, it associates to every digital. Can you see this? This is a password database, so something you should play nice. This is an identity server that authenticates the client. There are some other examples. For example, a network. This is a client. Well, what's that? It's internet network traffic, and then a browser that sends requests, HTTP requests, encrypted with TLS to a load balancer that actually is a reverse proxy server, sure, that has a service mesh with a sidecar container in a Kubernetes cluster. This is a container orchestration software, well, which is the security surface. Boom, boom, boom. This is the previous one, hamster running, finger crossing. Okay, and this is it. Let's, what happens when I port knock here? Wow. It worked. I didn't know it. Well, that's it. Questions?
So the first question that we have on Slido, it's actually something that I think you started answering, which is, can you pair it easily with Mitra attack? In essence, get correct defense steps based off an entry in the attack framework.
Excuse me?
Can you pair it easily with Mitra attack, which is the thing that you're showing before us? Yeah, and can you get correct defense steps based off an entry in the attack framework?
Well, you need to analyze the details because it's not very, it doesn't go at CVS level. But when you use this one, you can, well, the security measures I didn't show you. Okay. You can read the security measure, and you can identify and map this kind of, for example, if you want something practical, you should, you could map this kind of information to an easier technical framework like DevSecOps maturity model that has specific tasks. For example, I need to test my configuration. I need to write down integration testing, unit testing. So usually this is a wide area of knowledge, and you have to you have to filter. You cannot just identify just a simple checklist out of this one, but you can, once that you have implemented those measures with respect to the artifacts, you can put this information in the graph, just like Neo4j, and check which artifacts are defended and which are missing. But you cannot do this just with this simple web application. As I said before, this is made to help people to start using Defend, not for people experienced with Defend. I don't know if I answered the question.
Okay, thank you. And the next question is, did you find an easy way to dynamically generate a network graph in Mermaid.js based off the secure infrastructure network, or did that only work in Neo4j?
Well, clearly, it's always an approximation. So you need to, the main part, well, I started knowing the actual graph that I wanted to generate. So I had this one in mind. So while I write down Mermaid.js, I imagined this one. This means that it's easy to generate graphs with Mermaid. You have some problems with the rendering because sometimes to create a faithful graph like this one, you may create a Mermaid graph that is not nice when you see it. For example, you may have stuff moving around or moving in a counterintuitive way. But in general, it's easy, in my opinion, because they are always graph and they are always nodes. So maybe the problem that you have with Mermaid is that what you generate is not visually appealing, but actually it reflects the information flow and the action flow. And probably when we create graphs for our customers, those nice figures, they do not actually reflect the information flows. They are just useful because people that reads them has prior knowledge of how information flow. But they can be even misleading because I can make different assumptions of the flows reading a graph. And so I have to read the documentation and ask. While if you use this kind of description, you always map actions as specific keywords. For example, a privileged user that manages a server creates administrative network traffic. Usually this is implicit when you see diagrams, but this is real, and this network traffic can be on the internet or can be in the internet, and they are different. They have different profiles. So if you want to do something that is useful for security, probably Mermaid is okay. I think Mermaid is okay. But this is complex stuff. Happy to talk.
Okay, Thank you very much. We're just running out of time. So if you have any more questions
for Roberto.
Roberto,
Thank you for your interest.
give any other.
Oh. Yeah, so
Okay, New York,
so
are you ready?
yeah, I'm set. I'm good.
Okay.
Cool. So good afternoon, everyone. Friendly reminder that we do Q&A through Slido. So if you want to ask questions during the presentation, you go to the link in the schedule and you can ask questions there. And for the last session of the day in this room, we have a very special setup. We have two co-speakers. One co-speaker is remote. And we have Christina and Neor, who will talk about efficient communication between Python microservices using GlavinMQ. Let's give them a warm welcome.
Thank you. So can you hear me all right? Everything is good. Great. So hello, everyone. My name is Christina, and I work at 84 Codes as a full stack developer. I'm also a project lead for our open source message broker, LavinMQ. So I'm based in Stockholm, Sweden. And with me today, via Zoom, I have my colleague, Neor. Do you want to introduce yourself?
Yeah, sure. Hi, everybody. Nice to meet you all, even though I can't see anybody. I am Neil Clement, a developer advocate at Cloud MQP by 84 Codes. So before 84 Codes, I'd worked as a Python engineer where I'd used Django a lot, and then at some point, Fast API too. I currently live in Abuja, Nigeria. Yeah, that's it. Over to you, Christina.
Awesome. Okay. So, like we said, we come from 84 Codes, and we're standing in a booth in the big hall among all the sponsors. So maybe I've met some of you, and the rest of you I'm eager to meet. So please go by the booth, and we can talk some more. So 84 Codes was founded in 2012, and we specialize in automating and hosting open source cloud services. Mainly, we specialize in messaging services, but we also host database services like PostgreSQL.
Okay, forgot to, there we go, got it. Okay, so our flagship product is CloudMQP, which hosts RabbitMQ and LavinMQ as a service, so which basically means that we set up and configure RabbitMQ and LavinMQ for our customers. And so today we're here to talk about efficient communication solutions for your Python microservices with our in-house developed message broker, LavinMQ. So now some of you might be familiar with microservice architecture already, but I thought that I would give it a minute or so to just lay a foundation for us to build upon. So first I'm going to talk about what are microservices and what is message queuing. And then I'll do a short explanation on what LavinMQ is, and then I'm going to give the mic to Nior, and he's going to walk us through a use case with Python. Okay, so I think the best way to contrast microservices is to compare it with a monolithic architecture. So the monolith on the left here is tightly coupled, as you see. The services are dependent on each other, basically, to run. And in the beginning of a project, this is totally fine because you don't have that many services or dependencies, really, to mess things up. But as your project starts to grow and the dependencies become more and more, it's more difficult to introduce changes or even scale individual services. And a bug in one part of the application can really affect the whole system and even cause the application to go down. So you can understand why engineers start to look for other, more maintainable solutions for the long run. And that's where microservices come into the picture. These services are completely modular and independent from each other. Changes in one service won't affect changes, or it won't affect the other services at all. And therefore, you have bug isolation. So the project problem that we had with bugs won't really be an issue here. And you also have more freedom in introducing new technologies or new languages. So you could, for example, have 3 services in Python, and you can have some services in Ruby, depending on what kind of expertise you have in your team, which is really neat. Okay, so now with these services completely decoupled, how do they really communicate? So today I'm going to keep it simple. I'm going to talk about synchronous and asynchronous communication. There probably exists some type of hybrid solutions, but I think today it's going to be enough to just talk about synchronous and asynchronous communication. So beginning with synchronous communication, data moves from one endpoint of a service to another in what we call a blocking interaction. So a typical example here would be an HTTP request. So you send a GET request, and then you wait for a response before continuing with any other task that that service might need to do. So this doesn't really allow microservices to be fully autonomous. And the overall performance kind of gets impacted when you have to wait for a long line of responses, right? So this is not the most efficient way to communicate. On the other hand, we then have asynchronous communication. So this is outsourcing the message handling to a third party, which in our case now, we are using a message broker. So here you send requests or messages to the message broker instead of directly to the other services. The message broker will then facilitate these messages until they're consumed by the receiving service. So this service doesn't have to stop and wait for a response, which makes it much more efficient. Services send messages anonymously without needing any information on the other services. And so it only relies on the queue for the message to reach its destination. And this scales much better. The queue can hold like a large amount of messages, and the clients will just fetch them whenever they're ready or when they have the capacity. It's also more reliable. Synchronous messages often have a timeout where the messages will be dropped and you will lose your message. Here, the message queue will facilitate the message until the client's ready. Right, so now I'm just going to show you an example to really illustrate and make it really clear. So here we have 2 services. And when there is a high load on a service, there is a lot of traffic. Here, there's only 3 messages in the illustration, but we'll just pretend that that's a lot of traffic. And then the message queue is facilitating these requests, And this service that we have here in the beginning can continue on with whatever it needs to do while these messages have been sent out into the world. So now we can just wait here for a while until the client is ready to consume the message. So that's pretty good. Now, we have developed our very own message broker, LavinMQ. And it exists on GitHub as an open source project. And the LavinMQ project is all about using the experience that we have with hosting RabbitMQ for about like a decade now, and engaging that experience so that we can build on and improve of the parts of RabbitMQ that we think can be streamlined. So how does it work, really? Here you see an example of a data flow in LavinMQ. It's pretty similar to the example that I just illustrated, but with a few more details. So the producer, we have a producer service and a consumer service. The producer publishes a message with something that we call a routing key to the exchange. And the exchange component receives the message and routes it according to this routing key. So when routing, the exchange looks at this routing key, and it routes the message to the proper queue that the routing key is telling it to route it to. Messages will then stay in this queue until the consumer handles them, and the consumer handles the message in its own time. So that's basically how the message queue works. So now if you're familiar with CloudMQP or with RabbitMQ, this might seem really, really familiar. So what makes our solution different from RabbitMQ? So here we have the three main pillars of LavinMQ. So first of all, it's a super fast broker. It's optimized for performance, and we can benchmark throughput up to 700,000 messages a second, thanks to the priorities that we're making when we're developing. And hand in hand with this performance, we put a really high focus on resource efficiency. So we always try to keep the RAM footprint low for our vision of a more scalable broker, basically. And last but not least, we aim to make it feel like a really lightweight and simple broker. LavinMQ is simple to configure, and it's simple to get running. And we work really hard on our documentation, and we try to put up tutorials for you guys, so it's easy for you to just click around, get it set up and running. Easy. OK, so now since we're on a time schedule, I can't go too much into detail about this broker, which I would really like to do. But you can come by the booth, and we can discuss things, and you can ask questions after the talk, and I'm happy to answer them. So now I'll give the stage to Nior, and he will get into a use case that he has prepared for you guys.
All right. Thank you, Christina. Just to be sure, can they hear me? Christina, just help me confirm if you can hear me.
Yes, I can hear you. Can you guys hear? Everything is fine.
All right, yeah. All right, good. So let's try to build on what we've learned so far by looking at the use case with a sprinkle of Python. And to do that, I'd like to start in a very funny way. I'd want to tell you a story about my friend, Bob. The story of how microservices on LavinMQ saved him. Now, Bob is a Python engineer. I'll tell you more about Bob very much later on, but for now, just know that Bob is a Python engineer at a certain company. So he's not so different from all of us seated here today since we work with Python. One day, Bob just had this crazy idea, SlackGPT. And SlackGPT is basically a Slack bot that brings ChatGPT to Slack, literally. But to help you get a better picture, just think of this bot as some search engine or an AI assistant that sits right in your Slack channel. So you could reach out to it directly with your questions and you get a response immediately. That way you don't have to switch context. For example, go to your browser. Or you could even mention this bot in ongoing conversations and have it participate. So for example, in this demo, we see two people conversing about how to set up a CI/CD pipeline with GitHub Actions. So they weren't really exactly sure how to go about it. So one of them would mention SlackGPT in the conversation, and then SlackGPT will return with a comprehensive steps on how to set up a CI/CD pipeline with GitHub Actions. This is SlackGPT, and this was exactly what Bob had in mind. But you see, before Bob could build this bot, he would have two different iterations of his architecture. Now we're going to look at these two iterations and see what we can learn from Bob's experiences. Stay with me as I walk you through Bob's thought process. Now, first iteration, Bob would build this application as a single unit. I mean, deployed, that could be developed and deployed as a single unit, runs on a single process, basically a monolithic application. This monolith will receive relevant messages from Slack via webhook. It sends these messages to ChatGPT. It gets a response and then sends this response back to Slack. Now, with regards to architecture, at this point, there wasn't really much for Bob to think about, so he moves on to what technologies to use. I mean, he's a Python engineer, so he decided to go with Python. And he's using bold Python to build his bot. Now, if you're not very familiar with bold Python, it's basically a framework that helps you build Slack bots really easily with Python. But the problem with this framework is you can only build Slack bots. So if you're building a bot like this with extensibility in mind, for example, you want to have it work on, let's say, Mattermost or Discord, then I would recommend Airbot. So Airbot does pretty much what bold Python does, but then it has literally out-of-the-box support for all the popular chat applications you could think of. Next, Bob was split. Well, he didn't really split. He would just create two Python models within his monolith. The architecture is still monolithic, but I think at this point, Bob is just trying to modularize, for lack of a simpler word. And lastly, Bob had to decide on whether to use, asynchronous Python or synchronous Python. Now, Bob would go down the asynchronous Python route, now for performance reasons. And I say that because for lack of a really simple word, we could describe this application as being I/O bound. And what that means is whenever a request comes into, whenever the application receives messages from Slack, it would forward these messages to the ChatGPT API, and then it waits for a response. So there's some waiting time involved. Now, writing asynchronous Python would help us, kind of manage this waiting time better to optimize for performance. I must, however, mention that there are different ways of writing asynchronous Python. For example, you could use G events, you could use Greenlets, but then Bob would go down the async.io route. Now, if you're familiar, I'm sure a lot of you are already familiar with async.io here. So if you're familiar and you've worked with it, you know that under the hood, async.io there's no monkey patching happening. So if you're going to use async.io for asynchronous Python, so whatever library you're using has to be asynchronous too, and that would explain why Bob is using AIOHTTP for his request. So now at this point, Bob has pretty much everything he needs to build his monolithic application right. But then in retrospect, he realized that there are a couple of things that could go really wrong with an architecture like this. First of all, there is the problem of tight coupling. So if you look at the diagram on your screen, you'll see that there's a direct connection between the two Python modules in our architecture. Now, this direct link creates, a level of dependency, or coupling, that's the word. It creates a level of coupling that makes it really hard to isolate faults. So in practical terms, because the Slack model relies on the ChatGPT model, if for whatever reason the ChatGPT model is buggy, then the Slack model gets affected automatically. Now, if we're generalizing, like looking at the big picture, you could just say that a situation like this creates a scenario where if you have a model that other models rely on, and that models is buggy, then all the other models are affected. So we end up having a system that is not so resilient or fault tolerant. We could even take this a step further. Let's interrogate these fault tolerance problems from the perspective of infrastructure. This is a monolith developed to a single server. What happens if that server goes down? The application goes down with that server too. But you see, Bob is not like you and me. Bob is obsessed with performance. So he had concerns around performance too. So Bob was worried what would happen if at some point the resource need of his monolithic application outgrows the hardware he gets. And so you could easily argue that Bob could scale vertically, maybe add more CPU cores or increase the memory space, right? Or better still, Bob could scale horizontally, create multiple copies of his application, put them on multiple servers, and then hide them behind the load balancer. I mean, I agree that this would definitely improve performance because then you're going to have multiple servers processing requests concurrently. But no, even this architecture is limited in two major ways. First of all, it is going to be really hard for you to make changes. Remember, the architecture of this application hasn't really changed. It's the deployment topology that has changed, right? So if you make a change to one of the instances, that change has to be reflected on all the instances. Now, this might not be a big deal if you just have 2 or 3 replicas, but in reality, when you work on, let's say, enterprise applications, you're going to have tens or hundreds of these replicas. Now, imagine having to be deployed to tens or hundreds of servers simply because you fixed a very trivial bug. Now, I know Bob personally. He's a very hardworking person. And even for Bob, this level of unnecessary work was a big no. And then there are concerns around how we're scaling. So yes, we're scaling horizontally, right, for performance. But the thing is, when you scale a monolith, you scale the entire application. But then in reality, even within monolith, you're going to have modules or components, and some components would have, you know, more resource needs than the others. When you scale a monolith, you don't think about these things, you just scale the entire thing. Now, taking all these factors into account, Bob thought there's got to be a better way. Now, enter the microservice architecture. This is Bob's second iteration. At this point, Bob will break down his, you know, super large monolith, even though it's not really large in our case. He'll break it down into 2 small services that could be deployed independently. Now, responsibilities haven't really changed much. The Slack bot service will receive messages from Slack, and then the process bot message service would interact directly with the ChatGPT API. Now, the question that really matters here is, how do we get these 2 services to communicate? Well, one obvious way is to, you know, use REST API calls. But then if you go down this route, then there's still going to be that direct connection, and then we start having the same problems we're having with our monoliths, inability to isolate fault, you know, fault tolerance and all that, simply because that coupling is still present, right? And then Bob figured, well, he could decouple his microservices and put a message queue in between the services, basically. So in a scenario like this, the 2 services don't have to talk to each other directly. The Slack bot service would drop messages on the message queue, LiveNM queue, and the process bot message service will pick up these messages and process them at its own pace. Now, the beauty of this architecture lies in the following. Christina, could you help me just move to the next slide? Yeah, so there is total decoupling, right? One of the benefits of an architecture like this is total decoupling, which makes it really easy to isolate bugs, which are a point that Christina has emphasized before. So in more practical terms now, if the process bot message service fails, because the Slack bot service does not really talk directly to the service, it will keep adding messages to the queue as though nothing happened. So whenever the process bot message service is back online, it could pick these messages and process them. Now we've isolated a failure or bug to just one service, not the entire system. Now, there's the beauty of, sorry, I think I pressed now. Okay, this slide. Okay, there is the beauty of being able to scale efficiently too. Now, with microservice, you know, with monolith, if you recall, you have to scale the entire system, but then with a monolith, you just scale the services that you need to scale. So for example, if you notice that the Slack bot service needs more resources, then you could just create more copies of the Slack bot service without really having to touch the process bot message service. And then in the future, if you realize that the process bot message services needs more resources too, then you could create more copies of the process bot message service. It is for these reasons that Bob decided to, you know, I told you he had 2 iterations. First, the monolith, and he ended up working with the microservice architecture for these benefits. Now, at the very start of this, don't worry, we're not starting all over again. At the very beginning, I told you I'd tell you more about Bob, right? Now, Bob is just a figment of my imagination, a character that I just wanted to use and tell the story. But then that doesn't mean this entire story is untrue, because if you take away Bob from this story, everything else is true. And I say that because I built Slack GPT myself, and because I did, I'd be the first to admit that this story is flawed in 2 major ways. First of all, you can really argue that it is an overkill to use the microservice architecture for something as basic as this. And I would totally agree. But then in my defense, right, I was working on this for a tutorial that you can find on our blog, by the way. So the objective for me wasn't really to work on a complex or realistic project. It was just to find a fun and simple project that could help me explain these concepts in the simplest way possible. The second flaw, which is probably the most important one, the challenges of working on a microservice architecture in reality are way beyond and far more profound what we've seen in this story. So let's just look at one of them because we don't really have a lot of time. Now, when you work on the microservice in reality, you're going to have tens or hundreds or even thousands, which is the case with Netflix. You're going to have a lot of services. And in a situation like that, right, you're going to have instances where a request from a client would need data from multiple services. So for example, on an e-commerce website, if you go to a product page, and hypothetically speaking, let's say that e-commerce website is running a microservice architecture under the hood, right? If you go to a product page, a request for the product detail will most likely be getting data from the product service, from the reviews and ratings service, because you need the reviews and ratings for the products too, and from the recommendation service too, right? Now, the question is, how do you get this client to communicate with your services? One way is to just make direct API calls to this service, which is what you're seeing on the screen. But the problem with that, if you adopt that technique, then you would have to, for one data, like you need like the details of a product, then you have to make like up to, in our case, 4 separate API calls to get that data. Now, if you have multiple clients, you have to replicate that call across all your clients. Christina, next slide. Yeah, so you have to replicate it across all your clients, right? Now, this is not so good, but it doesn't even end here. What if in the future you decide to break, let's say, the review and rating service into 2 separate services? You'd have to make an update to all your clients too. Now, one way to solve this problem is to adopt, the API gateway pattern. Next slide. Yeah, so in the API gateway, you kind of introduce an abstraction layer, right, that hides the low-level implementation details of your microservice architecture. So if a client wants to get the detail of a product, they just make one API call, and your API gateway would be responsible for getting talking to all the relevant microservices. One other technique which I really didn't add to this slide is to adopt the back end for front end pattern where you create an API gateway for each client, basically. Yeah, and so, I mean, the challenges are numerous. Sometimes you have to think about data consistency too and how to deploy. But we just tried to keep everything basic throughout this presentation, hoping that you could ask questions and we could have deeper conversations around this concept. Thank you.
Awesome.
Thank you. Thank you for a talk. We don't have any questions on Slido yet, so I'm going to start with the first question about what's the main difference between LavenMQ and something like RabbitMQ? Why create yet another broker, I guess?
Well, I guess like I said, we have a really long time of experience of hosting RabbitMQ services. So you're bound to find things that you want to change or that you feel can be more efficient. So basically, the LavenMQ project is just to try to get that into the world, basically. And so there are some performance optimizations and resource efficiency optimizations that make it a lot faster. And that's like the primary difference, that it's a lot faster. But I also want to say that it's a lot more lightweight. So it's not at all the big beast that RabbitMQ is. On good and bad terms, I guess. On good terms, that it's really simple to set up and use. And then, of course, there are things in LavenMQ that or there are things in RabbitMQ that LavinMQ don't support yet. So like plugins, for example. But we're also a really small team, very agile. So if anybody has any recommendations for how we should add new features, then you're more than welcome to input or like make a pull request to the Git repository. We're always happy to take those. So yeah.
Okay, so I have a follow-up question on that one. When you mentioned that we welcome the pull request, given that the main object of the product is the performance versus, for example, RabbitMQ that is faster. How would the process of getting some major changes, if somebody wanted to contribute something, looks like? Do you basically somebody submits a pull request, or should they like ask first of like how to make some changes and not interfere with those opinionated set of opinions?
Right, so that's a really good question. It kind of depends. If you want to do the code yourself and you have a very specific idea of how you want to do it, then definitely feel free to just commit something, or not commit it, but make a pull request, and we can review it. But I think maybe that it would be actually faster to just hit us up on like GitHub Discuss, and we can implement it the way that we know how to, and yeah.
And there was one question on Slido about the tooling around. So like Rabbit has some nice admin UI, and is there any other, like for LavinMQ, is there also like a compatible set of tools or
Yeah, sure, yeah, exactly. So there is a complete UI manager that you can use, specifically if you want to use it with CloudAMQP, you even get the CloudAMQP interface, and yeah, that's also linked to the management UI. So basically, it has all of the things that RabbitMQ has in the UI.
Okay.
Yeah.
Cool. And we had some questions.
Hi there. I want to ask you a few things. First, like, what kind of technology is implemented LavinMQ? I don't know if you said it before or not. And if it's able to like scale for real-time data-intensive analytics, like can you have it like multi-process or kind of scale on the traffic?
Okay. So the first question, what technology we use? So it's built in Crystal, which is a fairly small language, pretty similar to Ruby, but it's compiled, so it's really fast. So that's like one of the performance things that we just try to squeeze in there. What like type of technology are you suggesting?
What do you mean? I was asking like, what kind of language was based on? Yeah.
So it's not based on Python, unfortunately, but we use Crystal. We really like Crystal. It's really fast, and its standard library is all in Crystal, so it's really easy for us to use and read and write. So yeah.
Yeah, and the other question was like, is it possible like to distribute like the broker on more machine, like in Kafka, for example, like you can have like multiple process, like for serving data-intensive messages.
I'm not sure if I understand the question.
Like if you have like a lot of like message,
like a multiple node
yeah, like
cluster?
a huge traffic, so you can like.
Right. Yeah. So no, LavinMQ is a single node broker for now. We are actually working on replication, but we have one node. But since it is so performance focused and resource efficient, it can handle a lot more traffic than a single RabbitMQ node can handle.
Okay, that's a short question.
Okay, I never use a RabbitMQ, so maybe my question seems strange. I'm long-term user of ZeroMQ, like 8 years I use them. ZeroMQ has different patterns of communication. Now, from your last answer, I understood that this is a single server, like a star in the middle, and everybody sends and receives data through this server.
Yes.
So, what pattern of communication can you have? Just request reply, or there is also push pull, publish subscribe?
No, it's like let's see if I can. Where is my? So basically, the way that I know how to answer that question is just like to show you this this slide again. So basically, you have producers and consumers. It just goes right through the broker.
One way.
Oh, you can, yeah, one way. But you can, of course.
Christina, Christina, can I just chip in?
Of course.
Yeah, so I think I understand your question. You want to understand what patterns of communication LiveNMQ supports, right? Is that what you're asking?
Yes, I mean, if you can have
yes.
different patterns like publish subscriber with the topic. Oh, sorry. Like publish subscriber with the topic, and there is filtering or push pull, meaning you have you have multiple pullers. You push a message, and only one puller gets the message.
Yeah,
Funny
so
in, fun
I think I
out.
understand you. Yeah, so from what I know so far, I think I've been working on LiveNMQ for some time now too. I'm writing a tutorial. So I know that it supports the publish subscribe, right, which you just mentioned. And it supports the competing consumer pattern too, where you put a message, you add a message to the queue, and then the queue sends this message. Only one consumer could consume a message, right? One-to-one relationship too. And then there is the topics which you mentioned. So basically, the pattern of communications are tied to the types of exchanges that we have in LiveNMQ. And yeah, so I know that we have the pop sub and we have the competing consumer pattern and we have topics too. Yeah.
Okay, thank you for the talk. We will run out of time. So thank you, Christina, and thanks, Junior. And let's give a round of applause.
All right.
Yeah, and I'm afraid we all have to leave the
Okay,
room
bye,
because it's
Nior.
going to be changing for lightning talk.
All right. Bye.
Così, prova, prova. 1, 2, 3, 1, 2, 3.
Hello there. How are you? You! So we have another wonderful keynote. Right now is Donatella Taurasi, professor of finance and data science in Berkeley. And she's going to talk about a very important topic, about the dialogue between different roles in tech, in finance. So the stage is yours. Again, a great warming applause for Donatella. And just a reminder, you can submit your questions on Slido, Keynote. Please go ahead, and we have a few minutes at the end. Thank you again.
Thank you. Thank you. Hello, everyone. How are you? How are you doing? Great. I'm so glad to be the one thing that keeps you from your spritz on the other side of this, right? I just realized I'm right before your aperitivo, your dinner time, so good thing I like a challenge. So thank you for that generous introduction. My name is Donatella Taurasi, and I'm really glad to be here with you today. It's amazing to have such much knowledge, willingness to learn, to challenge our mindsets, and also creativity, all in one big room. So I'm really honored to be here. Thank you to the organizers and the teams, the teams that were able to put this event together. It's very challenging. I do this often in my line of work. Just make sure you thank the staff as you walk around. It's a very hard job to do. So today, I come here with a message from the business people. And you know the rules. We don't shoot the messenger, okay? We just take the message at heart. What is the message? The message is from business leaders, and their message is clearly, we are desperate to work with you and to do it well. We want to really extract every last ounce of value from what you do and the way you do it. Those are exactly the same type of people that you avoid at all costs. And don't try to deny it. I have way too many years under the belt working with companies all over the world, and I have experienced firsthand this dysfunctional relationship, right? It's literally two different people, different backgrounds, different languages that, in theory, are on the same team, but somehow they work towards totally different objectives. And believe it or not, that is costly. It's costly to our profession, to what we're trying to do and accomplish, and of course, it's costly for companies. So today, I'd like to pack this message with both some motivation, and here I'm going to lead a bit by fear, the California way, and I'm going to also try to give you few tips, few tools you can use to perhaps do your part. Because this gap is there, we are painfully aware of it, and we see some effort put forward from the business side of the companies, but regrettably, I don't take this personally, we see very little effort on the technical side of the team. So I'm trying to fix that, and hopefully we're going to have a constructive conversation. Please send forward your questions. I'm very happy to try and answer them. So why me? Why now? Why here? My name is Donatella Taurasi, as we were saying earlier. I'm the Made in Italy professor in California. So I actually started my PhD here in Italy in finance. I was always mesmerized with how sophisticated and complex the math in finance was, and yet it was extremely practical, right? You could learn every day and apply what you learned in your real life on a daily basis. But where I really started being interested in data science is when I did part of my PhD between NYU and California. And in California, I understood how my passion really sat into empirical research. And we know, finance has always been a data-rich field, right? There's so much data I could really get, right? And yet, data was disappointing. It was very hard to do any meaningful research or empirical research we stayed alone. And I was really, really fortunate to be marinating, breathing the excitement around machine learning and data science that was growing in California where I was getting my PhD. Now, you can kind of map my age there, but do not say that out loud. So the idea there is I finally got closer to data science, I got closer to machine learning, and I was really able to bring my research forward because of these skills. And that's where the combination, the intersection between finance and data science came to life. And that's exactly what I do at Berkeley. As soon as I got my PhD, they offered me a job, and my job was one of my hats. I like to say I wear many hats. One of my hats was to teach, to infuse the core curriculum in the business schools with data science, analytics, data, technology. But I was also put in charge of training engineers, computer science fields. Why? Because while a lot of people were learning all these wonderful tools, they were having a very hard time understanding how to apply them. So this was one of the ways business schools were trying to bridge that gap between technical and business side. But I like to talk the talk. So I also wear the hat of Chief Science Officer in a forward-looking asset management company based in San Francisco, Global Human Investment, that allows me again to bridge, right? To bridge the academic view with what practitioners do in practice. And this bridge, the ability to bring together science and what practitioners actually do in the field allows us to create better investment choices for our customers. And although I wear different hats, where my heart is actually education. There's nothing more powerful than educating and training people, exposing individuals to the future they can possibly imagine and create. So I'm very glad to be working with the Data Masters team. Some of you are here, say hi. I'm sure you met them around. I am actually, yeah, they should deserve a clap, but it's okay. And the reason why, regardless of the very little time I have, I really like working with Data Masters is because they are taking the mission I have at heart and they're putting it in action. They educate and they train individuals to learn the tools and the skills, but also the focus on the application. And that's the key word today. We need to learn how to apply what we know. So as an educator, I was told very early on by an educator with a Nobel Prize that I really admire, that educators are in the business of making people uncomfortable. So get ready, prepare to be uncomfortable. Let's be comfortable with being uncomfortable. The idea today is we're going to challenge, question the status quo. What is the status quo? What we've been doing for the last 10, 15, 20 years. Think about it. What has been the core of our interest? We've been training, right? We've been giving this message that what matters is that we need to learn all the skills. We need to master all the tools. We need to know exactly what's going on in that black box, right? That's what it matters. So we've been investing in that. Any single training product, any educational program is focusing on that, okay? That's been going on for a long time and keeps going on. And of course, we've been investing in data infrastructure. 2020 came along, and what happened? We all went digital, right? So more data came in. And again, more sophisticated technologies came along to help us deal with this influx of data. And again, all we did was to focus on the technology and on the tools. We've been investing in business intelligence tools, right? We've been growing our teams at an incredible pace with no questions asked from the CFO of our companies, right? We have made history in pioneering the first 8-figure technology stacks with really no questions asked from our CFOs, Chief Financial Officers. Why is that? Because companies out there were looking out at the Nexuses and the Googles and the Amazons of the world, and what they believed was we had to become like them. It was the easiest thing to do. Let's buy the infrastructure, let's buy the data, let's hire those PhDs, right, that come out of computer science and engineering schools. Did we ever stop a moment and think, is this really bringing value to the table? Are we really converting this effort into value for the company? This is our status quo. We see now, we experienced in the last few years, a skepticism from the business world. They stopped investing. They stopped putting faith in our effort. And that, as we know, could be fatal. That's the worst possible thing a business could do right now, just move away from data and facts. And yet, we are part of the problem, so we have to work on that. And one of the reasons is that we do not communicate. I'm going to give you a second to absorb this. I know, you're a heron right now, right? That's your lingo. That's how you feel the happiest, right? Now, I can't deny it. I was kind of excited, but at the same time depressed by the fact that we actually deciphered that. Like, this is how you guys talk. This is how we talk. And we are expecting non-technical stakeholders to actually understand us and even want to talk to us. Now, don't get me wrong. That's all good stuff. It's amazing. And you're going to find people you work with that are going to totally understand you and talk in the same sort lingo. That's great. But our job isn't limited to our team, right? Or our peers or our communities. Our job is to work towards a common objective, and that's our company's project, or organization's objective. So we have to work on that. And we need to start really to understand that we need to find a way to quantify the value of our work. We need to start converting our initiatives, our data endeavors, into value. We have to demonstrate that value to our business stakeholders. So every time we have a project, every time we have any data initiative in our company, we need to really prove that that investment is aligned with the company's objective. We need to stop, kind of like move away from the hype and start talking about impact. And only that, if we do that, that would be a winning strategy in gaining back the trust from the business stakeholders. And you know why we need the business stakeholders? Because that's who allocates the budget. That's who gets our project from a project to a deployment at scale that becomes a product, a service that changes entire industries. Without that buy-in, we're just having fun. And that's called academia. That's where you want to do that. You don't work in a business to do that, right? So let's try to dive a bit deeper and understand where we can make those changes and how we can make them. Now, I want to bring this message home with a few examples. And I'm sure you're familiar with at least one, but probably most of them. But please indulge me. I really want to, as I was saying, I'm going to lead by fear. Really want to bring home the message that this matters. What we do matters. And what I want to talk about today here is how we make it matter in practice. Familiar with the Blockbuster versus Netflix story, right? Blockbuster, dominant player in the video rental industry, right? Thousands of stores worldwide. What did they do wrong? Anyone? Why? They didn't buy Netflix. Why is that? They made a fatal mistake, right? They were disconnected from data and facts. They had a data team, they just didn't listen. Or perhaps didn't listen because the data team wasn't doing that kind of research, getting insight, understanding market trends, right? In the meantime, Netflix did all the right things. You can take it, we don't mind. Did all the right things. He used data, like a digital platform, right? He used data to understand users' preferences. He used data to make personalized recommendations. He used data to invest in the right streaming technologies. Now, it was 88 billion in 2016. Was that double the value now? More, right? It's huge. 160 billion, something like that. And story repeats itself. Same identical idea, right? Kodak, dominant player. He just didn't have enough insight. He just didn't believe in the trends in the market and made the wrong bet. He actually What they did at Kodak is what happens most of the time. They actually put money into gaining early on knowledge in the digital photography. They even had patents. They just decided to stay in their comfort zone, right? To stay comfortable. They betted that the current business model will be the winning business model of the future. That's really very, very rarely the case. It's definitely not what happens nowadays, because things change very quickly. Nokia was on the Forbes cover 2007. Who's gonna catch Nokia, right? Dominant player, and another mistake. They all have something in common here. Disconnection between data and decisions at the business level. Just not enough trust in what the data tell us. But why? Why this disconnect? And well, actually, this story tells us something else too, right? Do not aim at ending up on a Forbes cover, okay? Turns out that anyone who ends there either ends in jail or something else, so that's not probably a good sign. So what is keeping companies from avoiding this fate? Because that story, I can bring you other hundreds of examples. This story repeats itself at different scales, but repeats itself over and over again. What is it? If you read, I hope you can read this. If you read this, and I can bring you so many infographics that tell you the same story. I just took Gardner because I like Gardner, but the story is the same. What is it? First, foremost, culture challenges to accept change. Really? We are change averse? What a surprise, right? We don't like change. We need to be nudged into change. And why don't we like change? Because we don't know what's going to happen when we change, right? So we need to beat ourselves at that game. Well, of course, if you don't like change, then you're not going to invest in making that change happen. And why don't you trust that change? Well, perhaps because you don't know what that change is about. That goes into data literacy, right? Another big painful point. We don't do enough to spread the news about data science, artificial intelligence. We don't make the effort of making it understandable, accessible to people that might not speak our lingo. And of course, lack of skills, right? We have lack of understanding of data literacy in general, but also we actually lack the specialized skills we need at a specific time in the growth of our company. When early on companies were hiring data professionals at an incredible pace, they were just poaching people from academia, which wasn't the right move, right? Because yes, we need the researcher, but we also need all the other people involved in the process, and those were not part of that team. So this is definitely something we can help with, right? We can be the evangelists. We can be the ones who bring data and data science to everybody in the company. And this is part of our mission. Remember the 3 V's of big data by Taglani? Right? In the early 2000s, we had to explain what big data was, right? And so we came up with, volume, velocity, variety. Whereas done data wrangling in their lives, they know how difficult big data can be. But as the world has changed, we actually been adding more V's. The main 2 are veracity and value. Those it's missing from our job today. We need to make sure of the quality of the data we are using, but also we need to understand the value that the data we are processing, using, and learning from is actually creating value for the bottom line for our organizations. So what is the way we're going to move towards companies where data professionals and business stakeholders can actually communicate and work together? Well, there's only 5 steps. And if you read through them, they seem pretty straightforward. Embrace the business, right? Learn about the business. Foster communication also asynchronously. Be welcome towards feedback. Become invested with the data. Get to know the data you work with in the context. Know where your data's been. Know your data's life cycle. And create a semantic layer. Let's all speak the same language when it comes to the important things we're trying to measure. When you read this, I think you feel like a bit cheated on, right? You feel like, I came here to learn something. This seems pretty straightforward, right? Trivial almost. Well, it's easier said than done. I've been observing companies all over the place. And even though I'm tasked with the exact goal to bring data culture to the company, to bring the data teams and the business teams closer together, I see data teams struggle over and over again in executing on these ideas and actually maintaining them over time, making scale them and sustain them over time. So let's see what these steps are. Let's see if we can actually make sense of that. First of all, this first step is about nurturing, creating data empathy. What's data empathy? It's like empathy in any other context. We have to be understanding and considering of other people's preferences, considerations, needs of other people's, individuals, or teams that work with data. And what we have to understand is that when it comes to data science, when it comes to analytics, processes can be very complex. The jargon can be very complex. And it can be very difficult for non-technical professionals to grasp the meaning behind those processes and this jargon. So it's our job to communicate the data in a manner that is accessible, that is meaningful, that is actually relevant, given those individuals' needs. That's our job. And that's why we've been talking over and over again about storytelling when it comes to data professionals, right? The idea of being able to look at the data, look at our analysis, and actually be able to tell a story about what that data is and what we're trying to get out of it. That's how we get people excited about what we're doing, because we actually make it accessible. They understand what we're doing. But why does that matter? Why do we have to put so much effort into this? They can just go to school and learn about it, right? Why? That's how you create mutual trust. Would you trust something or someone you don't know anything about? You might try, but the first time you are burned, right? Something goes wrong, or you're going to blame that. It's the first thing you can blame. Why? Because you're not touched. You know nothing about that. That's exactly what happens in the company. Anything that goes wrong gets blamed on the most obscure team. And the most obscure team's operations is the data team. That's for sure, right? So that is a very important aspect of it. So how can we do it? Take a proactive approach. Get to know the people that matter in the business, the ones who set the strategic objectives. How do you do that? How do you get to know people? You ask them what to do, what they do, what they care about, what are the priorities. How do you do that? You schedule a weekly meeting with them. That's how you do. That's how you do everything. It's really just networking. You go and talk to them, and you understand what's going on, and you talk in terms they can understand. What do you use that table for? What do you think that metric is actually measuring or capturing? If data is delayed, who should I notify first? Who is going to suffer the most? That's how you do it. You try to get at their level, meet them where they are. It's the only way to build that trust. Now, the other part is, of course, communication should be channels should be always available. And in the world we live in, meeting in person becomes pretty hard, right? And sometimes we just don't want to have a conversation about everything, right? Sometimes I just want to send a text to my husband and tell me that, and knowing me, don't do it again, okay? That's all you want to do. So what you want to do is create a system that allows people to provide feedback insights without the need of a real-time response of interaction. And you want a feedback loop, because in that way, you actually commit to taking that feedback into account and act on it. And you want this to be accessible, right? An open platform where everybody can actually interact. Why? Because you want that everyone's interests, every stakeholder's needs be represented. So as the data team, you get an insight on what matters for the stakeholders. As stakeholders, they can actually figure out what other stakeholders care about, what their peers care about. And I really like the role that this type of collaborative system achieves, because as an organization, you can tap on the collective intelligence of the organization. So you actually can put in place actions that really foster the growth mindset that you need in order to thrive as an organization. So this is very important. And how do you do this in practice? Of course, you can have online platform, you can have collaborative platforms, but most companies just use chat platforms, like Slack or Teams. That works great. Just have one dedicated channel where people can interact, provide feedback, and see how things progress. Now, becoming invested with the data is where you start going from talking the talk to actually walking the walk. This is where your genius, your creativity, your understanding of what's going on in the company takes shape. So you really want to avoid what most of us does, and I'm guilty of this too. As soon as I have data, what do you do? As soon as you have data, and as soon as you made it structured, clean, etc., what do? You just explore, right? That's what we call it. You just want to do something, and what do? You just use the most sophisticated tools you just learned that to use, right? So you just try all of them, because why not? It's easy. How many of us sit with the data for a few days? How many of us question that source of that data? What does each single column really tell us? What is even the unit in which it's measured, right? How many of us really do that work? Very rarely, not enough for sure. So being investigated means really understand what the data is telling you, what's possible. And here, in this phase, you have to be developing a culture of experimentation. Experiments are the most powerful tool in our hands. Think about it. You can, with experiments, provide almost a receipt to the CEO of the work you're doing. You can really attach a value that is grounded in proper theory of what the added value of that task is going to be, the outcome is going to be. There's nothing else like that. You can actually measure the return on investment in a very reliable and a very strong way. And yet, so much is written about machine learning and dashboards. Very little is written about p-values and A/B tests, right? Because that sounds sexy. That's not something we like to do. But this is where we convert ideas into value. And now I know your skeptical looks. I see your eyes rolling at me every time I talk about value and creating value and ROI. Now, it might be my finance background talking here, but how do you make a decision? When you have many projects, many options in front of you, and you deal with limited resources, maybe budget, know-how, time. How do you make a decision? What's your guiding criteria? You know where I come from? Finance background. You attach a value to each of those projects. And you gotta do it, euro, dollars, or yen, it doesn't matter. You have to attach a value to them, and then what you do? Once you attach a value to each of them, you can pick the one project or the subset of projects that maximizes your objective. You see how many things you need to know there to make the decision? It's not straightforward, right? So we need to do that. But how do we do that? How do we create a culture of experimentation? How do we make it so easy for companies to be on board with experiments? Why is it so hard for business leaders to accept experiments as a modus operandi? Experiments come with a probability of failure, the F word. He said it, not me. Failure. Gosh, business leaders hate those words, right? Failure is just the worst possible thing to ever mention utter in front of business leaders. Why? Because it's the opposite of success. Failure is like we got it wrong. We wasted resources and time. I cannot go to the board and say, oh, we failed an experiment, yippee. But in our world, failure is good. If you can run your experiments right, if you can kind of slice your big idea in small pieces and run experiment after experiment, then failure is a welcome, refreshing source of very cheap information, right? Well, I was just saying expensive information, it's never cheap, right? So we need to do that. We need to teach business leaders that failure is good. Failure does not define us. Failure teaches us what to avoid the next time we try to do the same thing, right? It brings us a step closer to what we need to achieve. Better product, better user engagement, whatever. And then brings me to another very important part of this very long slide, apparently, To be able to run experiments, to be able to really get the business leaders on board, we need to identify a North Star metric. How many of you have identified a North Star metric in your lives? Oh, North Star metric? Okay, one. You're so shy, guys. I promise you're going to have a spritz at the end, okay? It's going to happen. That's important. What do we need as one metric? Something we aim at. One goal in common. You work more united when you actually have a goal in mind, and that's even better if that goal is aligned with the strategic objectives of the company, right? So you have to identify what is you drive these experiments, but what are you trying to achieve, really? So we go back to that value. For example, for e-commerce platform, the usual North Star metric is number of purchases completed in a day, or perhaps customer lifetime value. If you are a social media platform, you might look at engagement, right? You want one or more, definitely a few, not too many, metrics that are clear to everybody. Every single vertical in a company understands that metric, agrees upon the metric, and everybody can work towards that metric. So guess what? When we all agree, especially business stakeholders, and we all work towards the same goal, then we can actually compare apples to apples. And that is priceless. That is something that's really hard to do, even in conventional areas like finance or marketing. And once you do all of that, do not even try to run a big experiment. Do not even get close to those monumental initiatives, where you want to develop a product, it's going to take forever to do, and then you have to collect data, and then you have to analyze them, and the momentum is gone. Focus on small wins. Identify small niches where you can make a difference. Small, non-controversial wins, okay? That's the key. Small, non-controversial wins. Even with those kind of experiments, you can make a large impact, okay? If you need the use cases, come to me later. I'll give you all the references. Make sure you build that momentum. Why do you want to do that? Because first of all, you want to build that trust, right? You want to do something that's not costly to the company, it's not controversial, and you start showing that it actually can work. It makes sense. We can change small things and measure the impact of that small thing. The other thing, it gets you a chance to test your processes, your infrastructure, the skills within the team, so that you can actually scale it up much easier. Now, I want to stress something here. You're not going to like it, but that's my job today. Remember, embrace the uncomfortable. Our job does not stop in providing those, building those dashboards and showing metrics to our non-technical stakeholders. Our job does not end there. We need to be part of the whole process. That means running the experiment, be proactive in terms of experiments, and help interpret the results, and help translate those results in actionable recommendations. We need to take ownership of our projects. We can't just drop the ball midway. This is the only way we can make sure that we are working towards the same objective, and the only way we can actually show with strong evidence that what we do is moving the needle, is making a difference in the company. That's how we ensure ongoing investment in our own data infrastructure and talent. So our job sits in between is exploring and exploiting, right? We keep enjoying the wonderful things we do about reducing costs, improving operations efficiency, et cetera, but our job is also being proactive, finding new insights, understanding new areas, bringing forward new strategies. That is what keeps companies really ahead of the game, right? So in line with Henry Ford's quote, when he mentioned how customers would have asked for faster horses because they couldn't possibly imagine such a revolutionary idea like the car, the automobile, stakeholders are the same. If you go ask them, they might just tell you, I want faster dashboards, right? That's totally probable. They've probably done it already, right? We have to go beyond that. So yes, be in touch, stay in line with what the objectives, the strategy of the company is, but be proactive. Do your job. Explore. Be the human mind that's being augmented by machine learning and not made like a robot by machine learning. Now, visuals work with non-technical people. So I always recommend using some sort of workflow for data science, right? This is the lean approach. So I like this because it really provides a clear picture. You can actually use icons or pictures. You can communicate the way you want. You can be very creative. And again, if you need inputs, come to me later. I'm happy to share. The idea is you go through this cycle with the other stakeholders. You talk about the problem, you identify the opportunity, you talk about all the possible roadblocks. You actually, kind of have, you see how this arrow has both directions back and forth? You really stress this idea that what we do is, in nature, iterative. What we do has built-in failure, and only that failure allows us to improve on what we did before, and over again. It's not ever at the end of improvement. The idea is fostering this idea of growth mindset, right? Where we keep on improving. We don't actually stop. Even when we are satisfied with it, the best of us keep trying, right? Keep improving. That's what makes a difference. Now, one thing that we noticed, especially after the Snowflake success and the data influx of 2020, is that we have no idea where our data has been and where it's going, right? We have no idea how our data has been used in the company. We have no idea what's the end use of it. So it's very important to understand how data is used in the company, what are the main stakeholders, and more importantly, the quality of that data. That's why I'm so excited about data lineage. I don't know if many of you, probably most of you work with it. It used to be such a tedious manual work to keep track of data, to understand all of that. And now, thanks to automation and machine learning, it's easy peasy, right? We can scale it up easily, and we can really focus on the one aspect that we should care about. We used to have to focus on the volume. What we need is to focus on the veracity, right? We can actually really track the life cycle of the data source and really verify the goodness of that data, right? Can we actually trust it? Can we actually use it for the types of analysis we are interested in too? So make sure you do all of that, and do not forget documentations, okay? I work with very large tech companies. Each single engineer, there are 2 engineers per team who have 2 hours per week. You know how much hourly salary a guru is? They have to sit down and produce documentation. And they have to link it everywhere. It's everywhere. So remember that. Keep documentation up to date. And last but not least, we have to find a way to create a semantic layer. A standardized, organized, approach to having, rely on information within the organization. We need to know what we mean, how we do it. And that's really hard to do, really, but the only thing I want to stress here is that we need to understand our North Star metrics, right? We really need to understand our North Star metrics. So if we don't agree on what that North Star metric is and how we build it, how we measure it, how we track it, then it's going to be very hard to have all the same objective. So this semantic layer is going to help us measure success in the same way. And then it becomes complex depending on what's the vertical, what's the specific goal of the team. So make sure you at least do it in that specific context. And of course, this is a world where we have to allow for change. Change just happens all the time. Make sure you update the semantic layer as you go. Now, let's switch gears a moment. And how many of you have taken statistics in their lives? How many of you use statistics on a daily basis? Yeah, that tracks. All right, so what are the types of errors we can make? Not our fault, of course. At least the first couple won't be your fault. Other one will say. First error, right? What did we do here wrong? Yeah, we did that, didn't we? Of course, the second error goes our usual false negative, right? You fail to reject the null hypothesis. That's not good. You guys remember what type 3 error is? I know. Only in academia we track that. What's type 3 error? It's our plague, guys. That's what plagues data science everywhere. It's when you do everything right. Right math, right tools, right theory, everything is great. But you put all that effort in doing what? In answering the wrong question. That's really disappointing, isn't it? This is the problem. Whose fault is this? I honestly blame academia. And not because the statistics class was not good. It's because we've been focused so much on those tools in the black box. How does it work? Everything detail. We train PhDs and computer science, engineering in understanding how every single tool works, right? What's inside that black box? And now the nitty-gritty details, the bolts, the nodes. And that makes sense. We want beautiful new products, right? Tools and technology, and that makes a lot of sense. But as time has gone by, now we have so many freaking tools, right? We have so much sophistication. But we've lost track with the other aspect of machine learning, that is the applied side. We spend so much time at defining the math and finding the right data set and figuring out the code, right, the algorithm. But we never really stopped. We were never really asked to stop and think about how do we ask the right questions from this data. What is the problem I'm trying to resolve? Nobody trains us to do it. And when I think, when I talk to you, business people have made some effort and made some progress, it's because business schools like the one I work at has made progress in trying to teach and trying to align in that domain. But unfortunately, the tech world has not been able to catch up as quickly. And the future, of course, is going to be in that direction. And this is really where we're going, right? The idea is we really focused on the sophistication of the math, the algorithm technology, and the data, but we haven't really learned how to solve the right problems, how to ask the right question. And this is where decision intelligence comes in. Decision intelligence is applied machine learning, analytics, data science, augmented by all the other many of the other social sciences, right? Applied psychology, managerial sciences, decisional sciences, all the other sanity check sciences that we need to help us frame the problem and therefore ask the question the right way. And we can't really find that unless our teams represent all these skills. So if we have companies that keep hiring researchers out of academia, or poaching famous researchers from academia, then all we're doing is going and keep nurturing the side of machine learning that does research, which is great. I don't have any nothing against that. But then we are taking away from the other side, which is the applied side, how we turn what we do in actual value. So the future, what leads to good decision makers, includes a third component, which is let's think about what we're trying to do, and let's do it by applying some common sense. Let's stare at that data a bit longer. Let's work on visualizations a bit longer, right? We forget something very important. All machine learning does is numerical optimization, okay? And they're getting better at that. It's great, but that's all they really do. And they're going to do what we tell them to do, right? They're going to optimize for what we tell them to optimize for. And you know what happens when we do that? If we are good decision makers, they will scale up intelligence. But if we are discrete or mediocre decision makers, it's going to scale up stupidity. It's going to speed up a solution regardless, right? So the problem is at the core. The problem is, let's think about what we're trying to solve first, and then we go and apply all of that. And what we've been doing so far is focusing on this side. And there's an analogy that many computer science professors I know use a lot. They refer to the research side of machine learning as those individuals that build, they say microwaves, let's say ovens, since we're in Italy. I guess microwaves are not as common. They build the ovens or the kitchen appliances, right? Those who apply machine learning, artificial intelligence in general, are the chefs. So what we're asking is, you spent most of your professional lives, perfectioning ovens over and over again. And now a company is asking you, well, since you made the oven, now you must be a great chef. I don't know if it works for you. Doesn't work for my husband. that's like our strategy becomes hope. We're gonna hope I'm gonna build, bring in this oven maker, and somehow it's gonna make the leap and become a great chef. It might happen, it's happened in the past, but that's not a reliable strategy, isn't it? So what you want is to focus on understanding what is that you're trying to do and what's the best skill associated with it. So what is the future of AI? The reason why I'm stressing is applied side of machine learning is because that's exactly where we're going. Tools are becoming easier, they're becoming accessible to everyone, and processes are becoming easier, right? So it really isn't important to know and to focus so much on the nitty-gritty details of those black boxes unless you want to keep building ovens. But now that we have warehouses and upon warehouses full of ovens, microwaves, and all sorts of kitchen appliances, perhaps it's time we really focus on how to apply those tools, what it takes to actually turn those approaches into value. And that's one of the things that really, I really like about data masters, that they do the training, of course, of the tools and the skills, but there is always an applied side to it. You don't just left hanging and figure it out by yourself. There's a lot of, let's think about how we use these things in real life. Now, if the epistle to data professionals, if this letter were a wish list, you have just 3 wishes, okay? Become better decision making. Just means practice. Practice learning how to ask those questions. That's all. Sit with the data, understand what the objectives of the companies are, do all the 5 steps, right? All of them all need to be done and scaled up and sustained over time. It's not a one-time thing. And wish responsibly. Remember, those tools, they will scale up intelligence as well as stupidity. So you have to be don't blame the genie, right? Blame who makes the wish. So make sure you wish carefully, and make sure that your team has all sorts of individuals within it, okay? When you try, if you're at the beginning or you can have any effect on deciding who is going to join your team, make sure you really have a diversity of skills. If you end up having the copy of each other, you're going to do something, but probably it's not going to change much. It's not going to move the needle. Okay, and with that, I hope I made you uncomfortable, and thank you for sticking here with me.
Thank you very much, Donatella. It was super interesting. And we have a few questions for the audience in here. One of which is you mentioned the data flow and also the limb style. There is something similar also related to other positions like data engineers. So all the things that you shared are can be translated also for other positions in IT, or you saw some difference in that?
They look a bit differently. They're a bit like more granular, less granular, but they're pretty much the same principle. And I can provide resources for that.
Yeah, thank you. There was some question related also on the business side people. So on your side, they're interested in know what they can share in their project. So you mentioned how data scientists should be more in lean to share data in a more plausible way. On the other side, do you think also that finance people, business people should share more to the IT? And what's your take on that, on how to do that?
Absolutely. And I think that goes both ways. Like in any relationship, it goes both ways. The real problem here is that we underestimate how hard it is to communicate with people like us, okay? It's really hard because it's all really a big black box. A lot of executives, very capable, very forward-looking, very open to change, they end up those meetings where I usually mediate, and they just didn't understand much of what was going on, right? So the idea is, yes, they should share and be proactive about it, but our effort is worth way more. If we make an effort to make the information accessible, meaningful, relevant, then it's going to be much easier to have this back and forth and actually check on each other through that feedback loop I talked about earlier. I hope that answered the question.
Yeah. Actually, there is a question that was quite connected to that. It's about how to collaborate with people that are a little bit hesitant. So you mentioned eventually to see the decision maker, go there, have a talk. But what if there is some hesitance in collaborating?
There is nothing better than showing them results, right? That's how you convince the skeptical. So go back to where we actually explore. We run small experiments and we show the results, and we do this over and over again, and perhaps we line, with their expectations. We listen carefully to them, and we try to build an experiment that might work, in their own field. And that really is going to build that mutual trust. And that might also give you more leeway, right? Leeway means room to make the changes, to collect data, budget, to hire people. You really need that ongoing iterative process because it doesn't end in one experiment. It's an ongoing process. So you want to really gain their trust that way.
Thank you. You mentioned different times structure, flow, but in particular, I saw also myself in different industry, different way to have a sector, have a pod inside your industry. For the data science team, do you think it should be connected and included in the IT team, the business team, connected directly to CEO and report to that?
I mean, there are different organizational structures for data science. I do like the hub and spoke model where you actually have data science belong to no one, right? It's just in the middle and has all this kind of like accessibility from all different departments and verticals, and then everybody taps on it. It becomes more challenging because you have to allocate resources, you have to go back to the famous ROI and figure out who gets what, but it's definitely the better way, at least in my experience, the better way to go.
Thank you. How you mentioned the North Star metric. Is the recommendation also related to potentially the disruptive effect of the good heart law? And I don't know if someone is in the room that want to articulate that question. Okay. Well, sorry. Okay. Sorry. I'm coming.
Yeah, so I quickly just looked it up just so I don't misquote it. But Goodhart's law, basically any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. In short, once a measure becomes a target, it ceases to be a good measure. How does that apply to the recommendation of establishing a single North Star metric?
This is what I was saying. It's very challenging to do and needs to be identified, agreed upon with the stakeholders, because you really need to capture that North Star metric as to be something you can't really get wrong, right? It has to be the one measure of success that is in line with the mission of the company, and that you can. Of course, it becomes a bit more complicated. You have to kind of build boundaries around what means what, and now not to cannibalize other sectors, right? You might want to achieve better engagement, or you might be hurting. Perhaps new customer flow. So you need to be very careful about how you identify the North Star metric, and that's why it's so hard to do. But it definitely comes with some pitfalls that we need to try to avoid. And there are systems in place, by the way. I mean, it's very hard. And again, if you want to go more in details about that, there's a lot. And growth hacking, all of those kind of strategies have a lot of documentation about that because that's how they thrive. That's how they do well, because they identify the kind of metric that is really the goal that everybody can measure and act towards. I hope that answered your question. But just get to me later, we can talk more.
Yes, and going back to methodology and models, do you think there is a model for data science that translates from the agile methodology that you so can be translated to the data science team?
Experiments all the way. I mean, the whole idea of being agile is that you fail quick, right? So the idea is that you start slow and you try things out and you keep on learning and you keep on growing according to what you learn. That's pretty much the core of it.
Great. And what strategy do you recommend to resist to counteract the business management that is latent urge to turn any useful metric into a target?
How do you, well, there is a lot of literature, so most of us do that. They go do their research, read white papers, look at use cases. That's how they identify those target metrics. I think the better way is to start understanding what are the objectives in the company. Really talk it through, understand what success means for the company, and be also proactive in testing these ideas and then coming up with one together. Now, the idea that the next Silicon Valley, what Silicon Valley is that the idea is copy and improve, right? You want to learn from what other people are doing and then work towards a better solution. And that's where I think the difference is made. Now, the average approach is that look at the literature, the white papers do the same thing. The success is actually defined by being original in the way we do it, and we work all the theory part of the problem.
So experiment.
That's the key word, the second way. Stay in touch with the business people and experiment.
Yes, and talking about, again, staying in touch with the business people, some people probably is concerned about transparency in a way. Should also people in finance business share their own challenges in getting metrics for the budget, financial plan, their own failures and success, perhaps their less communication in the other side, or what's your experience or take on that?
My background might be misleading here, but I think everything is about finance, right? Whatever you want to do, it comes down to money. So yes, absolutely, the finance department should be always involved and always, but this is what we're talking about here. How do you foster this kind of communication? How do you actually get on the same page with the rest of the stakeholders in the company? And that it goes back to trying to create a channel communication in person and asynchronous so that we actually can learn as much as possible. Sometimes you have to decipher what we're trying to tell us and keep on insisting. Again, even this is an experiment from our standpoint, right? You're going to try different ways to talk to them, try different ways to interact with them, and find what works. So you're not allowed to give up on the first or the second try, right? You actually have to find a way to work with them.
Thank you. So perhaps one last question about delivering successful projects and reports. In the software world, product managers, owners exist for focusing on value delivery, a widespread agile concept. So in the same sense of the agile methodology that we mentioned before, you have any tips about the delivery of the values to perhaps managers and product owners, and also I guess inside within the team and within the larger
the way we present it?
Yes.
Well, it really, again, the concept here is meet your stakeholders where your stakeholders are. If they're technical background, it's pretty easy to walk them through delivery. If they're not, then storytelling is probably the best way. Of course, with solid foundation, right? Data and possibly ROI attached to it.
Yeah. So again, connected to the agile method is in this way an experiment. What is works based on the stakeholders,
exactly.
Right?
Yes.
Okay.
And you can even build several experiments that tell a story, right? And then you can make that monumental change. But you're going to have the buy-in of your leaders because you're showing them results. You're showing them the metrics that matter for them to make the decision, or likely to make the decision. Now, if you're a product, they made you help up to a point, but then they just gave up, right? So you have that story too.
Yeah. So I don't know if you want to share one last word.
Well, I really hope you do embrace the applied side of machine learning. I really hope you try at least a few of the things we talked about. And well, best of luck on your future data endeavors. Thank you so much, and keep on showing up at this event.
Thank you very much. Okay, so thank you very much, Donatella. So coming up, there is the lightning talks happening here. So be ready for the courageous people that attended. And on Tagliatelle, there will be... Oh, go ahead.
There will be Alex Martelli and Anna Ravencroft talk till 7:30 p.m. Okay, so if you want to join the Alex Martelli talk, just go upstairs. Thank you.
So if you have a live stream talk, please come to sit at the front because we don't have that much time to change from one laptop to the other. So there's the connection here, and then there's also the USB-C, so you don't have to bring your own. And then there's the HDMI as well. So yeah, I'm sorry we can't like check everybody. So so we will go in that order that you sign up. And maybe I will explain the rules a little bit while people are coming in. For live talk, all of them got like 5 minutes to give the talk. We are already like running running late. But so I would keep a time on my phone, and if they are running out of time, maybe they have like 30 seconds left, we'll do a little bit annoying job to remind the speaker that they have to really speed up and finish the question. And then when they have to like, when they're done, what they are supposed to be done, we have to give them a big round of applause so that they know they have to get off. So let's try that. Okay, good. So let's the first group, please. Hello, Artur. Please come and set up while I explain a little bit more about the rule of live talk. Hello. Okay, can I use it? No. Not on. I don't even know how things work. Okay, so live talk, like I said, all the speakers, please come in the front because we don't have that much time to connect. And it will give me a hard time if it doesn't work, then I have to like yeah, it works. Okay, good. So let's welcome our first live stream talk about EuroPython.
Thank you, everyone. How many of you know what EuroPython is? Okay, lots of people. That's good. So EuroPython was here 10 years ago, right? 2013, and this year is happening in Prague. It's in the PCC. It's a 7-day long conference, so it's a bit longer than PyCon Italy. It's 2 days of tutorials, 3 days of talks, and then 2 days of sprints. And this year the sprints are actually free as a separate event. They're not, the conference is not required. And we recently published a list of sessions, so if you would like to see what's happening at EuroPython this year, you can go to europython.eu and click the link in the middle, and you will see all the talks and the tutorials that we have programmed for this year. The schedule is not out yet, but we're working on it. You can also grab your tickets and become a sponsor if you want to. And all the information are on the website. And one of the features will be the CRA conference that Chuk will talk about a bit later. And what else? Chuk will talk about it later. Okay. Yes.
All right.
We can talk about.
One most important thing which Artur did not talk about is that we have better beer there, unlike in Italy. So what? Yeah, and more so, not as good food as Italy, but more or less reasonable. Couple of things that you would like to know is, as Artur mentioned, we are this time we're planning to do like fully sprints which are fully free of cost, and we would like you all to bring your own projects. You can actually submit your sprint right now by clicking on Submit Your Sprint Now. You can learn more about the conference by going on europython.eu. We've got pretty much all the info up there. We're aiming to publish the first schedule somewhere around the next week or in the next 2 weeks. You know how it goes. Also, one important anecdote is that this website was actually made by someone who's based in Italy.
It's an Italian design.
It is an Italian design. So Patrick, and also the logo is also made by someone from Italy. It is also Italian. All right. Thank you so much. And now Chuk will talk about CRA.
Yes, I'm going to talk a little bit about the extra feature that we have, because EuroPython is a week-long event, so there will be a lot of things going on, except the sprint. We will also have a lot of events during the workshop day, so you can have a lot of things to learn for beginners. You can have a lot of workshop you can go to. There's like one humble data that like people who doesn't know Python can come and learn Python and data science. And there's also another one by the ladies, the Pi ladies, is also a beginner-friendly workshop. So there's also a mentor sprint. It's again beginner-friendly. Then you can learn how to contribute to open source. And the last thing that I want to mention is not up there yet. That's why I want to mention it. Is the CRA section. So what is CRA? So CRA is actually the cyber resilient edge that could affect your open source ecosystem because. Okay, thank you. So yeah, if you really concerned about like your open source software, you can't use it anymore for your company, then you should really definitely come and join the discussion section. So we still have 2 minutes left, but I'm done. So let's welcome the next speaker. Is also Vivi. So he's going to talk about audio of Hugging Face. So. Thank you.
I can't find my slides.
Also you need time to set up, right? No, okay.
No, I found my slides.
Okay, good. Are you ready? Okay, good. Okay, timer reset.
Okay, who here knows about Hugging Face? All right, cool. First of all, I am Weeby. My full name is quite weird, so just call me Weeby. I do some stuff around open source at Hugging Face, and what I'm going to be talking about is what exactly are we doing for audio. And first of all, Hugging Face ecosystem goes way beyond NLP. It's just for some reason we're just known for natural language processing, and hopefully by the end of this, whatever 4 minutes I'm left, you would know some of what we do for audio. In terms of the Hugging Face ecosystem, we have like a gazillion open source libraries, ranging from parameter efficient fine tuning to fast training and inference on Hugging Face, Accelerate for training your models, Hub Python library to be able to load petabytes of data, JavaScript libraries to be able to interact with all open source models, everything fully open source and by the community for the community. We've recently been starting to sort of double down on our audio efforts. And for audio specifically, we now support quite a lot of sort of tasks, more specifically for like speech recognition. For those of you who were at my tutorial before or have known about sort of Whisper, which is an OpenAI architecture, we support 70x faster sort of Whisper, and you can sort of fine-tune Whisper 5x faster with the transformer ecosystem. We also support Wave 2 2, which is the second best sort of speech recognition model. Also, Facebook released massively multilingual speech recognition models last week, and we're about to merge them like tomorrow. So you can also use that. We also support text-to-speech, text-to-audio. So there's Speech T5, Audio LDM, music spectrogram transformers. You can also use this for classifying audio. You can also get state-of-the-art speech embeddings using Clap, which is also another cutting-edge model in transformers. Not just that, we also have like a full-blown support for audio datasets. So pretty much all the datasets that you use in the industry or in the research, or in academia are on Hugging Face datasets. You can just go on hf.co/datasets, filter by your audio task, and you can get them. These are minded petabyte scale datasets, which you can. How much time do we have? Okay, which you can basically sort of stream through at the speed of thought. If you want to know more, feel free to catch me outside. Not just that, all of this at the speed of light, light, thought, whatever. And I'm just gonna try and do a live demo because why not? So we have, as I said, audio LDM, which is basically this text to audio model wherein you can give it a prompt. So I'm going to give it a prompt, techno music with strong upbeat tempo and high melodic riffs. Don't know what that means, but let's see how that sounds like. Okay, that was shit, but you can basically engineer your way through. You guys know ChatGPT, whatever. Give it a prompt and you can do it. Thank you so much and have a lovely evening.
Okay, so the next one is PyCampania. Ooh. Cool. Yeah, so please set up. And also, I forgot to mention the next one. So the next one can also get prepared for your laptop. So we can be faster, right? It's a lightning talk. So the next one is djangoproject.com. So whoever is giving that talk, please get ready. Good. Okay. So so someone told me this mic is too loud, and because I'm so used to karaoke. Who loves karaoke here? Woo. Okay. So you're ready, so let's go.
Okay, I'm ready, so good evening to everyone. This lightning tools basically is about local community. So for this, now I switch in Italian because in this case it's more inclusive in my opinion. So just 3 minutes. Ok, vado in italiano. Voglio presentare la community di Campana di Python. O meglio, il tentativo di community Campana di Python, perché ancora non è riuscito a partire in maniera definitiva. Giusto un secondo per cercare di capire quello che succede. Ok?
Oh no.
No, sta funzionando. Forse.
Oh.
No.
Oh, good.
Ok. Siamo partiti nel 2019 che volevamo iniziare, poi ci si è messa una pandemia di mezzo, abbiamo perso un po' di tempo, quest'anno davvero vorremmo riuscirci per cercare di avviare, dico Campana perché l'idea era quella di essere più inclusivi rispetto a solo Napoli, anche se tutte le altre community sono in realtà cittadine e non regionali, però cerchiamo insomma, poi vedremo come organizzare magari andando in giro un po' nelle varie città della Campania. Cosa vi chiedo? Vi chiedo semplicemente se ci sono persone interessate a dare una mano a questa cosa. Che cosa ci serve? Qualsiasi persona, possibilmente campana ovviamente, che possa dare una mano per la community. In realtà non è, diciamo, ci serve qualsiasi tipo di mano. Per esempio, faccio un esempio, gestire social, ok? Io non sono molto bravo a gestire social, quindi se qualcuno che magari non deve essere necessariamente bravissimo a sviluppare, un programmatore eccetera, ma può dare una mano per gestire social, può essere d'aiuto. Ovviamente tutte le persone che si occupano di Python e stanno in Campania possono mettersi in contatto con me, cercheremo già a giugno in realtà, avevamo intenzione di fare qualcosa già a maggio, poi abbiamo aspettato il PyCon proprio per cercare di ampliare un po' il pubblico. Cercheremo già a giugno di fare un primo incontro. Il primo incontro che vogliamo fare saranno uno schema abbastanza semplice, quindi ci incontreremo per un meetup nel quale cercheremo semplicemente di chiacchierare di cose diciamo tecnologiche in qualche modo. Il primo incontro verosimilmente si farà a Napoli, che comunque è un pochettino quello che concentra un po' tutta quanta la Campania, e poi cercheremo di girare in base anche alle persone e soprattutto alle location che ci metteranno a disposizione. Se chiunque riesce a essere interessato, chiunque può dare una mano, in un primo momento si può mettere in contatto con me. Qua sono un po' tutti quanti i miei riferimenti. Email, Twitter o LinkedIn, quello che preferite. Sto dovunque, nel senso anche su Facebook, su Instagram eccetera eccetera, però questi sono quelli che più o meno uso di più e controllo. Se ci sono persone in Campania, se non ci sono cercate di diffondere il verbo, così cerchiamo davvero di partire in maniera corretta questa volta. Nient'altro, l'unica cosa, se invece siete un po' più su della Campania, c'è già attivo il gruppo di Paolo, che è Python Pescara in questo caso, con il sito, quindi insomma cerchiamo di portare un po' di Python anche al centro-sud. Ok? Finito?
Sì, grazie.
3 minuti, quindi...
Yeah, that's probably all the Italian know. Do you have English track? Do you have English track? Oh! I can't submit a CFP because I don't speak Italian, as you can tell. But our next speaker can speak Italian. Are you going to present in Italian or English?
In English.
Okay, English, good. Okay, so there you go.
So, as Leo just... Oh. Oh. You can see that? No.
Okay.
So,
almost there,
Python
almost
Pescara.
there.
Python Pescara. As Leo just said, we had our first meeting two weeks ago. This is the first photo we have had, and we also have a website. You can find all other contacts, and if you want to join from everywhere, this is our group Telegram. So if you are everywhere in Italy or in the world, and you want to visit us in Pescara, you can join. For something totally different, DjangoProject.com has a fundraising section, and you can go to the website. You can see something like that. There is a big heart. You can donate because Django Software Foundation promotes Django Girls Workshop and other conferences all around the world, and it will be DjangoCon Europe starting Monday. And Laura Virginia did a talk yesterday here in this conference, PyCon Italian, speaking about how we are trying to renew the fundraising section on the DjangoProject.com website. The Django Software Foundation has it up to improve the usability of this section, the website, and we do analysis about accessibility, it's more important. And we had the evaluation, and we discussed a lot to what we can improve. And we saw positive and negative things in the website. Right now, we tried to isolate what we can improve. But now we need feedbacks from user, like Django user or also Python user around the world, because you know how website works. So please scan this QR code and answer the question you can find on the about the Django website. It's very fast, only 2 minutes. The questions are very easy, and we ask only your feedback from how you found this website, and we'll use your answer to improve a lot this website. So thank you, and see you in the next conference. Bye.
Yeah, so do you mind posting the QR code on social media so we can also catch up? Yes? Okay, thank you. Yeah, let's, yeah, because like, it's very important to help the Django project. And next week, actually tomorrow, we are all going to DjangoCon Europe in Edinburgh. So yeah, but talking about that, the next talk is about torprojects.org. And this onion looks a little bit familiar. I don't know whether it's the thing that you're going to talk about. Is it about an onion web, something,
Yes.
security? Yes, okay.
So hello, you can start the timer now. Hello everyone, my name is Kushal Das. I am one of the Tor project core team member. Who all here know about Tor project? Okay, so most of the room. So there are still not hands. So, and just for everyone else to revise the idea. So this is the website, www.torproject.org. We are a US-based nonprofit. We are a community. We are a network of over 7,000 servers, computers running across the world, which creates a network, open network, where anyone can connect and then browse internet privately. Do you know that your browsing habits are getting sold between thousands of companies among the world, and then people are trying to decide how they can sell things efficiently or sell you efficiently to other companies? Like, just, yes. And then there are other bad things also, like in different cases, like companies are trying to figure out based upon your medical history search or other researches, like if they can charge you more for some particular, let's say, insurance and other cases. People with particular medical histories, they are always worried about how they can search privately. Activists, lawyers, doctors, normal people like us, we want to visit a website. We just don't need to tell every other million websites that I visited something and read about something. That's where Tor project comes in handy. You should always go to www.torproject.org, download the browser from there. That's the easiest way to connect to the browser. If you connect, this is the page you see. And then you can open any website. I'm going to keep doing some quick demos.
So let's try PyCon IT. .it. So what is the most important thing here? That is, we are not connected directly to the website. From this browser, it automatically chooses a guard node, that is the entry node, which is in Finland. And then from there, it went to, again, Italy. Then from there, it went to Germany. And from there, it came to PyCon.it. Now, if we go back to this different graphics here, and I can actually show you how it happens. So, if you can see. So when we use Tor, your computer automatically connects to that first server, which it selects and stays around for 3 months continuously. Then in such a way the encryption works so that the first server knows that you connected to Tor, and then it is supposed to give it to the second server. It doesn't know which website you are browsing. It doesn't know who is the third server. Second server only knows it gets from first and gives it to the third server. The third server knows it got something from the second server, and it goes to the site.com, in this case, PyCon.it. So that's what's happening here. And together, along with all of these features, this particular browser is actually based on Firefox, plus a lot of security patches, which makes it really unique, so that one browser tab cannot figure out what all things happening in the other tabs. And every time you close this browser, things will start from the scratch. So if I go here and just show you how it works. So it is now trying to connect to the network, and it got back. And you can see things are not slow. It used to be slow, but now we still have more than double capacity on an average, other than when some people try to attack us that way. And it's a non-profit, and it's a project run by people like you and me. And I know there are many people in Italy who are actually running those servers called Tor relays. So you can also volunteer, or you can at least start using the browser so that you can have a better privacy in your life. And you will always see that media and publication, news, like movies, there is always a different way to produce what is Tor browser. The words or the terms like dark web, deep web are getting thrown into against each other, and they will keep trying to tell you that Onion browser is bad. You heard about CIA. There are other things going on right now in Europe about chat control. I don't know how many of you heard about that term. Only a few. You should try to see what are these things called chat control and other things happening in EU, let's say the AC, and you will find that the companies, not the companies in this case, the governments are trying to make sure that they can stop us from using encryption. Tor browser gives you that power. To make sure, just try out Tor browser. Thank you, everyone.
Yeah, I have another use case that's how I heard about the Tor project, is that because, there was some unrest in where I grew up, Hong Kong, right? So everybody was talking about using the Tor browser just so that people can track you and what you are trying to do. So yeah, I think it's a good project and we should support it. And
go on.
We have a next. Oh, you're not done yet. I saw the logo. I thought you were done. But yeah, so it's in Italian. Is it Italian talk or English talk?
It is in English.
In English talk. Okay, so I can understand this one. Good. Yeah. Oh no, but the screen doesn't want me to see it, which is but oh.
Can you see this?
Yes. No. Yes. No.
Okay. Hello. First
Hello.
lightning talk, so I'm very
excited. Okay.
Yeah. Okay, so I'll be quick. Do you know what Italian queues are? They are data structures. If you don't know what they are, you are in the right place. I am Professor Alessandro Re. You can know that I'm a real actual professor because I use Comic Sans as a font in my. I am PhD, Master of Science, Bachelor of Science. I am also a Dungeon Master and a certification authority. So I'm very qualified. Thank you. So what is a queue? Everybody knows what a queue is, or a line. It's a linear data structure, right? Used to manage data that shall be processed sequentially. Italian queues implements the CISO strategy, something in, something out, also known as first come, eventually served. Okay, so in this example on the right, you can see how to use the API. It is an actual test. It will, if you run it, it will work. The Italian queue, you get some data, you push the data in the queue, and you get the data with POP out. Okay, so it's very, very easy. Also, thank you, shout out to Nicola there for a tip on how to properly use the list comprehension. So very nice talk yesterday, so thank you very much. So how to implement that in Python? Well, we will use a node class, okay, that represents one item in the queue. Of course, the item has a value, and also something that follows it. It's a linear structure, so it has one on the left and one on the right. I will also add something like an insert method that allows us to insert data in the queues. Please note that this is a recursive function, and I'm using recursive function because I'm too cool for loops. So this is the node. The queue and actually is a class that will have the nodes connected one to the others. There will be a totally linear queue, okay, in the line that is initialized trivially to none. And then the push method, okay, the push method says if nothing is in the queue, I create a new node. If nothing is in the queue, if something is in the queue, I use the insert method that I defined recursively earlier. So this is the push, very simple. The pop is a bit more involved, so it's a bit tricky. If you know data structure, yeah, they are like that. So in some details are omitted for brevity, but basically, of course, if you try to pop something that doesn't exist, WTF, man, come on, okay? Control your code, okay? So you get the first element in the queue, try to get that, and depending on the presence of something in the back of the queue, you decide what to do in the queue, okay? So you save the value and then decide, is there something in back? So if there isn't, I'm done. If there is, I do something and restructure the queue. So that's basically it. I cannot go into details right now. So example, you push the data, Alessia, Bob, Carla, Dean, and even gets in the Italian queue. They get out Bob, Carla, Alessia, Dean, Alessia again, and even, okay? So that's it. How it is structured an Italian queue, it's very simple. So somebody gets in the queue, somebody gets in the queue in another way, and eventually the queue will form this very large and organized linear data structure, because this is how we do linear in Italy. And you can see people in the queue. These are their example, okay? So eventually, okay? It works. Oh, it was, sorry, I lost the most important slide. Sorry, I forgot about that.
Oh, you forgot one slide. Okay.
Yeah, sorry. Do I have the time?
I'll give you 30 seconds to turn it
I hope it works. Come on, Linux. Okay, it works. So complexity analysis. Given an element, of course, pushing is constant. Popping is O of 9 3/4. Space complexity is obviously n+1. Mind complexity is O WTF, and time complexity is theta ? Okay, so thank you very much. I hope you had fun.
So thank you so much for this like super realistic real life stimulation. Yeah, that's really good. So next one is Michael? Michele, sorry.
Michele.
I don't speak Italian. So, so it's about simulators? Simulators,
yeah.
Yes. Yes, that is English, so I can read. Okay. And the computer is not mirrored for whatever reason. It doesn't not mirrored. Okay. So let's talk about. Okay. Okay. So let's talk about what I had today. So the problem is not what I had today, it's what I didn't have today. Because today at lunch, I didn't get to have the dessert because I have to run back to give my talk. So
okay, I think I found it.
Yeah. So the problem is keep on finding. It's fine. So the problem is so now I really crave for dessert. So who want to have a gelato? Who already had a gelato here? The first question. Who already had a gelato here? Okay, lucky you. I'm so jealous. I really want to have gelato because I still haven't had gelato. So who want to go for gelato with me after pie dinner?
Okay.
Okay, I'll see you all later. Okay, so let's welcome the talk. Simulator. Are you ready?
Yeah.
Yes. Okay. Let's welcome the talk. Simulators by Nicola.
Thank you everyone. Okay. So today I'll try to speedrun something which is a 49 minutes article in 5 minutes. So in order to give you, this is done to give you a new powerful way of thinking about models like GPT. because I think that you may have heard of it. So basically, who am I? My name is Michele, on De Simoni. Online I'm called Ubik. I am a senior, as I like to say. I'm a scientist. Google me up. Slides will be in the Discord. I like to do traditional machine learning engineer, data engineer, and now AI safety. So what is the Shoggoth in the name? Look it up, actually. This is like left for demonstration at home. Look up Shoggoth AI meme, and it will be clear to you. What today I'm going to talk to you about is this article, which is called like the simulator theory. You can, again, look up the whole kind of article in by simply searching for Janus simulator, which is one of the name of the author, or simulator theory in the alignment forum. This talk is related to AI safety, and tomorrow, actually, there will be a talk from Stefania Del Prete on introduction to AI safety, so you're really welcome to please attend it, because AI safety is very, very important, may actually be one of the most important things in the world right now, or especially for our future. There are some caveats, sorry, about this talk. I will use GPT, but when I say GPT, I mean like transformers, or anything which is basically trained as a next token prediction. What I'm going to tell you about will not be, will apply to everything which is a simulator, and you will see later what is a simulator. But this only partially applies to stuff which has been fine-tuned or RLHF. So basically reinforcement learning from human feedback, so ChatGPT, Claude, stuff like that. This only partially applies to them. There are lots of caveats. Look up mysteries or model collapse to know more about it. So we actually do the talk as a memento style, so from the end back to the beginning, so that maybe I can get across my point even if time's run out. So what is a simulator? Basically, whenever you do self-supervised training with a predictive loss, independent of architecture, data, whatever you do, doesn't matter, you will create a model. And this model will actually be better described as a simulator rather than other more traditional types of AI model. Simulators are very, very powerful tool, way beyond like the traditional stuff like agents, Oracle, or Genies, which you may have heard about. And by looking at them, it will be very useful to know, to think about them as a simulator. So what is a simulator? Simulator refers to model training, as I told you, with predictive loss, self-supervised data set, invariant architecture. Doesn't matter what you try to predict. Is it a token, is it a pixel, is it a game state? Doesn't matter. What does a simulator do? A simulator is optimized to generate a realistic model of the system. The simulator will not optimize for objective other than realism. That's what you get. This is actually generated by GPT. So it knows what it is. Current AI taxonomy are not good enough for simulator. What's the current taxonomy is basically we have agents. Reinforcement learning creates agents. Agents are open-ended. They want to optimize stuff, usually an utility function or also form of rewards. Oracles give you back answer. Genies are something like, it's basically an agent which does stuff when you ask it to. But is GPT an agent? Yeah, not really. Agent kind of really like their own rewards, and basically we can say that an agent is its own reward function. But GPT doesn't actually, the reward function of GPT is predict next token, and so you can actually simulate agents who do not care about predicting next token, but maybe care about paperclip maximizing inside the GPT. So that's why we are talking about them as agents. Why this matter? Well, this matters because we are probably going to build actually agent which will scale to AGI or ASIs or superintelligence. Most likely, they will be built off this type of LLMs. And so it's really important that we understand what the hell is going on inside them. This actually may be very dangerous if we do not do this properly, especially if we try to apply reinforcement learning on top of this stuff. But is GPT an oracle? I mean, if you ask stuff, it will give you back answer. Yeah, but actually oracles are trained in order to be correct, and they want to be perfect. But GPT does not give you back correct answer. It can give you back hallucination. So what the hell is a GPT? Well, GPT is a simulator. So look it up. Thank you.
Okay, thank you so much. There's a lot
I'll post the slide on Discord. So.
Yeah, there's a lot of information there. Yes, yeah. Please share the slide so we can read it afterwards. So next is David. Hi. So you say hype here. Is it are you going to be hype about it, or what was that about? Well, you're always hype. That's why you put hype next to your name. So, yeah. Okay. So you are hype. I can already see a little bit, but yeah, just let it. It's too hype, this thing. Okay. So there you go. Here's your time.
Okay. Hi everybody, I'm Davide Raghi. I work as a senior data engineer in HYPE. HYPE is one of the largest bank in Italy and provide several payment services, saving box, loans, and also crypto purchasing. And all of these services are in a unique suite that is an app available on App Store and Android Store. All our data are generated by the app. This is our data platform that is based on Azure, and we have several source of data that come in from marketing tools, our partner, customer management, our CRM, and we process all of our data with Data Factory, Event Hub for a real-time event, and of course, our core big data processing is made with Databricks, that is an environmental tool that is related on Spark, and you can perform several tasks like machine learning experiment, ATL, and SQL, and you can put different kind of task of analysis. And we receive gigabyte every day, and we have to handle to provide a better service to our customers that are more than 2 million. But one of the building blocks of Databricks are Jupyter Notebook, and do you like the Jupyter Notebook?
Yes.
This is not good for me. No, I think that Jupyter Notebook are awesome for POC, for sharing quick analysis, but they have several problems that in our data team we highlight, and we come to the conclusion that don't guarantee a production-ready code. Why? Because there's no leaking, there's no formatting. Even Databricks has introduced black formatter, but there is no a linear workflow on executing different Jupyter Notebook. There's no code modularization, and there is a high risk of spaghetti code. There are no security checks, so if we put erroneously a secret or a library that does not respect security compliance, we cannot reveal in our code review. There's no package handling dependencies. In fact, you install pip via pip or via jar or via a simple wheel on the cluster, but there is no package handling that on the Jupyter Notebook. There is no quality check in general. There's no templatization. So we have move out all the developing process with the Databricks VS Code extension that we have allow us to develop entirely our process out of Databricks. Thank you.
Right on time. Okay, so next one is how to launch a local Python community in Branchet, Italy. So I don't know, because I think that if it's launching a local Python community, we can learn from each other. So I hope that it's not just about Italy, right?
That's the question mark.
Okay, that's the question mark. So we have to listen to the talk to figure it out. So
Yes.
thank you for that. And why is it not so? Please, okay.
Takes time.
Yes, I think it's going to show in 3, 2, 1. Yes, good. There you go.
What's this? Sorry. Okay. So, I took this picture this morning. This one, yes. And this morning there was the annual yearly Python Italia Association meeting. Let's call it like this, assembly, actually. And what is the goal? What I understood that the goal of Python Italia Association next year will be to push the growing of new local meetups. And so I took this job, and after 10 hours, I will show you the solution. So I'm a data scientist, more or less. So I started with some statistics. It took quite some hours, and this is what I've computed. So today there are 3 local active communities, one in Milano, Biella, and Pescara. So we miss still 73 provinces, and then we are done. So what can we do? I am one of the organizers of Python Milano. And we have been around for 9 years. We have monthly tech talks. We have a podcast. So what we have learned is what I will show you today. So if you are thinking to start a local Python community like in Campania, what to do? So I have 6 tips. The first one, don't start alone. If you are just one person, it's very useful to have someone that help you, at least one. More is better because you need to share feedbacks and to some energy sometimes when you are tired after work. So better to be at least in 2. That's the first tip. Second, join the Python Italia Slack channel, because there is a channel for communities where you can get tips, advices. So it really makes sense to get invited to this channel. Number 3, you need some basic tools, very easy to set up. Some communication tool, Slack or Telegram. You can have a very basic website using GitHub pages, and Python Italia will provide you with the DNS and hosting. I recommend meetup.com because it works, has nice features, is also discoverable by other users, but it's expensive, so be ready for that. And then it comes the problem, where are the speakers? You don't need a speaker. You can just start by organizing a social event, and often people enjoy it more than the tech talks. That's what we find, because when we have tech talks, they ask us, when is the next Pi Beer? To start, just organize a Pi Beer event, and that usually helps. Then about the events. Maybe you think that it's hard to find a venue that hosts you, but actually that's not so hard. Usually you can find companies, university, or even local libraries that helps. And try to have a regular pace. I mean, if you do a talk in 2 weeks, then after 6 months, then people don't understand what you are doing. So try to have a monthly event. And if you don't have speakers, just have a Pi Beer or social events. Money. My advice, this is my personal opinion, try to keep money away from the local meetups, because handling money is just more work. So try to avoid monetary sponsorship, try to avoid registering an official company or association, and that's it. And if you need help, just visit our website or... Let's see in a year from now if this helps. Thank you.
So I have a question. Please get ready. So I have a question. Can we have a lightning talk if we don't have a speaker? Maybe. Okay, maybe. So next would be, this is very good. It resonates with our first keynote of the conference, like 3 factors that are blocking contribution to your open source project. So we always want to encourage people to contribute to open source projects, so maybe we should listen to this talk. Thank you.
Hey everyone. So this is my first lightning talk and first time in Italy. So thank you so much for organizing this. So a little bit about me. My name is Saurabh. I'm coming from Delhi, capital of India, and I'm strong open source believer. So 2 years ago, I decided to start working for an open source project full time as a community manager. So my work includes helping community members to contribute to that project to make their path easy. And so the main work was when I saw that it is a very big problem that when a new contributor comes to a repository, it's very difficult for them to contribute. So I researched a lot about this and I find 3 factors that block contributions to any open source project. And it's not only for any company or a project. Maybe it's your personal project and you wanted to put it on open source world and want contributions. So if you put these 3 things together in any project, I can guarantee you will get a lot of contributions. And I'll show you how many I got. So the first problem is getting overwhelmed by code. Yeah, so you can relate to this. When you start contributing to any open source project, you visited a GitHub repository and you find the code base of that GitHub repo very, very difficult. There are hundreds of packages, there are thousands of files, different technologies, and you have no clue which package does what. And so this is the biggest problem. Any new contributor coming to your repository, this is the biggest problem. So the solution for this is having good first issues. So as a maintainer or as an owner of that project, you have to make sure you have at least 20 to 25 good first issues at any point of time to make that project inclusive for the first time contributors. And these are not only code issues, these can be design issues, bug issues, UI UX issues, documentation issues, sorry, and making the README better even. And yeah, who hates a good README? So it's always a good idea to open that issue. So this is the first thing we can do to make our project inclusive for the first time contributors. The second thing I saw when I was working as a community manager that, let's assume you have many good first issues. Someone started working on your any good first issue and they are having a problem with it. So yeah, the meme. So they picked up an issue, they start solving it, and maybe they are having an error with installation of your project. Installations are not easy. Maybe they are having error with dependencies. Maybe they are having error with Git issues. So someone is trying to contribute to your project, they are giving your time. The least you can do as a maintainer or as a owner of that project when the project is small to help them. So arrange meetings with engineers of your company, arrange meeting with yourself, help them to contribute for the first time, and you'll see they will contribute more and more and more after that. So this is the second thing, the support thing, and you have to be proactive in this. So whenever someone picked up an issue and stopped working on it, you have to ask, what's the problem? Can I help in any way? And that too in a polite way, not like rudely. So the third thing is rewards and recognition. This is a very, very important part that that worked for me. I personally believe that every open source contribution should be celebrated. It's a big thing. Someone is investing time, someone may be working on holidays or on weekends to make your project better for the community. The least you can do is say a thanks. So say a thanks on your social media channels. Tell the world that a contributor has contributed something very good for your project. If you can afford, give them a token of appreciation. It can be a t-shirt of your company, it can be a cap, it can be a small badge or sticker sheet, anything. And it acts as a motivation for the whole community that if we contribute to this project, we can get this, or we can get simply a thank you post on their company, which they can show off to their friends maybe. I have nothing that. So these are the 3 things that I noticed and it worked for me. So you can see when I joined, it was 30 contributors and now we have 200. Thank you so much. It was fun. Thank you so much.
Thank you so much. And I do like the term token of appreciation because I know one project, it's called Beware. Oh, okay, it's fine. It's not this next speaker. Next speaker is Maxim, by the way, if you don't know, that's you, okay? So a token of appreciation. So the Beware project, so I've been to that spring. And if you have contributed to Beware, and then you will get actually a token. It's like a coin that is for your contribution. So I think it's very nice. I'm really jealous because I still haven't got the coin yet. I still have to work very hard to get it. But it's a very nice coin. So yeah. And so, wow, you're very busy setting it up. So our next talk is about, is it Latin or is it Italian? Carpe diem. Oh, okay. Well, you can teach me all about it. Thank you so much.
Okay. Can I start? Yeah. Okay. Hello, everybody. My name is Maxim Danilov. And who I am? I'm developer around 25 years. 10 years in the past I worked with assembly, and 9 years I work with Python. And I'm speaker on the conferences. All my talk you can achieve with this link. And I want to say thank you for two companies who support me. And I have a special thanks for the person who support me. Anastasia Sen created design of my presentation, Pavel Pelikin tested, work with my code every day, and Martin Eichenreiner tested this all. And I want to say thank you for my family, Elena, Maya, and Mark. Thank you. Today I have a talk about generators. In preparation for this talk, I reviewed my past. Why I am here. Why I did to be here. I remember about PyCon the year 2022. I talk about complexity in Python code, and right in the same time, my wife waits me, and she is pregnant. After that, on DjangoCon in Portugal, 2022 in September, I have a talk, and right now, in the same moment, my son was born. It was the first day of conference. It's all okay, I can answer. I was on conference, it was planned 1 year before, and child not. But DjangoCon United States in October. My wife cannot wait me. He made a photo shooting. Okay. In PyCon the year in April, I have a brilliant talk about generators, and in the same time, my wife sent me a photo. My son did the first step. Again, it's important, without me. My PyCon Italy, I'm here. And my son you cannot see the first teeth in mouth. What I want to say, the boy full life live without father. But what I want to say right now, let's take Python. In Python we have one built-in iter. Iter receive one callable and one sentinel. If callable equal to sentinel, iter throws for us a stop iteration. If not equal, iter give us the result of callable. And we can create infinity generator from this infinity iterator. I give one iter, and sentinel is 1. This is infinity iterator, and this is better than iter tools. From infinity generator from iter tools, it works better. And what I offer you to do with that, we can create a loop of our life, and for every moment in infinity, we can catch the moment. Carpe diem. Thank you. Don't forget about your family, it's really important. Thank you for attention, and my next talk on EuroPython in July in Prague.
Yeah, see you in Prague, and please show me the picture of what's happening in July at that time. So yeah, it's very philosophical talk, but the good time is almost come to an end, and there is come our last talk of today, as a lightning talk. So who have get the stickers for at the registration desk and found those cute bunnies? Who has got one of those stickers? Yay! So. That is actually the mascot of PyScript project. So I do believe all the good open source project need to have a cute mascot. So yeah, I found the rabbit very cute, and I think it's a good choice because if you have seen like the PyScript logo before, the Y kind of looked like the ear of the rabbit. Oh, it's so cute. Okay, so let's Valerio talk about all these cute rabbits.
Thank you so very much. I'll try to be brief. I normally speak like 4 hours, so I'll try to say in 5 minutes. Of course, my talk is full of live demos, so why not? Just wish me luck. Who's here knows what PyScript is? Brilliant, all of you, essentially. So PyScript is actually Python running in the browser, and it's a very fascinating project. Is first and foremost Python in the browser, like literally Python in the browser, genuine Python in the browser. It's not just Python; it's a whole ecosystem, and all you need to start with it is like a web browser. How to PyScript is very simple. You just add this line into your HTML file, and everything is ready. And PyScript actually works with calendar releases. So this is 2022, then we have 2023, and just like a couple of days ago, we released the first release candidate for the May release 2023. So if you want, you can test it out. It's open for testing. Very quickly, PyScript architecture is actually on top of Pyodide, and Pyodide is the C Python interpreter running on WebAssembly compiled via mscripting. And thanks to Pyodide, we have integration with JavaScript, and we have essentially the full PyData stack running directly in the browser. So we use NumPy, Matplotlib, scikit-learn, and whatever else. A few examples very quickly. So for example, we can have, this is a dimensional reduction thing, but most importantly, I'm using Panel, which is an interactive Python project to have self-contained applications in the web. I'm switching from Matplotlib to Bouquet to generate the same chart. I'm here using still PyScript to use NetworkX integrating with d3.js. So if you don't believe me, essentially this is the code of the application. There you go. So I'm importing d3 here. I'm just setting that my application needs NetworkX, and this is the full code. So I'm importing NetworkX, I'm importing d3 from JavaScript, and this is genuine Python code, and everything essentially works here. The whole thing is actually contained just a few lines of code. A more complex example, so Palpatine is actually happier. We do the same thing, but more complex example. So we have d3, and we can change different graphs to have Star Wars social network here. And everything here is actually done with d3, but the whole code is Python. It's not all about data, actually. We also have something else. This is particularly cool. So something we can try on is like that, as in I'm using the webcam directly here. So let's take a picture now. There you go. And now we download it. Of course not. This is all Fabio's fault. Kidding. That's actually me because I forgot a dot there. But actually, I can fix that later. But now we have the picture. Thank you very much. And what else? PyScript is actually evolving in an ecosystem right now. So we have in technology preview different background interpreters, runtimes. So it's not just Pyodide, there's MicroPython also running in the browser, and you can switch between the different backends. So for example, here I'm running Pyodide, And you can see from the spinning wheel, and you can see is 3.10 Python. This is for a specific, is linked to a specific version of PyDide, or you can switch to MicroPython, and essentially is MicroPython running in the browser. So how to get started? Meet the PyScript bunny. So this is the official logo of PyScript.com, which is something I'm going to present to you in a second. This is the logo of PyScript.com according to my colleague Antonio. In fact, internally, we decided that we should use probably this logo for him. And so this is a public shout out to the wonderful PyScript and PyScript.com team. There's a bunch of a few people, some of those are anacondics, but not all of them. PyScript, by the way, is an open source project and open source community governance. And so let's talk about PyScript.com for a bit. PyScript.com is a project Anaconda launched recently, and it's free of charge. It's in beta right now, so I'm very recommending you to try it out. It's a very useful project to start with using PyScript. So PyScript.com essentially is offering you a dashboard, and you can create your own application. And by the way, this is the camera example I was working before, so let's have a look at that. So in PyScript.com, you'll have everything is ready, and I just need to add a dot here to fix my bug. I can save it and run it. And now, this is the preview. I start my camera, I take the photo and download it, and it works. And that's my finger, of course.
Thank you very much. And what's next? I think next, I feel hungry, so next is Pie dinner. So, woo! I'm not sure where is Pie dinner. Can someone tell me where's Pie dinner? Organizers, please. Huh?
Okay, so the Pie dinner is in Taverna degli Assi, which is a place that's basically across the river, up there, not too far away. Have your QR code ready and see you there.
See you all at Pie dinner. Woo! Thank you so much.